Hey guys, and welcome back to another video, or should I rather say course, because that is what it is. As you can probably already tell from the video length, I decided to really give something back to all of you who have been supporting this channel for such a long while now, by just also giving you a full course like this for completely free, which will specifically be about Compose Multiplatform, because I also know that this is currently a very hot topic in the community, and that there are not that many resources about Compose and Ktor Multiplatform yet, especially when it comes to building full apps from scratch, which is why I decided to change that. So no matter if you've never worked with Compose or Ktor Multiplatform before and now want to get your hands dirty as an Android developer maybe, or if you've already tried around a little bit, this video will be for you. Specifically, we will build an app that involves things like talking to a remote API in Compose Multiplatform that involves a local database with Room. We'll build an app that involves animations, that involves navigation transitions in our shared code in Compose Multiplatform, and that works for 3 platforms, so Android, iOS, and desktop. And the first step, let me just show you what we'll build, because it will be an app called Bookpedia, so a book searching app. As you can see, we have some default search here set to Kotlin or whatever you prefer. We can then scroll through dozens of books. You can see not all of these have covers. These come from an API called Open Library, which does not require any form of authentication, so you can just talk to it. You don't need to register for an API key or so, which is really great. But when we then tap on a book, we get to the book detail screen. We get a nice blur effect here for the background. We can actually mark it as favorite, as you can see, which I already did for this Kotlin programming book. We do see the rating, the amount of pages, the languages, and if there is a description that the API offers, it would also display here. If we go back and actually take a look at our favorites, we can also swipe here. You can see there is our just marked book where we toggled the favorite option. But we could also search for something completely different, like Harry Potter, for example. It searches automatically, fetches all those books from an API, and there we go. Here are all of those Harry Potter books. If we click on one of these, then there we go. Again, detail screen. You can see Harry Potter supports a lot of different languages, and here we also see an actual description for this book. We can then toggle it as a favorite, which will be saved in a local database using Room, which supports Kotlin Multiplatform already, and then in our favorites, we can already see our Harry Potter book. Since it's Kotlin Multiplatform, this whole thing of course also works on iOS. As you can see here, I am on an iPhone simulator. In order to actually run this on an iPhone simulator, you need a macOS. But even if you are on Windows here and you want to learn Kotlin Multiplatform, then feel free to follow through this video because you will put pretty much all the code of this app inside of Android Studio, inside of Kotlin files. You just won't be able to run any iOS code on an iOS device. If you are on macOS, you can also launch the iOS app like here. You can see it looks pretty identical to Android. We also have our favorites, and we can also search for something else like Harry Potter again. It will search, and then we will see our Harry Potter books with a few nice animations. As you can see, we can click on one, and there we go. Here we have our book with the description. And to also show you the desktop variant, as you can see, this also works. This will work on macOS, this will work on Windows, so on all viable desktop operating systems. And here we can also expand this window and then just scroll through this list. I always have to remember that on desktop we actually scroll with a mouse wheel and not by dragging. But with a mouse wheel, it works perfectly fine. We can also click on a Kotlin book, mark this as a favorite here, for example, and then take a look at favorites to actually see this book that we just marked as a favorite. So this is the multi-platform app that you will learn from scratch, except a few utility classes that I will show you in a moment, by following this single course. So what do you need to do to actually follow through this course? Now, the first thing you need to do is to actually clone or download the initial code that I share down below in my GitHub link. So you can either directly clone this repository into your IDE, or you can just download it as a zip, extract it, and then open in Android Studio. In this initial project, I've already included the dependencies that we will use. So you will find this here in under Gradle, libs.versions in our version catalog. So here you'll find all those dependency versions that we will use in this course. So you can see Kotlin Coroutines, you can see Kotlin serialization, navigation. We are going to use Koin as a dependency injection library. We're going to use Ktor 3.0 here as a networking client. We'll use Coil 3 as an image loading library and image caching library. So we also keep offline access to all those book images and book covers. KSP is for code generation for things like Room. Then we have SQLite, which is used in combination with Room in order to just implement a local database. And down here you will find all those library versions for those different libraries that I've just talked about. Down here we have a few plugins. You can see Room and KSP and serialization comes with separate plugins. And here we just summarized a few in bundles, so we can add those dependency versions together with a single call. Then in our main build.gradle file, which you will find in this Compose app module, and in a moment I will also say something about what all those modules here are, what kind of code we should put in them. So in case you're new to Kotlin multi-platform and this confuses you, no worries, I will go over this in a moment. But let me just complete what is contained in this initial setup. So here in build.gradle, this is the main Gradle file in which you can configure our builds. You can see I've added a Room schema directory, so where our database schemas are actually stored. This is a requirement from Room. I've added Android-specific libraries, so the Android-specific Koin imports. Here, common main dependencies is for our shared dependencies that belong in our shared code. So things like Koin for our shared code, things like Coil, Ktor, and so on. We have one dependency that is specific for desktop that I've added, which is OKHTTP, and the Darwin client for native, so for macOS, iOS, and so on. I'm also say something more about this in a moment, but the last thing that I've added is something you will find in common main, Kotlin. And here you can already see a core package in which there's a domain and a presentation package. And I've just added a few very needed utility classes where I decided to not create these from scratch in this video because I have dedicated YouTube videos about these classes. For example, this result wrapper class, which is really just used to have a class that wraps around, for example, a network result. We load some kind of data from the network, from our open library API. If a network call was successful, then we will just wrap this in a result.success. We pass our data, so for example, the successfully loaded book. And if something failed about that network call, we will instead return a result.error with a specific error code. And then here we just have a few utility functions to map a result, to convert this to an empty result, and to just have some nice listeners for on success and on error. But for these utility classes, I will also link references to my videos below. So in case you're curious how I get to this code, then feel free to watch these explainer videos just about these topics. And of course, I'll explain what happens once we get to the part where we actually make use of these classes. Next up, you will find a UI text class here, which is also just purely utility, which allows us to create references to string resources across our app, also in view models, in any file pretty much, without requiring the context, which is usually needed on Android to unwrap string resources. But that's also something I will say more about when we get to using these classes. And lastly, you will find a colors KT file, just with 4 colors that make up our fixed color theme here. Everything else will really be built from scratch in this course. Next up, I want to say something about the architecture that we will use. So you already have an impression of how we will structure this app in the end. I will intentionally structure this in a way that really scales, that is meant for larger apps, even though this is not strictly a large scale app. If we just have 2 screens here. But since this is typically what people want to learn, how I would also structure a larger app, I want to show you this approach here. So specifically, we will have 3 layers: presentation, domain, and data. And these layers we have for every single feature. Since again, this is a rather simple app, we will only have a single feature. So whenever you have a list and a detail screen, that is pretty much always part of the same feature. And if you maybe have problems deciding what would make up a feature in an app and what belongs together in a feature, so which multiple screens make up a feature, what helps me to always think about is, would I be able to extract a certain screen out of this app and reuse that in another app without requiring anything else from the app I extracted it out of? So when you're, for example, thinking about, would this book list screen here, would this be a full feature? Well, not really, because when you click on a book, then in pretty much every case, no matter where you use this book list screen, you would want to display some sort of details. So the detail screen and the book list screen are actually pretty closely coupled together. However, if you then take this book list screen together with this book detail screen here, these in combination you could very well reuse in a different app. Imagine you would have a different app which would also require a login system where you would have to log in order to see these this list of books, the details about that. Then both the authentication feature, so with the login and registration screen, and the book feature would be their own features. Because the authentication feature does not really need to know where you navigate after logging in. This could be a social network app, this could be a book list app, this could be any type of app that requires a login. And the same counts for the book feature here, because it doesn't need to know where a user comes from when they see this book list screen and detail screen together. But if you use a book list screen somewhere, then it certainly also comes with a book detail screen. So I always try to think about how self-contained a single or a set of screens would be, which helps me to decide what would make up a feature or not. But that's not really the idea behind this architecture that I typically use for apps, that we will have one root package per feature. So in this case, as I said, we will have a book feature, which bundles a book list and book detail screen. And inside this book feature, we will then split this based on layers. So we have presentation, which contains all the references relating to UI for this particular feature. So that means the actual UI components, that means the view models, which have the responsibility to actually update state and keep state. We then have a data layer for every feature, which, oops, that was the wrong place. A data layer inside the book feature, which just contains anything regarding data. So our network client, our repository, our local database. If you would use some sort of external library that can be seen as an API, this would also go in data. If you would talk to system services, like if you would fetch location coordinates, if you would talk to the device sensors or so, all that where your app is actually talking to some kind of external service, external API. So it has to retrieve data from a place that is not coming from your app directly, then that goes in data. And the last layer we will use is the domain layer. Domain layer in this architecture is the innermost layer. So the direction is actually like this, that we have our presentation layer with an arrow towards domain, and then an arrow from data to domain. So that's why domain is called the innermost layer, since both presentation and data are allowed to access references, or allowed to access classes and files and functions from domain, but not the other way around. So domain is not allowed to actually access something from data directly, so an HTTP client, a reference to a database, and it's also not allowed to access something directly from presentation, for example, a view model or a composable. The reason behind this architecture and why the directions here are really as they are is that we want to keep frequently changing code, not have impact on less frequently changing code. And if you think about what is frequently changing code, well, those are so-called implementation details. So really how your app achieves something, how your app retrieves data. Is that with an HTTP client? Is that with a local database? Is that with WebSockets? And things like, how does data communication actually work? Is this with JSON? Is this with XML? How do you actually transform JSON with which library? All those are implementation details because they describe how you achieve specific results, how you achieve that data in the end is displayed in the app. All these implementation details are part of your data layer. And these are just things that change much more frequently in the real world than what your app actually does. So what problem it solves. Because typically in the real world, the changes you as a developer commonly face are things like, hey, the backend team actually changed a JSON field name. Please update that in the app. Things like, oh, this HTTP library is actually not ideal for our use case. Let's migrate to another one. Things like our database schema needs to change. Let's also fix that in the app. These are very frequent changes. And with this architecture, we achieve that these frequent changes won't have an impact on the rest of our app. Now, the domain layer contains really the core of our app, the core rules and the core logic. Some people call that business logic. So if someone would really just have access to your domain layer, they should be able to tell which problem your app solves. On the one hand, with the business logic they will see in the domain layer, and on the other hand, with the business models or the domain models. So those are typically just data classes that bundle some data in Kotlin, like in our case, a book model. In general, an Android app has no idea what a book is because that's a concept from the real world. But in order to give our app context on what a book is, we would make that a book model. And since it's such a fundamental concept in a book app, this would be a domain model. If you had a social network app, for example, then you would have models like a post, a profile, a comment maybe. because those are all concepts that are not immediately clear when learning about your app. And the most important rule for the domain layer is that it's really completely isolated. We don't want to use any third-party libraries in there. We don't want to have any references to our other layers, as you can see with these arrows. It should really just contain pure Kotlin code. And lastly, we have our presentation layer. So as I said, this contains our UI components, the actual composables, things like UI models. Sometimes if you have a very UI-specific way of displaying something that just differs a lot from the domain model. For example, if you heavily need to make use of formatted dates, a formatted date in the end is only useful in our UI layer. So it can make sense to have a separate model for that. The presentation layer contains view models, so the logic how and in which case UI updates. So this is really our layered architecture here, and the reason why we have these feature packages and these are then split into these different layers is that we really keep our features self-contained again. A typical mistake a lot of people make, especially when it comes to scaling apps or apps that need to scale, is that they have these layers as root packages. So you have a data, domain, presentation layer inside of your app's root directory, and then in there they put all their features code. But this would not be reusable at all, because you would have to reuse the whole presentation layer of your app, the whole domain layer of your app from all features, and there would rarely be a use case for that. So I really always structure my apps in a way that I could also migrate the structure as it is to a multi-module architecture, which I never start with, by the way. But if I would want to migrate to a multi-module architecture at some point, I would really just need to make single modules of these layers and of pretty much any package inside of these root packages. You've also noticed that we have a core package already. So core is also structured in the same way that we have presentation, domain, and later on also data. This will just contain the code that is shared between multiple features. So typically utility, or if multiple features would need to access the same model class, you would also put this in core. We'll play a smaller role here in this course, since we only have one feature. If you want to learn how this works with many features, then I will also link down a course of mine, the Android Essentials course, where I really build a larger scale multi-module running tracker app. Okay, so that's it about the architecture. The last thing we need to talk about before we get to the actual source code is that we also want to celebrate the release of Ktor version 3.0. So just very frequently, Ktor, our favorite networking client that we can use for Compose Multiplatform, that we can use for Android, was updated to 3.0. So there was a breaking release, a breaking new change. And that's also why JetBrains is the sponsor of today's video. So thank you, JetBrains. So that's of course also why we want to use Ktor version 3.0 here. As you can see, the changes of this version are on the one hand that we get a better performance. According to JetBrains, the performance of Ktor 3.0 is 30 to 90% better than for Ktor 2.x. This was achieved mainly because they switched to the Kotlin X.io library, which is a rather low-level API, so how Ktor manages all those data streams in the background. This is also why this is a breaking change, so why the first digit of this version actually increased. Because if you are using these low-level APIs in your app, then this is a breaking change, so you might need to fix your project. If you're just using Ktor normally by making HTTP calls and without actually working with byte streams and all that stuff, then this should not be a breaking release for you. Then what else is supported is server sent events now. So server sent events are pretty much the opposite of an HTTP request, because with HTTP requests, we have a client that pulls the server for new information. So we ask, okay, hey server, can you give me this information that I'm asking for? Can you give me this list of books? While with server sent events, it's the opposite way. There we have a one-way connection from the server to the client. So instead of the client pulling the server is able to send new updates to the server in form of events. So instead of the client always asking for data, with server sent event, the server will send new data to the client in form of events when it's available. If you want to work with that, that is a separate dependency from Ktor that you can add now, but then it will work out of the box. So you need to set it up, but Ktor does support that now. Then the update to 3.0 brings support for WebAssembly. So if you're working with Kotlin Multiplatform and WebAssembly, so building websites with Kotlin, then you can now use Ktor as a networking client for that, which is of course very cool, since when working with websites, we pretty much always need a web client for that. And lastly, a very cool change regarding Ktor server, so you can also use Ktor as a server-side framework, which I also really like, is that this now offers so-called CSRF protection. So CSRF is a type of security vulnerability where an attacker kind of tricks an authenticated user into making a request with a valid token, with a valid authentication. And Ktor server now allows you to generate a token which really protects your users against this type of attack. And what Ktor server now also offers is serving static zip files. So that means you can provide a zip file at a specific endpoint, and Ktor will provide the contents of that zip file as direct resources you can access from the client. So I think this is pretty exciting, especially where all these changes with Kotlin Multiplatform, Compose, Navigation Compose, Ktor, all those new products from the JetBrains ecosystem will lead in future. I really hope that in future we really have a viable and also established way to build multi-platform apps, to build apps and software for multiple platforms from a single code base and using Kotlin. That would be super cool. All right, let's start with the actual coding part here. So I assume that you've now cloned the initial branch from my GitHub repository from the link down below. Now is the latest point where you can do that. In case you're creating a new Compose Multiplatform project, you can do this here on this kmp.jetbrains.com website, where you can generate such a project, since there is no integrated wizard yet in Android Studio to generate a Compose Multiplatform project. That's only available for KMP without sharing the UI. But as I said, in this initial branch, I already included everything that we will start off with here. And if we open such a Compose Multiplatform project, this is how the structure will look like. So you will have this Compose app module as your root module. This will be your application module, which you can see with this green square here. It's kind of the entry point for your application. And it will then consist of an Android main module, a common main module, a desktop main module, and an iOS main module. At least if you selected those platforms and you want to target these. And our goal with Compose and Kotlin Multiplatform is now to put as much code as possible in this common main module, because this will be the module with our files and classes and functions of that code that we want to share between all platforms. So if we open this app.kt file here, for example, then you can see this is already a composable with some initial logic where you can toggle an image. This is just included in this initial template from this project generator. And since we're using Compose Multiplatform, that allows us to also share our Compose UI, which is why that goes inside of our common main source set or common main module it is. But in addition to that, we sometimes might also want to have certain implementations that are specific to one of these platforms only, or where a specific shared implementation just differs on each platform. So a typical example would be creating a database client. While the logic to interact with a database is pretty much the same on desktop, iOS, Android, the queries are the same. It's on all platforms, it's SQL in the end, but creating the database client just works a little bit differently on each platform. So on Android, we have this concept called the context, which is an Android-specific concept, but the context is needed to construct such a database client on Android. While on iOS, we don't have such context, and we can create a database client in a different way. So this is what these other main source sets, other main modules are here for, so that we can also have a place to implement platform-specific logic. That means in Android main, you have full access to all kinds of Android dependencies, to the Android operating system, to Java code, and all that would normally work in a native Android app. Same for iOS, just for the iOS-specific dependencies. On desktop, it's very similar as an Android, just that we can't use Android dependencies, but we can certainly use Kotlin on Java dependencies. And in this common main module, we have the limitation that we can only use dependencies that support Kotlin Multiplatform. But nowadays, luckily, for pretty much any common thing, there's already a library that supports Kotlin Multiplatform. So I would say we get started with the absolute core of our app, so our domain layer, because you first of all need to, of course, define what kind of problem our app actually solves. In our case, to be able to search through some books. The next step would then be to start implementing the UI layer for our first feature. In this case, when we have one feature, as I said, so for our book feature, but the UI layer, let's start off with just defining that for the first screen, so for the book list screen. And then after that, as a last thing, we get to the data layer to actually be able to load books from our API and then also save these locally. I always start off in exactly that order because on the one hand, building our UI typically involves our domain models. So if we want to show a list of books, then we need a book model somehow. So we want to start with this book model, but then we can freely implement the UI without actually being blocked by anything else. And we can already test that whole thing. Because if we would start off with our data layer and first of all start implementing the HTTP interaction, if we would implement our database interaction, our database client, then we could all do that. But if our data layer would be finished, we would not have no real use with that. We couldn't test that because there is no way for us to actually interact with our app since we are missing the UI at that point. If we do it the other way around, we already see what we actually built, so our UI. We don't need any actual data from our database or API for that. We can just work with dummy data. And then when we then get to implementing our data layer, we can immediately test that since the UI is already set in stone. So let's go to our book feature here. Open up our domain layer because, as I said, we want to start off with a book model. So that will be our innermost domain model here, which is nothing else than a Kotlin data class. Yes, I want to add that to Git. And then we can start to think about what a specific book actually offers, what a specific book consists of, which data does it bundle. This is in our case just an ID in form of a string. Those IDs just come from the API later on, and the API just uses string IDs. It certainly has a title, it certainly has an image URL for our cover image. It might have one or multiple authors. So we will have a list of strings here for all of the authors of a book. It might have an optional description, so a nullable string, since not every book has a description that the API provides. It might have some languages, which is a list of string. It might have a first publish date. Well, let's make it first publish year, which is optional and a string. It will have a rating average. Let's actually call it average rating, reads better. Average rating, which is a double, also nullable because not every book from the API has such a rating. It has a rating count, which is a nullable integer, also not provided for every book. It has a number of pages, so let's call it num pages, integer, nullable, and a number editions. This one is not nullable because the API apparently provides this value for each and every book. Okay, and this is our very first domain model. It really just contains information about what a specific model, what a specific concept consists of, what kind of data is bundled here that makes up a book. And if you now have a different type of app that would also deal with books, like let's think of an ebook reader app or so, then the domain model of a book might look completely differently for that different app. Because for an ebook reader app, you would certainly also need to know what is written on each page. That's not relevant for this specific app that we built here, but for an ebook reader app, it would be necessary to know that. And this is really the idea of the domain layer, that we can take a look at it and we see, okay, this is actually the problem that our app solves. This is its business. And here we really don't want to include any references to third-party SDKs, to any annotations that come from libraries. So you would not want to use something like serial name here, for example, to indicate how a certain field is called in the JSON response that comes from the API. Because this again would couple the domain layer to an implementation detail. Implementation detail would be how the JSON field name is actually called, and that we use JSON in the first place to encode and decode data. So all that should not be part of domain. I will show you later how this works with this architecture, but here we really only want to use raw Kotlin code. And now that we have our core domain model, obviously you could have multiple domain models in another app, but here we really only have this book model. Now that we have that, we can jump into our UI for the book list screen. And the way I typically structure this is inside of our feature, we have a presentation layer, which just contains our UI logic, our screens, and so on. In here, for every single screen part of that feature, I create a package that is called how the screen is called, so book_list. And in that, we will now put everything that belongs to this book list screen. On the one hand, that is a book list state. So here in this course, I will specifically stick to the MVI architecture. So MVI stands for Model View Intent, and that is an architectural design pattern that decides about how our presentation layer is split, how we structure our presentation layer. And with MVI specifically, what it says is we have our UI, so the actual view, which is in the end just our composable here. Then we have our view model, So that is the unit that actually decides about how and when state is changed. MVI specifically bundles the screen state in such a data class here commonly. So we just have a single screen state that we need to observe in our UI. And then the I about MVI, so the model view intent, that corresponds to a bundled class, a bundled sealed interface, it will be in Kotlin, that contains all those UI actions, all those things a user could do on a screen that we might want to send to the view model. For example, clicking a button to save a book in favorites. For example, to just select a book and open the details. For example, to change the search query. All of those things that are changed as a result of a user interaction would then be bundled as such a sealed interface, which you can then send to the view model. So this is the intent about MVI, the intent the user has with a certain action. And here in this book list state, we now just bundle our state. So all kinds of values that could change over time and have an impact on our screen, on our UI. On the one hand, the search query, for example, because that can obviously change when we type in a new search query. The default one here in our case will just be Kotlin. We then certainly need some search results, which is a list of our books now. Initially, it's an empty list because we have not loaded any data yet when we initially open the screen. We do need a list for favorite books. So a list of book again. Again, an empty list. We want a Boolean, whether we're currently loading any books. So we can show a progress indicator. We need an integer for the selected tab index, just an integer, and initially it's 0. So the first index, just as a bit of a recap, let's open the app again. So you can see we have 2 tabs here for search results and favorites, and the selected tab index will just highlight the index of the currently selected tab. So either 0 or 1. And lastly, what we need is an error message. So in case something went wrong, we want to show some kind of error here. This will now be a UI text here. Initially null, because initially there is no error. But what this UI text now allows us to do is, which, if you remember, comes from our core package, presentation UI text. It allows us to either make this a dynamic string, so just a normal string, nothing else, or to wrap this around a string resource ID. So string resource IDs are in the end just references to our string resources, which then later on allow us to also localize our app, translate it to different languages. And if you want to support that and make it easy later on to localize something, we have to work with string resources. However, the thing is, we can only unwrap string resource IDs in our UI so that we look up which specific string is behind a certain ID, but we still might want to actually create strings based on string resource IDs from within our view model, where we wouldn't be able to unwrap these. And this we actually solve with this UI text class, because if we then want to pass a certain error message that comes from our string resource, we can return this in our state in our view model by saying, okay, UI text.string resource ID, we pass in unknown error, for example, but coming from the string resources just as an ID. And then in our UI, where we actually have access to things like the context, which is needed on Android for that, there we can very well then deconstruct and unwrap this string resource ID here again by making use of this string resource composable. So it's in the end really just a convenient way for us to work with string resource IDs from within a view model. The next thing we need before we can get started with the actual UI for our book list screen is our intent. So the actual sealed interface that I talked about that bundles the different actions that we could perform on the book list screen. This will also go here in presentation book list and will be called book list action, because this is a sealed interface encoding all those different actions a user could perform on the screen. It will be sealed interface, so we just have a limited set of actions and options in here, and specifically what can change on the screen that the user has an impact on. On the one hand, we can say on search query change. We pass in the new query, so the new text of our text field, and this will be a book list action. Then we have a data class on book click. So when we just tap on a book, we want to pass in the book that we clicked on, book list action again. And lastly, when we actually switch the tab, so on tab selected, then that will also have an impact on our state. So we want to pass in the new index and also make this a book list action. What's important to consider here is design-wise that the UI is not responsible for deciding what should happen after such a user action. After the search query changed, after clicking on a book, That's not the responsibility of the UI, but it is the responsibility of the view model. So we should really also call our actions that way, that they really just contain the information, what happened, that the search query changed, that we clicked on a book, but we should not call them based on the result they will lead to later on. So that we actually trigger a search. So we should not call them open book details. We should not call them switch to different tab or so, but rather just call them what happens. And the view model's responsibility is then to decide that. This really keeps our UI and the view model decoupled. So even if you would use your screen with a different view model, you would not need to change anything about the naming here. So next up, let's create this view model. For now, really just a blank view model. We won't put any logic in this, but really just have our state there, have our function that receives these actions, so that we have something to work with in our UI. So this will be a book list view model. Make this a class, inherit from view model. This comes from the JetBrains Jetpack dependency. And in here, we can then declare our state. So private val underscore state is a mutable state flow. So this is typically what I like to work with when dealing with my states. So there are also other options like using compose state directly here in the view model, which is also viable. But I feel like state flow gives us a bit more options to work with, because it also allows us to work with reactivity by chaining and combining multiple flows. And it makes it easier to update state in a thread safe manner, since it provides a function for that. The default state here will be our empty book list state. And then we will have a public immutable version of this state, which we can create with state as state flow. So that's typically what we do, that we have a private mutable version of the state that the view model can mutate, but the UI should not be able to mutate the state directly, but rather send these actions to the view model, so the view model can do that. That is why we have these two properties. Then we will certainly expose a function on action, where the UI can then pass a certain action to the view model, which you can then unwrap here with a when expression. We can hit Alt-Enter to add those remaining branches and leave these empty for now. Maybe for the search query, this is an easy one. We could already implement this. So here the view model really just responds to those actions. When the search query changes, the view model's responsibility is now to update our state and just update that search query. So we again observe this in the UI and then see this update. So here we would say state.update. So update is this function that updates state in a thread safe manner. So you can safely call this from multiple different threads on the same state object and won't run into any race conditions. In here, we then use our existing state. We copy this and we set the search query to our new search query that comes from our action. And that's how we update state with this architecture. Same thing would apply to our tabs. So here we wouldn't update our search query, but actually our selected tab index to the new index. And everything else that is about searching through books and all that stuff, that comes later. So now that we have our very basic screen structure, at least everything that we need for our book list screen, let's create our root structure for our book list screen. So here, new file, call this book list screen, simple file, and we make this a composable book list screen. Something that I always do for composables, that I can only highly recommend you to do, is to not work with just a single screen composable. So what I often see people do is they now include the view model reference in here, coming from Koin view model, like this, so that in this screen composable, they can directly observe state from the view model and also trigger this on action function we've created. However, the thing is, especially if you use DI like Koin, which will inject a view model during runtime, this won't work for previews. So the preview is not smart enough, the Compose preview is not smart enough to actually inject such an instance, to actually have a real instance of this view model, because that would come with all your other dependencies, all your other classes that you might need for this view model. So a repository, a database client, an HTTP client, and the preview is simply not capable of all that. It's simply meant to preview simple UI or to preview just UI. So instead of doing it like this, what we want to have another composable, which we call book list screen root. And what this composable will get is, this will now have the view model reference. Furthermore, it will provide a lambda on book click that we provide in here. And all this root composable will do, well, all this is responsible for, is on the one hand, collecting our state. So we can say val state by view model state collect as state with lifecycle. And then it calls our subcomposable, our book list screen, where we now don't want to pass in the view model, but really just our raw UI state. And we will provide an onAction lambda, which takes in these book list actions. And we don't need a modifier here for this one, since it's a screen composable, which will always fill the whole size of a screen. So this way, we can say the state is the state we observe here. The onAction lambda is simply our view model, double colon onAction. So we just forward all these actions we bubble up with this onAction lambda here in this screen to our view model reference. Or we actually listen to these specifically, since here we also want to bubble up these on-book click events specifically, since in that case we need to navigate. And if we don't have access to our nav controller here in this composable, we don't want to have access to that. Same reasons with the preview, but we rather want to just bubble these up to our nav graph so we can do the navigation transition there. So in here, where we get access to all these actions, we can check when that action is book list action dot on book click, then we just trigger on book click, and we actually pass in the book we clicked on. So we also need to pass this in here. And then we can also get rid of the modifier, I would say, yes. Then we can say else, we just don't do anything, and all actions, no matter what that is, we just forward to our view model anyways. So we really just intercept these actions kind of here if we need to handle these in the UI directly, since clicking on a book is something we wouldn't handle in the view model, since there we don't have access to our nav controller. But if we structure our screens like this, and you can really always structure these like this, you can now put this composable in your nav host, which gets the view model, which has all those lambdas that would have an impact on navigating. But this way, our actual screen composable, which contains the actual UI, is completely isolated. But this would now be much easier to test in an isolated UI test, because we just need to provide some sort of instance of our state, which we can just construct in the preview. And the lambda is also very easy to construct. It can just be an empty lambda. So we don't rely on a view model reference anymore. And that's exactly what we want to achieve. In this case, we can also make this private, since we don't need this anywhere else. This one needs to stay public, since that is what we will add to our nav host. So what comes next? Let's take a look at our UI. And the first step when I structure a screen is I try to think of reusable components. So which parts of the UI would actually make sense to extract in a separate composable. So here, what would make sense is certainly our search bar and possibly each list item, and maybe the list as a whole. And that is what we'll start off with. So we'll first of all define a composable that just defines how our search bar looks like. Then we will work on this tab view, tab layout, so we can also swipe here. And lastly, we will then work on these list items as well as the list itself. Starting off with the search bar. When I have such reusable components that are still specific to a screen, the way I structure this is in the screen composable, I simply create a composable or components package. So those are just components, composables specific to the screen. If I would have components that would be shared between multiple screens, still part of the same feature, I would create this components package here in the presentation layer outside of this book list package. And if these components are actually shared between even multiple features, I would put them here in core presentation. So this is how this would really work with this architecture. But here we just need the search bar on the single screen. So we can say, let's just call it search bar or book search bar. Make this a composable book search bar. What kind of parameters does it need? Certainly a search query for displaying the right text. It provides an on search query change lambda. So whenever it changes, it will bubble up the new search query here to the parent composable. And it will provide an on IME search action. What this will do is, well, it will trigger the search when we tap that button on our keyboard. So if we take a look here again and we want to type something here, then you can see on the one hand, it will trigger when we just wait for 500 milliseconds, but we also have this search button here, which can trigger a search when we would have typed something else, and we will trigger this lambda in that case. All right, let's get started. Sadly, the Android Studio does not yet support previewing Compose Multiplatform composables, so this is not possible. At this point, it probably will be at some point, maybe when you're watching this video. You can just put a preview annotation and a composable down here and this will work. You can get this to work already if you're using JetBrains Fleet, which I haven't used excessively yet. I've tried it out just when it came out, and Android Studio was superior at that point. Just because it's much more mature, so it's expected, it's a preview version. But that is why I sadly can't offer you a preview here in this file. We can hack our way around that by putting the preview in our Android main module, since for Android apps, the preview is supported even for Compose Multiplatform composables. But that is a limitation we have to accept as of now. So in here, we'll put in an outlined text field, which we'll make use of here. I think we need to, we need to provide a value. So our search query, we need to provide an on-value change lambda, which is on search query change. And that itself would already make up a working text field, but it would look quite ugly. So if we would want to preview this, we would go to Android main, Bookpedia, create maybe a previews file, create a preview here, say, okay, book search bar preview. We would have our material theme in here in which we put our book search bar. So in these platform-specific modules, we have full access to our common main module, so to all the shared code, but obviously not the other way around. So from common main, we can't access Android-specific code directly. So if we go in here and we provide a search query like Kotlin, if we have an empty lambda for when the search query changes, just like when we trigger the IME search, we can give this a modifier of modifier, fill max width, then we should be able to see something, build and refresh. And yes, there we go. By default does not have a background. We could fix this by giving this a background color of color.white, for example. Not that one. Let's give it a hex code like this. And then we would have a white color. No, for some reason it is not working. Well, then we can also leave this here. I mean, we see that it works. We can maybe give this composable a background color with the modifier. Color white. Why is it using these old colors? I want these compose graphic colors like this. But that apparently also doesn't do anything. That doesn't matter. Let's just move on. But this is how we could preview something from Compose Multiplatform. So I think for the more complex composables, we'll also do this here in this course. So if we now proceed with the outline text field, we can also open up here our reference text field. So we actually see what we want to build. The shape certainly needs to be a pill shape. So we can say rounded corner shape, passing in 100% of rounding. We want to give this colors. So I'm going to style this a bit differently by saying outlined text field defaults, it's actually called. Not sure why it doesn't have the dependency. Colors, text field colors, text field defaults dot outline, that it is. Outline text field colors. And in here, we will have a text color. Well, actually, the text colors can stay at the default. Since we have a white background, it will just be the on background color, I think, from our theme. But let's change the cursor color to our dark blue from our colors file, as well as the focused border color to something like sand yellow. So you can see the sand yellow color here is the border color, and the cursor color is this dark blue one. Something we might also want to pass is a placeholder. So when there is nothing here, then we will include the search text, placeholder, make this a text. And here we actually want to use string resources. So we say the text is a string resource, where we say res from here, this resources. So this is how these shared resources work for Compose Multiplatform. res.string.search hint. And I'm not sure if we can create these with Alt-Enter. No, we can actually do this for Android resources, but not for Compose Multiplatform, as of now at least. So let's create these manually by going to common main, compose resources. That is where these are located, like for example, a Compose Multiplatform vector. And if we would want to create string resources, we would create a values directory. And in there, we will create a new file called strings.xml. Make sure to have the same namings so Compose can actually find these resources. Here, first of all, we want to add this XML metadata. Encoding can be UTF-8. And then we will have a resources tag. Don't worry if the autocompletion doesn't work here. It's just a bit atypical for Android Studio that we put our resources in a random folder, since Android Studio is not that closely coupled with a Compose Multiplatform yet. Nevertheless, we can make this work by having string resources in here, where each XML string needs a name. So just the string resource ID. So for example, what is this? Search. And the text will then be search. Let's call it search hint, actually. Is a bit more expressive. So here in book search bar, we can now say res string search hint, which is not available because those resources are actually generated after a rebuild. So what we can do is we can click on make module, and this should hopefully generate the corresponding Kotlin and Compose Multiplatform classes that implement this string resource-like behavior and also would allow us to localize this app. You can see my rebuild actually failed because we need to import this. So it's what Compose did is it generated a separate class, which is not included by default. But once we import this, then it will be recognized, and a rebuild should now also succeed once we did. This is actually much faster once we rebuild our project once, so these incremental rebuilds will not take that much time anymore. But in my experience, the first rebuild of a Compose Multiplatform project can take ages, at this point at least. All right, next up, we have a leading icon, which will be the leading icon. Let's take a look. So in this case, it will be this search icon, which we want to display here. So just icon, where we say, okay, we got an image vector, icons.default.search. There's already a ready-made icon for that. The content description can be null here. And the tint of this can be our material theme, this one, .colors. Is it actually, that looks a lot like material 2, but why don't we use material 3 here actually? I'm not sure, didn't I include this dependency? Let's quickly take a look. Because with material 3, it would actually be called material theme dot color scheme instead of colors, which is a bit odd. Let's take a look at our version catalog. We do have our, where's Compose? Is there any reference to material 3? No, didn't I include that? I think for Compose Multiplatform, it's already coming from the Compose Multiplatform framework. So we need to change this here in build.gradle of our main module. And here you can see there are certain dependencies that come from Compose. I didn't add those myself. Those already come from Compose Multiplatform from the Gradle plugin. If we switch to material 3 here, this should hopefully fix it. We might also need to re-import these UI components, but just making sure that everybody of you gets the same outcomes here with these components. Let's make sure that we all use the same material version. This way, after syncing, we should probably get some errors here in book app search bar. Yes, because we need this new import, you can see, from material 3. Alt enter to do that. And now it's actually here, this one we also need to import. And now it's actually also called differently, which I thought at first. Here it's now outline text field defaults dot colors. And then it will do the same. Also need to do the same for texts. Not the one from Ktor here, but the composable. Need to import this icon from material 3 this time. And now we should also be able to set the tint to our material theme color scheme. There it is, that on surface. And we give it an alpha of 0.66f. So then we get this grayish effect here. In between, we can also just optimize our imports or remove these here manually. And then take a look in our previews. Where is that? Previews here. Maybe we see something here. Need to re-import the material theme here as well. It seems we would need this dependency for the Android side as well. Then let's ignore this and just show this search bar for our preview as it is. Reload this. And then we also need to actually fix this here. This is actually just the standard app composable here. We can get rid of all that. This is really just the standard initial code that we don't need in our app. We can optimize all those imports. Take a look if this is now fixed. Yes. Now we can actually see an actual search bar here. And for the background color, we could also put this in a box. Modifier fill max width. Give this a background of color.white from Compose now. And then put this in here. And yes, now we also have a much more decent preview here. If we don't have a search query, then you will notice, or if we actually make this empty, then we should see our placeholder. Yes, there it is, search. So we can go back to our book search bar and continue working on it. What else is important for this text field? Well, we certainly need this to be single line. So we set single line to true, so we can't have any actual new lines there. We want to trigger our IME search action by saying keyboard actions is keyboard actions on search. This will simply be our IME search. Seems like we need to create this lambda here and then trigger on IME search. So this will be triggered when we click on this green search button here. And when we then type something here, you will notice that this close icon actually fades in and fades out. We can achieve this with a trailing icon this time. In order to make it fade in and out automatically, we can work with an animated visibility, where we say, okay, the visibility actually changes based on our search query not being empty. So if it's not blank actually, then we want to show the icon, otherwise we don't. And whenever this changes, we will animate the transition. In here we can then have our icon button. When we click this, we will simply call our onSearchQuery change and pass in an empty query. So we just say, hey, the search updated with an empty text. When we say we have an icon with an image vector of icons, icons.default. What is this? Close, yes. Content description would be a string resource, r.string, and we pass in our close hint. Actually not R, it's res here in Compose Multiplatform. Close hint, and I think we still can't create this here from the context menu. No, let's then go to our strings XML. Here we now just need to copy paste this and make this a close hint and say clear search or so. This is really purely for accessibility reasons that we give our icon button here a clear content description so that screen readers could also kind of read what the button is for. So even blind people also could use this app in some sense. We can then give this a tint of material theme, color scheme on surface. This time we give this a full on surface color without any alpha value, because this is really meant to be interactable and should be a prominent action. We can then make our module again, and we should hopefully be able to see a valid import for this close hint string resource. Yep, there we go. We probably need to import it again. So this is still a bit annoying about Compose Multiplatform, or at least better for native Android, that we can we don't have to generate resources with rebuilding, but it is what it is, and that is definitely a trade-off we can accept, I think. All right, I think we also need to define that we actually have a search IME action, so that this search button appears in the first place on our keyboard, simply by saying keyboard options is keyboard options, where we say the keyboard type is keyboard type.text. So we just want to be able to enter normal text here, and the IME action would be IME action.search. So this icon actually pops up. When we click it, this will trigger. And the only real thing that is left is making use of this modifier here. Let's do this at the very bottom. Passing in our modifier, we might want to give this text field a background color, where we say the shape of the background is again our rounded corner shape with 100%. So the background is also adjusted to this rounded corners, and the color will be desert white, which we've added previously. And we want to add a minimum interactive component size. So what this will do is, if we take a look at the docs here, it will reserve at least 48 dp in size to make sure that these touch interactions, for example, for this close icon, that there is at least that much space for those for this trailing icon button. So even if the composer would measure smaller, we make sure that we at least have the space for this trailing icon button. And if we now take a look in our previews again, then we should be able to see a fully fledged search bar. After reloading, yes, there we go. Here it is. We could also start the interactive mode, this one here. If we type something in there, you can see our yellow border, our orange border, and we can then enter something. No, we can't because we did not provide an implementation for this lambda here, obviously. A little fun thing we could do is that we also change the cursor color. So you will notice this, not the cursor color, but the text selection color. So when we type something here, oops, right here, test, and we highlight this text, you can see it also marks this in this orange that fits to our theme of our app. We can achieve this by hopping into our search bar composable and saying composition local provider, and we say a local text selection colors dot provides, or just saying provides text selection colors. The handle color will be sand yellow, as well as the background color. Sand yellow. Open a block of code and then put our outline text field in there. So what we can do with this is that we can change the actual value that local text selection colors.current will provide for all the code that comes in here. So those are just typical values you might want to retrieve easily in composables. application white, and all the composables that now come in here will use those provided text selection colors. And we could also easily test this already by going to our book list screen and just adding this new composable here. So we could say we have a column. We say modifier is modifier fill max size. We give this screen a background color of white, or let's actually say dark blue. Not color.dark blue, but dark blue from our colors KT file, because this is the background color of our actual background, and then our column, our list will be drawn on top of that. We give this some status bars padding, so we consider the padding here for our status bar. And we can say horizontal alignment is alignment center horizontally. And in here, let's just have our book search bar, where the search query is now our state.search query, where our on search query change will now trigger our on action lambda, where we say, when this search query changes, we want to trigger our book list action. That on search query change with it, so the new search query. So this will be sent to the view model. The view model will then receive this here. It will update the state. When the state changes, since it's a state flow, it will trigger an update in the UI again. So the UI will show the new updated search query in the text field. Then when we actually click on IME search, we're actually not going to perform a real search here because the search triggers after 500 milliseconds automatically. So I think, yeah, that doesn't matter, that we actually need to provide a way to let users search even faster. But what we will use this for is we want to hide the keyboard. So when we click this, the keyboard will be hidden, as you can see. We can do this with the keyboard controller, local software keyboard controller .current. We can then use this in here to say keyboard controller $hide. So we just hide our keyboard. And lastly, let's pass in a modifier. Modifier dot within, passing in a minimum width of 400 dp. Actually a maximum width. So the search bar doesn't become too large, especially on desktop devices. That's always something you need to think of course, if you're building a KMP app that also targets larger screens. So we say the width of this text field will never be larger than 400 dp. We still try to fill the maximum width of our screen, unless that would be more than 400 dp. And then we add some padding, 16 dp for example. And we could already try this out by taking this book list screen composable, going to our entry point, our application composable. Let's also get rid of this greeting and platform, by the way, which we also need to get rid of here for each platform. So platform.android can be deleted, platform JVM can be deleted, and platform.iOS can also be deleted. This is the entry point. So this is the composable that will show up at first. So here we can say we got a book list screen root. The view model can for now be just a view model constructed with remember, since we don't need to pass in any dependencies yet. So really just for this demonstrational purposes. And when we click on a book, we would perform the navigation, but we also don't yet have a nav controller. And this application composable will now be drawn in our normal Android main activity. So if you're an Android developer, this will be familiar to you. You can see there it is. This comes from the shared code. If we are on desktop, we really just have a pure main function, which is created with this application function here, which gives us a composable scope, creates a window, and then also calls this app. For iOS, we have this main view controller, which in the end just constructs this view controller, which is an iOS concept of a view of a UI component, and then also lets us call composables in there. So this way, let's actually run this on Android. Clicking run, taking a look here, and hopefully see some sort of decent looking search bar. There we go, and we do see that. Here's our search bar. We can hopefully change this, yes, because we've already added the logic to update the state. And when we actually click on clear, we can also already clear our text. That is very cool. So what is the next step? Let's actually switch back to our reference app. Next up, I would say what would make sense to implement is a composable for all these different list items. All right, let's take a look at our package structure again to check where we want to put this book list item composable. Definitely not in our Android main source set, because that would be for Android specific UI components or classes in general. We want to put this in common main book list components again, of course, since this is an exclusive reusable component for the book list screen. So here, book list item, for example, make this a file, composable, and we call this book list item. Well, and what does a book list item need in order to display some data? Obviously a book. And we might also want to pass an on-click lambda when we click this, so we can then navigate to the detail screen later on. Let's make this a bit larger again, so we actually see what we plan to build. So we now plan to build such a book list item here, where we can first of all start with this surface around. So this little light bluish kind of background. For that, we can use a material surface composable that is just used to create such a surface. Let's give it a rounded corner shape. So shape is rounded corner shape of 25 dp. Well, let's say 32 dp, that's at least, I think what I used here, 32 dp as a rounding. Then we give it a modifier, so we pass in the modifier we have passed in here, and we make that clickable. And when we click this, we can say onClick is equal to the onClick function, the onClick lambda that we pass to this composable. And the color of this surface will be light blue, the one that we actually defined in our colors KT file, and we say copy and set the alpha to 0.2f. So let's now think about what kind of components and layouts we do need for to just display what we want to display for such an item. So we definitely need a row, because this image here, the book cover, needs to be displayed in a row-like fashion together with a column here, a column of 3 texts. Then we have another row in here for this text and this star icon. And then in this very outer row, in the root row, we then have this final arrow icon. So first of all, let's define this very outer row for the book cover, for these 3 texts, and for the final icon. The modifier for this one will be modifier.padding. First of all, let's add 16 dp of padding. We say fill max width, and we then say height, and we set this to intrinsic size dot minimum. What is intrinsic size? That is in the end a way to give this row a fixed height that is still dynamic in some sense. So if we want to keep our layouts here somewhat dynamic, that the proportions of how much width this image takes, of how much width this text section takes, and so on, if these are dynamic, also based on the screen size of the device, then we need a way to find out which part of this row actually has the highest height. Because if we wouldn't use intrinsic size.min here, then it could be that this text spans more height on certain device types than the image, or the image spans more height on certain device types than this text. And we don't know that yet during development, which of these powers will span over more height. So with intrinsic size.min, we give the height of this whole row here, of our whole list item, the minimum height that we need to fit all of the single children in. So the minimum height that is needed to perfectly fit in the image, to perfectly fit in the text section and the icon here. Because if we then use fill max height somewhere inside of this row, normally without giving this a fixed height, it would just span the whole screen's height, because it would that's how fill max height works. But if we give this row a fixed height by using this height modifier, then it will always have the same height, or at least this minimum intrinsic size. I hope this makes sense. Then for this image, for this book cover, I actually want to put this in a box, because when we load new images, then we have this loading animation here, as you can see, which is a separate composable. We will implement all those animations at the end of the course. So we'll focus on functionality, but we can already think of this aspect when designing this list item, that we just have a box in which we can conveniently swap out the contents of that, so the composable, so either the book cover or the animation. The modifier of this box will be modifier dot, let's give this a height of 100 dp, for example, and we want to make sure that everything is centered in this box. Well, and now what comes inside of this box, if we put the animation aside for now, is this book cover, of course. But as you can see, certain book covers are available, and for some, there is just no book cover available on the API. In that case, we want to display this kind of a generic failure icon or so. So let's think through how we can do this. In the end, our image loading library that we use here is called Koin. That is a Kotlin image loading library that I can only recommend for Compose and Kotlin multi-platform projects, but also for Android. That library is great. And if we want to now observe the current state of the of loading a specific image from a web URL, if we want to do that with Koin, then we need to keep track of that with a compose state. So we say we keep a reference to our image load result. We say that is equal to by remember, and in here we will then have a mutable state of, and the state will consist of a result. And here's important that you import this Kotlin result. For this use case, we're fine with that. We don't want to use our custom result class. This will be a Kotlin result of type painter, and this whole result can be nullable. actually in here, and then we need to close this off like this and make this null initially, like this. We then Alt-Enter to import this by remember delegate. Then we have our very initial state. So the result can either be a successful result or a failure of type painter. So if it was successful, then we get a painter, which we can use to paint or draw an image. And initially, we don't yet have any result. In order to then get the painter, we can say val painter is equal to remember async image painter. That now comes from coil. The model that we have to pass is in the end the image we want to load. So you can see coil takes in anything here. So this could be a bitmap, this could be an image URL, and then coil will figure out how to load this image. In our case, this is simply the image URL of our book. Then we can override this onSuccess lambda, which will trigger when the image was successfully loaded. This will then give us access to this async image painter state.success. But here a little catch is that sometimes the API seems to actually provide an image with no real valid dimensions, so with a size of 0. So I want to make that check if that actually is the case. So if it dot painter dot intrinsic size, so the size of the image, if the width is larger than 1, and the same is actually the case for the height. So height is also larger than 1. If that's the case, if we have a valid image, then we want to say result.success, and we pass in it. Actually the painter here behind this it. Otherwise, if we successfully loaded an image, but it's 1 by 1 pixels, then we want to say, okay, that's actually not a successful result. And we say result.failure, and we can pass in a custom exception here where we say invalid image size or so. What kind of issue does it complain here? Okay, it's not thrown. We don't need to throw this exception here. We really just need to pass it to the failure, so we get an error message. And this whole thing we then need to assign to our image load result. If there was an error with loading the image, then on error will trigger. So this would be the case, for example, if we don't have internet connection. Then we could say, okay, we first of all want to actually print the stack trace of what went wrong. So we get to see the logs if an image failed to load. And then we say image load result is result.failure. And we pass in this throwable. So it result throwable. All right. Next up, now that we have our painter that we can use to actually draw an image. Right now, we don't really draw anything because this is really just a state and not a real composable, at least not a visual composable. So what we want to do is when val result is equal to our image load result, when that is null, actually null, then that means we are still loading this image. Let's for now just show a circular progress indicator. So that is a very easy way to get an animation, but later on I will then show you how we get this book pulse animation. But if this result is now not null anymore, that means we can draw our image. Here we can simply use a normal compose image, which takes in a painter, but the painter will now be our special coil image painter. So we can say the painter is equal to if our result is actually a successful result. So the image has valid dimensions that was loaded. Then we use the painter. And otherwise, if it does not have valid dimensions, we use a painter resource instead, where we can now load our failed image drawable from our local resources. I don't even know if I included this here in the app before. No, we actually don't have our drawable in here yet. I will simply paste this here because this is an XML drawable, which you can, of course, also find from GitHub below. But I think now that I realized this, I will also include this in the initial branch. So you should probably already have this here. And if not, if I forgot it for some reason, then you can still simply copy paste this XML code from the same path here and just create a new empty file, put this in there, and then you're ready. We now need to rebuild this. So make module, that's enough. And then we should have access to our new drawable resource. So we did get a compile error, which is expected since we have an issue in here. But if we now actually, let's move this into such braces. If we now type a res, this one here, dot drawable dot book error, there it is, book error 2. Then we will create a painter from this painter resource. Cool. Next up, what we need to pass here is a content description for content description, where we can just use the title of the book, so screen readers would read that. And then what we want is a content scale. This is also dependent on the actual result here. So if the result is success, we want to use content scale.crop. So we use this typical center crop content scale style. So if the image does not fit in our dimensions, then it will be cropped. And otherwise, if this is not successful, that means we are dealing with this book error, we will use content scale that fit instead, since for this icon it would look weird when it's cropped, and this way it still looks solid and is then centered here in our image. And then what we can do is we can say, we give this whole thing a modifier of type modifier, obviously, and I just want to give this an aspect ratio of 0.65f. So we just force every single image to have the same aspect ratio. What we also want to do is we want to set this ratio on the one hand, but we also want to set this match height constraints first, set this to true, so that it definitely tries to fill in the height here of the aspect ratio without trying the width first, since the book covers are all rather higher than wide. So this should now be enough to actually load an image and display error loading events. So the next state of our outer row would be this text section here, which is actually a column. So let's take a look up here again. So this box is the first element of our row. And if we then go down here, we can put in our column. For this column, we can now say modifier fill max height, which would normally again span the whole screen's height if the outer row in this case does not have a fixed height. But since we assign this fixed height with this intrinsic size.min, we will make sure that this does not happen, and we will only span the available height. So pretty much the height of our image cover. And what we want to say is we want to give this column a weight of 1f. What this will do is if only the single element in this outer row has a weight of 1f, it will simply span all the available width that it can get after the other items have already been placed. And what's important is that we set vertical arrangement to arrangement.center, so these texts are just centered vertically here. The first text in here will be our book title. So book title, we can set the style to material theme dot typography dot title medium. We can give it a max lines count of 2, so that we allow it to span over 2 lines here. And then we set the overflow to text overflow.ellipsis, so that if the text or the title is even longer than we can fit in 2 lines, then we will cut it off with 3 dots. Then afterwards, if there is actually an author, then we want to display that. Not all books have an author, at least in what the API provides. Some books have multiple authors. Still here in this primary list item UI, we want to really provide a rather condensed view of everything around the book, and then display the details on the detail screen, which is why I will only show the primary author here for a book. So if we take a look at the book dot authors, then we can say first or null. So if there is an author, we call let, get the author name, and simply display a text with it. So the text is the author name. The style here would be material theme, typography, body large. For the author, we just want to allow 1 line and also set the overflow to ellipsis. And then the rating text remains. You can see not all books have such a rating provided from the API, but if they do, they want to display this as a row with a text that displays the rating value and our little star icon. So down here below the authors, we can say book rating average, average rating I called it. If that exists, we get the rating, and we can display this actually in a row here, where we can say modifier is modifier. We give this actually a vertical padding. Let's do this first. Not a vertical padding, but we center this vertically. Vertical alignment is center vertically. Center alignment dot center vertically. There it is. We actually don't need a modifier when I think about it. We just want to center this vertically, and in here we then put in our text first of all that reflects the rating that to string. So it's an integer rating. What's a double, I think? Double, yes. I'm going to show that as a string, obviously. And we might also want to round this, actually, since doubles often have a lot of decimal places. If we do some floating point arithmetics here, this can quickly happen, since you can't accurately represent every single decimal number with a binary sequence. So sometimes if you do some logical floating point math, you will end up with something like 3.5000004 or so, which is something you've maybe faced, which is why we definitely want to round this to only 1 decimal place. So instead of actually just converting this to a string, let's say we display what we get from the round function here. We pass in our rating, we multiply this by 10, and then divide it by 10 again. So that means if our actual rating would be 4.555, for example, what we would do is we would say 4.555 multiplied by 10, which is equal to 45.55. And if we then divide this by 10 again, or this one would actually be the rounded results. If we say round this whole thing, then this would lead to 46. And if we then divide this 46 by 10, we get to 4.6 as the final value without any of these extra decimal places. That is how this works. Style is material theme dot typography body medium. And then next to that, we want to have a little star icon. So we can just say icon, image vector, icons, default, star. There we go. There is an existing item for that. The content description can be null for that. We don't really need to explain that in any way. And we then say the tint should be our sand yellow color. So we get a little nice yellow orangish icon here. And the last thing that remains is the simple icon here for this arrow, which will be displayed at the very end of our outer row. So after this column right here, where we just say we have an icon, the image vector is icons default. Actually, it's auto mirrored. This is in auto mirrored dot default. Or I used this one from filled dot. It's called keyboard arrow right. So we want to have a keyboard arrow that points to the right. Content description is null. And the modifier, let's give this a fixed size of 36 dp. And that is our book item composable, at least for now. The only thing that is missing is that we give this a proper animation here that I've shown you here with this little pulse-like animation. And also that once we loaded a book, you can see we animate this in. This is also what's currently missing here, which is what we will do later in this course. Next up, we can work on actually showing these list items in an actual list. So a lazy column in Compose, which we want to put here in our components package again. So we say book list. Make this a file, have a book list composable, which obviously will take in a list of books. It will get an on book click lambda, which gives us access to the book we clicked on when we clicked on a book. And it needs an actual scroll state, which is a lazy list state. And we can default initialize this here with remember lazy list state. Like this, we can then move this down here since it's encouraged to have the modifier as the first default parameter in a list of your function signature. And in here, we can then make a lazy column. This composable is actually quite simple. The lazy column will take in the modifier we've passed. It will take in our state, our scroll state. It will take in a vertical arrangement of arrangement that's spaced by 12 dp. So if we alt enter to import dp, what this will achieve is just that we have 12 dp of spacing between all of these list items. And we can set the horizontal alignment to alignment that center horizontally. Inside of the lazy column, we want to have an items block, since we want to display a bunch of items, which will obviously be for our books. So we have our books list in here. We then get a reference to every single book in that list. And we can now use that information to show off our book list item. Pass in our book reference, give this a modifier of modifier within. I want to give this a maximum width of 700 dp because again, we need to think of desktop as well. And I think super long stretched list items would not look that well. So we rather want to give these a max width. We can then say fill max width. So we also make sure to span over the available width. And then finally, some horizontal padding. Padding horizontal of 16 dp. And lastly, when we actually click on such a list item, we can say on book click, and we pass in the book we clicked on. Something that is also worth doing is that we say items is this, and then we also give each item a unique key. Keys are pretty much the most straightforward way in a lazy column to optimize performance and to also enable item animations. So when certain items in the list change, because if we give each item, each book here, a unique key, for example, the ID, then the lazy column is smart enough to actually detect which items changed if this whole list is being replaced with a different list of books. And we can then on the one hand animate the items that changed. And on the other hand, the lazy column only needs to recompose those items that changed instead of the whole list again. So I would always recommend to pass in unique keys if you have unique keys. And I would say we now have all those reusable components that we need for our book list screen. We still need to work on this tab layout here, but I will implement this right away in this book list screen since this is quite mixed with different composables. So we need to know this list. We need to know how this looks like here in this whole layout, which is why I've decided to actually put this in the screen layout itself. So let's go here back to our book list screen. And I think for this one, it's actually worth creating a preview in our Android source set here in our previews file, since it definitely helps to actually have a real preview for the whole screen. So we can just add this here, preview, book list screen preview. We can, let's just display this right away. Book list screen root, actually not the root one. We do need to make the real screen here public. Normally I wouldn't do that because normally you could put the preview inside of this file directly and then therefore access this private composable. But since Compose Multiplatform doesn't support previews in the public in the common source set yet, let's do it this way. So we say we have a book list screen, this one, which is now very easy to preview since we can just construct a book list state on our own. Search query can stay Kotlin. Search results, might want to have a dummy list of books here. Private val books. You can just randomly generate 100 books, for example. Say 1 to 100 map, and we map each index to a book. You can then say the ID is the current index to string. The title would be book it, so book 1, book 2, and so on. Image URL. We won't be able to display any images here in the preview anyways, at least not load these from the network. So we just pass in some kind of invalid URL. The authors, let's have a list of me, like this. Then for the description, that is not relevant for this one. Let's just give this a description it again, in case we need this book list later on as well. Languages, also not relevant. The first published year is not relevant for this preview. The average rating is relevant. We can give this something like this. So we also check if the rounding works. The rating count is not relevant. We can pass any random number. The number of pages is not relevant here. Let's give this 100. And the number of editions is also not relevant. But now we have a sample list of dummy books we can pass in here. And this is also, as I said, the reason why I always start with a presentation layer, since now we can already check how our UI looks like. It's very easy to create dummy data, but if you start with a data layer and actually are able to load real data, but you don't have any way to really display these and work with that, then you still need to implement the whole presentation layer in addition until you're at the point where you can test this whole thing for the very first time. That is why this is typically easier. So here, do we need anything else? No. Everything else can stay the same. What is this one here for? What is that lambda? It's on action. We can leave this as an empty lambda. I also always recommend to actually name your lambdas that way unless it's a composable content lambda, because if we have a trading lambda here, it's absolutely not obvious that this is a normal lambda and not a composable lambda. So avoid that. So if we now reload this, we should be able to see our very basic book list screen with our single book search bar. No, it actually seems to complain. We need to build and refresh. Yes, there we go. Here's our book list screen preview. Awesome. So from this, we now somehow need to get to this. And that happens here in the book list screen. I don't know if I can actually split this here maybe a little bit. Can I split right? Does this do something? And if I then expand this over here, oh, this is very hacky, but if we then switch over here, then we do have a working preview pretty much. Very cool. Let's make this full screen preview. And if I now change something, I'm curious if this automatically refreshes the preview in another file. So let's give this a different background color of color red, for example. Then we apparently still need to click here. Yes, there we go. So apparently it doesn't automatically switch and refresh the preview. We need to still do that on our own. But this is a hacky way to make the Compose preview work in Compose Multiplatform as of now, until that's supported in the common main source set as well. So you can see we have our search bar. And After that, we now want to have our lazy column with this kind of rounded corner shape, and in the end, just a white surface. So that is what we will go on with. We will have a surface, composable again, where we set the modifier to modifier weight 1f again. So we just make this white thing span the remaining height of our screen, and then say it also fills the maximum width. The color of this will be our desert white. And the shape will be a rounded corner shape. Here we really only want to have these rounded corners for these top 2 corners. So we say top start is 32 dp, top end as well. And then if we open up the surface, we should already see when we refresh the preview that we have our surface here. Yes, there we go. This looks pretty much like on the left. Very cool. Now what comes next is we want to have a column here, because on the one hand we have this tab row, which is a single composable, and then we have what comes after this tab row, so our actual book list. And since we want to arrange these both in a column-wise fashion, we will make use of a column. This column will have a modifier, or actually not, just horizontal alignment. So we center everything horizontally, alignment, center horizontally. Then in here, we do have this tab row, which is a material composable for now displaying these multiple tab items. Here we need to pass in the selected tab index, which we get from our state. The modifier is modifier. We give this some padding of actually vertical padding of 12 dp. So this is this vertical padding that you can see here. This orange highlight has a bit of vertical padding. We again say within maximum 700p for the same reasons I've mentioned before, and then fill the whole width that we have. In here, in this content of the tab row, we can now specify those tab items, so single tabs. Our search results on the one hand, and the favorites. That works with tabs, surprise, surprise. But we now need to say whether this tab is selected or not, so whether I want to draw this orange kind of a border there. For this first tab, it's selected if the state selected tab index is 0, so if it's the first one that's selected. If we click this first tab item, we need to trigger our onAction lambda, since that is a user action that triggers some sort of state change, switching the tabs here, where we say book list action dot on tab selected, and the selected tab is tab number 0. The modifier here will be modifier weight 1f, so we just want to evenly distribute these tabs here over the row, because this is, I think, a row scope that we have access to here. Otherwise, you wouldn't be able to call weight. I want to set the selected content color to our sand yellow. So this is for the line here and for the text color, and the unselected content color. So when a tab is not selected, we set this to black, but with 50% of alpha. So color black, copy alpha 0.5f. Then the text for this tab will be a string resource. Let's create this here in our values strings XML. Let's create 2 of these. On the one hand, search results, and on the other hand, for the favorites. Then quickly make this module again, so we generate these string resources, go back here, make this bigger again, and we get an error that is expected. In here we can now refer to these just generated resources with ras.string.search results. And the modifier of this text will be modifier.padding, and we again give this 12 dp of vertical padding. And the second tab will look exactly the same, so we can just copy paste this, work with that, just replace this one with 1. So this is selected if the select tab index is equal to 1. If we click on it, we want to select tab number 1, and the text would be favorites. And if we now refresh our preview, we should hopefully see exactly that as well. We should hopefully see a tab layout. Yes, just this purple bar should not be there. This should also be orange. I think we need to change this for the tab row, which is the container color. No, the container color is obviously what's behind. If we set this to desert white, that is what we should definitely do. The content color to our sand yellow, and then refresh this. What happens? No, and I actually just check that we do need to override this indicator. So that is how this thing is called, the currently purple thing. That is a tab indicator. We can override with this indicator lambda, which gives us a composable lambda, to have one from tab row defaults that tab, that secondary indicator it's called. We set this to modifier, modifier dot tab indicator offset. And this one actually gives us access to tab positions, which is, if we take a look at that, a list of tab position. So where each tab is in our tab layout. And we can now use this to properly offset the indicator. So let's actually not do this. So we see what happens by just giving this a color of sand yellow. If we do it like this, then you can see this is a completely sand yellow, which might also be because I set the content color there. But no, and we actually do need to pass in this modifier tab indicator offset. And here we can then refer to the specific tab of our selected index. So state selected tab index. Refresh this again. And now you can see it's properly offset. So it just uses the proper position and offset information from the tabs that we already get from the lambda itself. So we don't need to worry about that, but we do need to use this custom tab indicator offset modifier to properly offset this. Okay, below this tab layout, I just want to have a little bit of spacing. That means if we have this tab row here, then here we want to have a spacer. Where we say modifier is modifier.height with 4 dp of spacing. And what comes here will now be a horizontal pager. Why do we need a horizontal pager? Because this tab row from the material library is really just what it has. It's really just a tab row. It adds these tab-like components, but it does not yet allow any swiping between these tabs. It really only adds 2 tabs and lets us click on these. But if we want to be able to actually swipe between these pages, then we do need a horizontal pager, which is pretty much just a container in which we can put a composable, and that container lets us swipe between multiple pages of composables. In our case, just our search results and the favorites list. In order to now declare this horizontal pager, we can work with a horizontal pager, surprise, surprise, which now takes in this pager state. This pager state lets us then also control which page we are actually inspecting, how many pages there are in the first place, and I would like to declare this at the top of our screen, somewhere here. Val pager state is equal to remember pager state, which gives us this lambda here in which we need to pass in the page count. So in our case, just 2. The initial page can stay at 0, and the offset fraction, we don't need to change anything about that. We just want to have 2 pages and then pass in this pager state down here. Give this one a modifier of modifier fill max width and a weight of 1f, so we can fill the remaining height of our screen. And then we get this composable lambda in here. And what we now put in this lambda here, it will be our current page. So we do get the page index here. So either 0 if we are on the first page, or 1 if we are on the favorite section. And depending on this page index, we now want to show the right page. So we can say when page index. If that is 0, we want to show this composable. And if it's 1, we want to show that one. If it's 0, then that means we are here on the first page where we show our search results. There we need to have another check, because if we are currently loading those search results, we want to show a loading indicator. So we say if state is loading is true, then show a circular progress indicator, which we actually want to center on the screen. So we might want to actually put all this stuff in a box. Modifier fill max size, and we give this a content alignment of center. So we just center everything here inside of our box. And when then the page index is 0, this indicator will then be centered. If it is, if we're not loading, so else, then we actually need another little when expression, because depending on what our search results are, we want to show a different thing. So you can see this if we search for something here where we probably don't find any search results, then we display such a text. This is something we would need to put in this box. And if there are search results, we obviously show them with our list. And if there is an error, we also want to show this. So if we, for example, turn off our internet connection and we search for something, Harry Potter or so, then we get an unknown error occurred, or whatever kind of error message we choose for that. So here in this when expression, when the state dot error message is not null, so that there is an error, then we just show a text that tells us this error. And since this state error message is now a UI text, not a string yet. This UI text is just a wrapper, as I said, around a string resource ID. We can now take this and actually unwrap that with asString, which is a composable function, and will then simply take the string resource ID. And if it, first of all, check what kind of UI text this is. If it's a dynamic string, it will return the value right away. But if it's a string resource ID, like it is here, then it will return the string resource with this ID instead. So going back here, we can then also change the appearance of this text a little bit. First of all, setting the text align to center, not snap position. Text align is text align.center. And the style of the text can be material, theme, typography, headline, small, for example, headline small. And we might also want to give this an error color. So material theme, color scheme, error, like this. Similarly, you want to do this if there are no search results. So if state search results is empty. So we search for something, but nothing is available. Then we also want to show a text, not the error message in this case, but rather a string resource. String resource are res dot string. And how do we call this? No search results. We can then go to strings XML, duplicate the last line, create a no search results string resource, and say, oops, we couldn't, or not we, let's say, oops, there aren't any books for your search query, something like that. Then again, make this module again, and after that we can import this. We go, do we get the import? No, it's not done yet. There we go. Do we now get this import? Yes, we do. Alt enter, import the string resource, and for the final state, so else, that means we successfully found at least one book with our search query. In that case, we want to show this list of books, of course. So we say book list. The list of books comes from our state.search results, we called it. When we click on a book, then we do want to trigger our onAction lambda, where we say book list action on book click, and we pass in it, so the book we clicked on. The modifier can just be modifier film X size, and that's already fine. For the scroll state, I want to pass something. Let's say lazy list state. I want to declare this up here. Here. Well, lazy list state is equal to remember lazy list state. The reason I'm creating this, I actually need two of these lazy list states. One for the list for the search results and one for the favorite books. Let's actually change this to search results list state or so. The reason I'm creating this is that if we've scrolled down a little bit and our search results change, for example, we search for Python now, then you can see it animates a scroll to the very first item index. So in order to actually force animation or force animating towards a specific item, we need a lazy list state. So we can have a launched effect block here whenever the search results change. So when we have different books in our list, then we want to say search results list state, animate scroll to item, and we want to animate to the very first item. Down here in our pager, in this book list, we now pass our list state. And for index number 1, for our favorites here, when we are on this page, then we also want to show a book list. So we can actually have something similar. So also if there are no books in our favorites list, so if state favorite books is empty, then we just want to show some kind of text here. So we can just replicate this one here. No search results. We probably should change this to something like you haven't saved any favorite books yet. And here we can say no favorite books. And again, same thing. That is a bit annoying with having to rebuild all the time when creating a resource, but we get a lot out of that by being able to share these resources. The rebuild is still going on, but we can already set this to no favorite books. And in the else case, we can probably just copy paste our book list from up here, put this over there and just swap this out with our favorite books. Here we need to also pass in a different scroll state. So we can say favorite books list state, something like that. Scroll up, duplicate this one, call it favorite books list state, and we are ready to go, I think. I think this should be the screen, and we can also refresh our preview in a moment. Rebuild is still going on for me. All right, and now after rebuild, you can see the preview actually loaded, and it looks slightly off. So if we go back to the search results, these items all look a little bit like not so high as these are. And I would say we check why this is. First of all, let's vertically center these, and there's also there's not enough horizontal spacing. So let's fix these easy things first, I would say, by going to the book list item. And here in our row, yes, the root row, here we need to make sure that we vertically center everything like this. We can also give this row some horizontal arrangement spaced by, let's say, 16 dp. If we then refresh this preview, we should already see that everything is hopefully centered vertically. And yes, not so cramped. It seems like there is some vertical spacing here. I mean, the odd thing about this is that this box here, if we click on that, then that is the surface. That is smaller than the actual area that gets drawn. And I'm not sure if this is actually an issue in our code or an issue with the preview. So I would suggest we just try to launch the app as it is with our dummy books by going to our previews, taking this private val books and cutting this out, putting this in our book list state, like this. Let's just have our dummy books over here, make this thing public. It's really just for development purposes. Here we then need to import these books with Alt-Enter. And then we can say, okay, the initial search results are just our dummy books. If we then launch this on our device, let's see what happens, because I think everything else should already be set. Okay, we do get a crash. Why is that? Because of probably missing internet connection. Let's go to manifest, add a user's permission and say we want to use internet. That was probably it. Yes, it was. And here it actually looks different. That is good. So it seems like the preview here has its issues with the Compose Multiplatform composables. You can see the images don't load because we have invalid URLs. So that makes sense. And the rest is looking pretty much like before. Going to the favorites works. It just doesn't show the favorites list yet. Or did we also pass that, also pass in our dummy books for that? No, that one is an empty list. So we still need to check why that doesn't work. Oh no, okay, when this error book actually loads, then we do get this extra spacing. So it seems to be related to somewhere here where we check whether the search, no, actually in our list item where we check if we successfully loaded the result. Somewhere here it seems like we have too much padding or so. Alright guys, I did not expect that finding this padding issue here would be that difficult. I just spent 1.5 hours to actually track down why, only for error images, we get this kind of extra padding here. You can see I opened the layout inspector, and for some reason only for these error images there's this extra kind of spacing around this image, which does not happen for the actual book covers. I really copy-pasted my exact composable that I have in my sample code in here, same issue. I double-checked everything that I could, same issue, and I ended up finding the issue, so we can fix this luckily, but I still don't understand why. I assume that it's either a bug in Koin, a bug in Compose resources, or that I just completely missed something here. But I know that people like when I actually fix such things also here in the video, because I think it's important to show that YouTube is also not always sunshine and rainbows and that we just type the code from beginning to end and then it magically works. That's also not the case for me. Of course, everything is prepared here. And even if everything is prepared, such issues happen and I need time to debug these. That's completely normal. So nobody needs to feel bad if that happens to you. That happens to all of us. Let's actually take a look at what the issue is, or rather how we can fix it. We can fix it by taking a look here in our book error 2 XML. For some reason, this vector drawable does not like being 512 dp wide and high. If we change this to something smaller like 256 dp, which, by the way, I don't have that way in my prepared code. I actually just copy pasted this file. So my prepared code, I have 512 dp for both of these, and it works just fine. It does not have this extra padding for these error images. But here I need to change this. I don't know why. I'm using the same versions for Koin and all that stuff. But if we change this and then actually rerun our app, then take a look here again. Let's also get rid of the layout inspector so we get this a bit larger. Then we should hopefully now get a working list item. I mean, they are working, but they should look a little bit better without all that extra spacing. And there we go. You can see now it looks exactly as we wanted. I have no idea why this actually causes an issue, because we gave our image actually a fixed size. So here in our book list item, the image is inside of this box, which has a fixed height. So it's technically not possible to actually exceed that height, no matter what kind of image we put in there. But for some reason that still happens. So I can only explain that, as I said, either a bug in Koin, a bug in Compose Multiplatform resources, or I'm missing something. If you know the issue, comment below. Would be really interesting to know. But I think this is also not something that we need to waste hours on. So let's just go on with building the book app, because now we actually have a completely working book list screen where we can scroll through all of our books, or dummy books at this point. We can actually change here to the favorites. You can see this does not yet update, and that's something we'll do in a moment. Maybe we should also change the text color of this one here to black, so it doesn't show up as an error. We can do this here in our book list screen by scrolling down. Let's shrink the preview a little bit so you get to see more code. Here for the search results, when these are empty, no, actually not these, but when the favorites are empty, then I want to get rid of the text color here. So it will show up in black. How do we now implement that when we switch the page, then we also update our pager, and that when we click on our pager, we also switch the page, because that's the only bit of functionality missing here, apart from, of course, loading the books. We need to do this with some launched effect blocks, because on the one hand, we need to listen to our current page, which will update when we swipe here in our pager. And on the other hand, we need to listen to the selected tab index of our tab row, which will just change when we click here. And the way this works is pretty simple. So it's kind of a two-way binding, we can call it. We have a launched effect block here where we listen to our selected tab index. So whenever that changes, this launched effect block here will be called. And in that case, when we click on favorites or search results, we want to use our pager state to animate a scroll to a page, and the page will simply be our new selected tab index. Just like that. So this will fix that if we click on something, we also switch the page. And now the other launched effect will be for switching the page, that we also update the selected tab up there. Here, launched effect. This will now require the actual, the current page, so pager state at current page. Whenever that changes, which will update when we swipe the pages, then we want to check if we are currently not scrolling. So if pager state is scroll in progress is false, because only when we really stop the scroll, then we want to actually update the tab row. So here we need to send an action to our view model by saying book list action dot on tab selected, and the new selected tab in this case will then be the pager state current page. So just the new page that we swipe to. If we launch this, then we should be able to check this. There we go. So if we swipe, then no, it does not yet happen that we actually see the tab row. If we click here, that works. I think this might be because the current page updates before this Boolean switches to false. Let's try if this works if we put this outside this if condition and launch this again. So there we go, we swipe. Yes, now it works just fine. And we can still click here and still swipe. Yes, now it works. So the scroll check apparently wasn't necessary. So I think we can start the next chapter of this course, and that is to start working on our data layer, on the functionality that we can actually fetch our book data from our Open Library API and then somehow display that in our UI so that we are able to actually search for books, that we call that we properly map everything to state in our book list view model, and so on. So to just show you how this API works, which API we're actually using, I'm here on this Open Library website. You can see that's just openlibrary.org, completely free. As I said, you don't even need an authentication for that. You can just call the endpoint. And the way this works is we do have this search.json endpoint, and we can just attach this title here. So for what we are actually searching. And for example, if we say Harry plus Potter, execute that. Then after it loaded, we get all of our books here from that endpoint. So this is now the JSON structure that we need to kind of replicate in our source code in Android Studio. Of course, not exactly the same structure as here. So there's a lot of information for every single book, but only those types of fields here that we're actually interested in. So specifically those that are also part of our book model. So how does this work with the architecture that we've chosen? This works with so-called data models. So you've already learned about domain models. A domain model is in the end what you've seen here, this book model, for example. So really just a pure Kotlin data class representation of a core concept of our app, of what a book is. Now, a data model is something similar, but it contains implementation details. Specifically, how our JSON field names are actually like, in which format the JSON structure is in, and so on. So what we want to create for this book is we want to have an equivalent data model that we can then use to take our JSON structure that the API responds with and parse that into our Kotlin data class. And we call these data-related models, at least if they come from a network, we typically call these DTOs, so data transfer objects, because these are transferred via the network. And you'll notice that these can be quite similar as this domain model here, but I'll share why we have two types of models here in a moment. So here in our data package, what we want is we want to create. Let's actually create a DTO package in there for all of our data transfer objects. And in there, we will now have a data class called searched book DTO, for example. So just one book entry from our search response. This will be a data class. And since we're now using Kotlin X serialization to actually parse the JSON into our Kotlin data class, we need to annotate this with serializable. This is a requirement from this Kotlin X serialization library. And now here in this data class, we pretty much just want to look up our JSON structure. So we are now actually trying to parse such an object here in this docs list, trying to parse that into such a data class that we've just created in our DTO. You can see we have the title, which is interesting for us. We have a lot of IDs from Amazon, ISBNs, and so on we don't care about. We have the publish year, for example. So we now want to actually extract the data that we need here from this JSON structure into our Kotlin data class. On the one hand, each book will have an ID in form of a string. And we also want to annotate this with serial name because remotely these IDs are actually called key. I still prefer to work with ID here. So with that, we just say, okay, in the JSON it's called key. We want to call it ID. Then we get the title, which is a string. Title is also called like that in the JSON structure, so we don't need the serial name here. We do want the language, actually the languages, because there could be multiple languages, which is a list of string that can be null. So this is not returned for every book. We have the cover alternative key, which is an integer and nullable. So this will be the cover key, which we'll later on need to actually fetch a book cover, since that's not contained in the response there. So this will have a serial name called cover_I, which I just like to call cover alternative key. Makes it a bit more clear. Same thing for the author keys. So serial name author_key, which is actually a list. So author keys, list of string nullable again. We have the author_name for our author names, again, plural. We then have a normal cover key. Let's also duplicate this again. Cover key, which is called cover_edition key. This will be an integer again. So a nullable integer. There are just two of these cover keys. We'll first of all try to fetch the book cover with this key. If that fails, we'll try it with this key. And if that fails, we will display our error image. In general, the API design of this open library is not that good. You will also notice this later with an issue that we have with this API that we will need to work around. But for now, we can just proceed here. So we get the first publish year, which will be our publish year. Let's call it first publish year. We have our ratings average, which is a double and called ratings average. We have our ratings count, which is an integer. Call this ratings count. And we have two more that we care about. On the one hand, the number of pages median, which we want to call num pages median, and that is an integer nullable. And the last one that we care about at least is the edition count. So the number of editions, And I would say for consistency, we can also add these serial names to these here by saying this is our title. Oops. And here, I think that's actually called language, even though it's multiple ones. So let's also add the serial name here. So we now have our searched book DTO. This looks very similarly to our book model, except for these annotations. So why do we really work with two models here? Couldn't we just add these annotations here to this book model? So to make this, a serializable and so on, we could, but we would violate this architecture because, as I said, the domain layer is really meant to be completely isolated. It really shouldn't have any references to external libraries, to implementation details. And while we have a single module project here, we would technically be able to use those here, but very often in practice, you don't have that. So you have your domain layer as a separate Gradle module. So you also have to add your own types of libraries for this domain module. And then you wouldn't be able to use data-related references here by default anymore. And that's the intention of it. Because the purpose of this is of having two models here is that when implementation details change, let's say the backend team says, hey guys, I actually renamed the key field to ID. What we as app developers then have to do is we have to hop into our code and we need to change this here to ID so that our code doesn't break. And such changes in implementation details like the JSON structure should not have an impact on our domain layer. They should not require changes in the domain layer. And that is why we really want to keep it like that. Also, if certain implementation details or certain libraries change, if you say, I want to swap out Kotlin actualization with, I don't know, Moshi or JSON, well, then you also only need to change your data layer. Your domain layer is completely isolated of these dependencies, so you don't need to change anything there and also not change anything in the presentation layer, since the presentation layer only makes use of the domain models again. Something else we now need is, if we take a look in our browser again, the searched book DTO is in the end what starts here from this JSON object. However, the actual JSON response that is returned is this outer one here. So we also need such a DTO for that outer response, which contains this docs field, which then contains a list of our searched book DTOs. So let's go here in DTO. Let's have a search response DTO, for example, which will also get our little serializable annotation. And in here, we will then just have our docs field, or let's call it results to be a bit more expressive here. This will be a list of our searched book DTO now. And we can annotate this with serial name to encode the remote JSON field name, which is docs. So this was what the API will respond with. And this contains our desired list of searched book DTOs then. Okay, so the next step is now to actually implement the functionality that really makes that actual API call and parses the JSON response into this object. And that also goes in our book data layer here, where we can just say, okay, maybe create a network package or so. And in here, we will put a class called Ktor remote book data source, because that's exactly what it is. It's a data source. So a source of books, it's remote, and we use Ktor for that. So this is a typical naming I choose for these specific implementations of a data source, since the class name immediately makes clear what will be inside. And this class will take in a reference of an HTTP client. So from our Ktor client, this is the main instance that we need to use in order to make actual API calls and fetch data that way. And technically, we can just create a suspend function in here, which we call search books, for example. That obviously needs the search query. And we could pass an optional result limit, so nullable integer for just how many results we want to have in the response. Let's format that a bit like this. And what will this now return? Well, this will return a result, our own custom result class that takes in two generics. A result that holds our search response DTO. Oh no, actually not, because that would be a violation of our architecture, which you will see in a moment why that is. Instead, what we want to do, what we want to return is a list of books. So our domain model. If there was an error, so the type of error codes of error enums that we can return here in this search books function, well, those are data errors which we need to create. That is now how this result class works that I added before in our core package, domain, And here we have this result class, which really just wraps around either a successful piece of data, a list of books, for example, or a specific error that must implement this error interface we have in here. It's really just a marker interface. And the way this now works is, if we want to extend this, for example, with a set of network-related errors, then we can go in here, we can create something like a data error, make that an interface, a sealed interface. And a data error could now be a remote error, but it could also be a local error. So if we're dealing with a database and the storage is full or so, then that would be a local data-related error. If the API responds with some kind of invalid status code or there is no internet connection or so, then that is a remote-related data error. So in here, we can declare an enum class called remote for the remote errors, which is now a data error. And this data error, very important, must also implement our error interface. So we are able to pass that as a valid error to our result class. And let's now think about what kinds of remote errors we care about. For example, request timeout. Too many requests. So in case the API has some kind of quota and you exceed that quota, then that might be returned. For example, something like no internet, if you don't have internet connection. Something like server. So if there's any server-side error that we don't really have an influence on, then we also want to know that, of course. Maybe also serialization-related errors. So if JSON parsing fails for some reason. And lastly, let's have some unknown errors for everything else. We can also already add another enum class here for local data errors, in which we just have disk full or unknown, like this. What this now allows us to do is, in our Ktor remote book data source, we can now make this return a data error dot remote. So here in this function, we can now make our API call. We can check for the result. We can properly retrieve the list of books in our response. If so, we will return this as a result of success with this list of books. If something failed, we will return the proper data error here from the enum class remote. And for a simple app like this, that really just needs to make use of two different API calls, one for the book search endpoint, one for the book detail endpoint. We could really just type this off here. But as I said, I really want to teach you how I would also handle this in a growing app, in an app that scales. And that is why I will introduce some utility functions that I typically use for my bigger projects that I've also shared in my Big Essentials course, because that will really make your life easier when you work with maybe 10, 20, 50 or more than 100 endpoints, which can quickly be the case in a growing app. So what we want to do is, in core, we create a data layer for shared data-related logic utility. And in there, we will have an HTTP client extension file. So here we really just define extension functions for the HTTP client or just other HTTP client-related utility. For example, that we have a suspend inline function. We say reify t, and no worries, I will explain this in a moment. Call this response to result, where we pass in a certain HTTP response. And what this will now return is a result from our domain package here, a result of type T or data error remote. So this function is now a utility function that takes in an HTTP response, so any type of response that came back from an API, no matter what kind of API call that was, it will try to actually extract the data out of that HTTP response, so the actual JSON body, and parse that into our type T that we expect here. The reified is needed because we need the type information of this generic argument inside of this function here, which would normally not be possible. With reified it is. Inline is also needed together with that, and it's suspending since the function or the parsing process is a suspending function here. But in the end, this is really just a when expression. So we can return when the response status, that value, so the actual returned HTTP status code, if that is in the range of 200 to 299, that means the response was successful, because if an HTTP status code starts with a 2, that indicates a success. In that case, in here, we now want to try actually parsing the JSON body into our type T. So we say result success, and we say response.body as type T. So just try to actually parse that response body into our T data class, and this would then return just our Kotlin representation of the JSON response. If that fails, it will throw a node transformation found exception, and in that case, we can then return a result error instead, where we say data error remote serialization. That is the specific error that happened in that case. And now after that, when things went wrong, then the status code does not start with a 2. Instead, it will start with something like a 4. So that will be a client-side error, something that is our fault, that we made a wrong request or so. For example, 408 will mean request timeout. In that case, we can then return result error, data error, remote, request timeout. Something like 429 will be too many requests. And let's take a look what else we have in here. So we have a server-side error, no internet error that does not have anything to do with the status code that is returned. That is something we need to check when we make the request, and unknown errors. So in here, if the error is in 500 to 599, if it starts with a 5, that means server-side error. So something on the server went wrong that is outside of our influence. So we say result error. Actually we need the in keyword here. And then we want to return data error .remote.server. And in all other cases, we say result error, data error, remote, unknown. So in that case, we just display a generic error message. Of course, we could check for every single status code that could be returned here, but I always decide about how fine-grained I do this, depending on whether I want to show different types of error messages for these different types of errors. So if there is no benefit to the user of knowing the exact error, what went wrong, then I also would just show a generic error message, which can sometimes also be better security-wise, since you're not revealing why something went wrong. All right, that is one utility function that I want to create. Another one is now a function that safely executes an HTTP call and catches the necessary exceptions there. Will also be a suspend inline function, also with a reified T for the same reasons as below, and we call this safe call. This will get in an execute lambda, which is meant to execute the actual call, and this lambda will return an HTTP response. And again, put this on a separate line. And this will then again return a result of T and a data error network, remote I called it. And all this will now do is it will get the response, or try to get the response, from our execute lambda, which executes the request. So it's a lambda, so we can dynamically use this function with any type of request that returns an HTTP response. But this function will now catch certain exceptions that could happen there. On the one hand, a socket timeout exception, for example. In that case, we want to return a result error, data error, remote, timeout, and actually return that here. If we get an unresolved address exception, then as long as the server is actually live, this usually means that there is no internet connection. So then we want to return result error, data error, remote, no internet. And if we get any other exceptions, then we want to return result error, data error, remote, unknown. Here it's important, if we catch general exceptions in a try and catch block for a suspending function, which this execute function could be and will be, that we also call coroutine context ensure active. I won't go into the details here, but what could possibly happen here is that we accidentally catch cancellation exceptions. So when a coroutine is cancelled in Kotlin, the currently suspending function will throw a cancellation exception, like this execute lambda, the API call. And if we catch that, then we can break this cancellation mechanism in our app, since the parent scopes of this coroutine might not be properly notified about that. That can lead to several issues. I made dozens of videos about common coroutine mistakes. I have a Coroutines Masterclass, which I also linked down below. So won't go into the details here, but this is something we have to do. All right, so this means if we did not return at any catch block here, we successfully got a valid HTTP response. And this we will then simply return by putting this into our response to result, like this, which will also return the same type of result here. And now we have very handy utility here that we can use to go back to our data source and actually execute this. So here for search books, we can return our save call function, which has this lambda. And this lambda now needs to be an HTTP call that returns an HTTP response, for which we can then use our HTTP client. We call get, so it's a get request. We need to pass in a URL string, so the actual URL we want to make a request to. We can also have our base URL here, so private const val base URL, and that's simply https openlibrary.org. And then we can say, okay, our URL string is, our base URL search.json, that is the URL that I showed you before. And then here we can open a block of code to configure that request a little bit. Specifically, you want to pass certain request parameters. On the one hand, Q for query, where we pass in our query. Our limit, so how many books we're interested in for this request, will be our result limit if it exists. We want to pass in our language, so the language of the books we are looking for. If you come from a different country or you prefer books in your language, then feel free to adjust this. We will use English here, of course. And lastly, what will be quite useful is that we also pass in this fields parameter here to tell the API which fields we're actually interested in. So all the others then won't be returned. You just saw how big the response was with all those Amazon IDs and so on. We don't care about that in our app, so we also don't need to transfer all that unnecessary data. So we can just specify the fields we're looking for. I would simply paste these here. Those are really just the same fields that we already have declared here in our search book DTO. So all of these just in a comma separated string. If you're lazy like I am, then you can also just look up this string here in the GitHub repository below. Now the thing is, if we would run this, this would very likely crash. Even though we don't have any syntax errors, it would crash because what we return here is a list of domain level books. But what this response returns is actually our search response DTO. So typically you have two options when you face this with a data source. It really all depends now whether we want to use this data source application-wide, so also in our view models, for example, also in our domain layer. Because if we would want that, we would need to create an abstraction for it. Because again, if we would now simply use this Ktor remote book data source somewhere in our presentation layer, so if we would pass that here, for example, in our book list view model, this would work. So we would have our data source, which is a Ktor remote data source. But the moment we do that, we couple our presentation layer to our data layer. And when our data layer faces changes, again, in things like JSON field names, if the accepted data also changes, then that will cause changes in our presentation layer as well, which we want to avoid with this architecture. A data-related change should ideally only cause a change in our data layer. And a presentation layer-related change should only cause a change in our presentation layer. So remember, the directions here of our architecture, the directions of the dependencies are like this. We have our presentation layer towards domain, and then we have data that also points towards domain. There is no arrow from data to presentation directly or from domain to data. So this would also not be valid if we would want to use that in our domain layer. So what do we do here? We could create an abstraction for this. So we could go in our domain layer and we create something like a remote book data source, which really just provides the function signatures like this, that this data source should have. This actual implementation can then implement that abstraction that we've created in domain. Since this way around, it's completely valid. If the abstraction sits in domain, then data is allowed to access that, since there was an arrow from data to domain, as I showed you. However, in our specific case here, when we actually have two data sources, a local and a remote one, and there's also a certain interaction between these, because when we later on also add the local data source, the local DB, in order to also save favorites, then we need to somehow coordinate that data access. Because if we then want to actually display a book, then we need to first of all check, is that book already in our local database? If so, we can show it right away, so we don't need to make an actual API call anymore. But if not, we need to make that API call. So this is called offline first, that we first try to load something offline and then online if we weren't successful with our offline query. And if we have such a mechanism, then we need something called a repository. So a repository is really just a design pattern used to combine multiple data sources. And in this case, in our app, our view model and domain layer just need to know that repository. So it will be enough to create this abstraction for the repository and not necessarily for this remote book data source here, at least not in domain. So what we can do in this is we can swap this list of books out here with a search response DTO. And it's now debatable whether we need an abstraction for this one here or not. But if we create one, we must create it now in the data layer, because at this point where we added an implementation detail, where we added a data model to our function signature, at this point, it would not be allowed anymore to have this abstraction in domain, because then domain would again have a reference to a class from data. So what we can do is we go to our network package, we create a remote book data source, which will be an interface, an abstraction, and this will just have the function signature for our search endpoint. So search books, we will have our query in here, we'll have our result limit in here, which is a nullable integer. And this will now return the exact same type of result here. So a search response DTO, and then our data error remote. And if we then take this and actually make this class implement this, then we also need to add this override keyword here. We do need to make the parameter here default in the remote book data source over here. So this way we now create an abstraction of this data source. If we would change the HTTP library, for example, from Ktor to something else in future, then that would not be a problem, because the only class we would need to change is this one. Or we would just need to add another class like this with the other HTTP client, and the rest of our project would not need to change. However, I really want to say that this abstraction is debatable. It does add a little bit of extra complexity here. And it's not necessary in order to not violate our architecture, because we really only need this class inside of our data layer. And obviously the data layer is allowed to access dependencies and classes from the data layer. So I hope I did not confuse you too much with that, but I just want to highlight that it would be important that you would not put this interface here in domain if it has a reference to a DTO, because then domain would have an actual import to your data layer, which would not be allowed. And in a case where your domain layer would need to access a data source and you would not need a repository, as I said, then you would rather make this result contain the actual domain model. So a list of books as I had it before, because then there is no reference to data anymore. So what we now want to do is want to go to our book data and we create a repository. Really just simple for now. Repository, yeah, let's call it like that, as a package. And in there, we will create our, let's call it default repository, or a default book repository. Like that, will be a class. This will now get our data source. So the book, remote book data source, which will depend on the abstraction now. So we could easily swap this out with a different one. And in here, for the search endpoint, there is nothing offline first about this, since we don't cache all the books from our search. That would be a good homework for you, but that's something I won't do in this video. This one will be super simple, since it will just delegate the call to our data source. So we have a search books function. We just need the query, and it will then return our result. Now with a list of books that will become important, as you will notice in a moment, with a data error remote. Just like this. And here we can then simply return remote book data source, search books, pass in our query. And you'll notice that this now gives us a type mismatch, because what we expected was a result that consists of a list of books, but we got a result that consisted of a search response DTO, which is exactly what that remote book data source returns. That is our data transfer object in the end. That is our Kotlin representation of what the API responded. So what we now need to do is we need to take this DTO and somehow bring this into a format that we can use across the app. So a list of books in the end. We somehow need to take all those books that are contained here in this results list, all those search book DTOs, and for each and every book, we need to take it and map this to our domain level book. And for that, we use so-called mappers. So a mapper will just map a data model to a domain model. We could put this also here in data in a mappers package, for example, and create our, let's call it book mappers. This will really just be a file of extension functions where we will say we have a searched book DTO and we want to be able to map this to a book, so to a domain model. And here we really just construct a new book out of the search book. So the ID will be the ID, title will be title, image URL will be, no, here we actually don't have this image URL. In this search book DTO, if you remember, we have this cover key and this cover alternative key. So those are two keys that we can use to fetch the cover information about a book. So here, I actually want to also paste this URL. You can quickly type this off, but this is the URL that we need to request when we want to load an image. So covers, open library org, b, audit, whatever. And here we then have to pass in our cover key, but we want an if check. If our cover key is not null, so if it exists, then we want to load the cover from this URL, and else there is an alternative URL. So as I said, it's quite a difficult to understand API. Also took a bit to actually understand how this works. But if this cover doesn't exist, it could still mean that this one exists by making a request to this URL. But from this point on, where we then mapped such a search book DTO to a book, we don't need to worry about that anymore, since we just need this logic here at a single place. Next up, we need the authors list, which is nothing else than our author names. The description will be null here, since we can only fetch that from the separate endpoint. What is the issue here? Okay, well, if the author names is null, we will return an empty list here. Then the languages is equal to languages. If that is null, empty list again. First published year is first published year. That can stay the same. And this is, it's an integer, but required a string. Let's say that toString. So this would print null if it doesn't exist, and otherwise it uses the publish year. Then we have the average rating, which is ratings average, rating count, ratings count, number pages, is number pages median, and lastly, number editions is number editions. And if that doesn't exist, we will say 0. So we now have a mapper, a function that maps one object to another, to a book in the end, which we can now make use of in our repository. So where is it? Repository here, which you can make use of here to take this, the response here, map this. So this map function here comes from our helper utility functions here from this result class, which maps one result of type T to a different type of data, for example, R. So from a search response DTO to a list of books, for example. So here we do get our DTO, and we can now map this DTO, that results, so the actual list of searched book DTOs, we can map these to books. So it.toBook. And then we don't have any errors anymore. So this is really the responsibility of your data layer here, at least one responsibility of your data layer, to take the DTOs, to take your possible entities, that is how we call the data models that we save in a local database, to take these and map these to domain models, so to a format that the rest of the app is able to use. But right now, if we would actually have a reference of this default repository in our view model again, like here, default repository, we would again have this data reference here, actually this one. So we can have an import from domain, from presentation, book list view model is in presentation, with an import from presentation to data, which is not allowed again. So how do we work around that, or how do we fix that? This now again works with an abstraction. So whenever you need to access something from data in presentation or domain, you need to work with abstractions in this architecture here. So the way this works is we get rid of this. Let's do this in a moment. But the way this works is we now create an abstraction for this repository in domain. So we say book repository, make this an interface, have our search books function that takes in a query and then returns our result of type list of books and data error remote. So you can see this abstraction, because it now works on domain models in this case, we don't have any reference to somewhere outside of the domain layer, because we are in the domain layer and domain is not allowed to access anything outside of domain, which we also don't violate that way. So all imports here are from domain. If we now go to our default book repository, and actually make this implement our book repository, then we do have an import from domain here, but here it's also allowed. Data is very well allowed to access classes and interfaces from domain. So if we now go in here and make this an override function, we don't have any errors anymore. And if we now go to our view model, where is it? Book list view model, and we swap this default book repository out with a book repository, and then optimize our imports, we suddenly fix this problem, because now our presentation layer does not have any references on data anymore, but just domain. And this is again allowed. Again, recap. Presentation has an error to domain and data as well. Presentation is allowed to access domain, which we do here. Data is allowed to access domain, which we do here a lot of times, but domain has no errors outside of it. So here we only have our domain level references. So that is why the architecture is the way it is. I hope this is clear. Let's also call this book repository. Since now we implemented our data layer, at least to fetch books. And I know this was a lot of work to actually get this to a point where we can make an HTTP call. But from this point on, if your project scales, it's really very easy to add more calls. You would just add another function here to your data source to fetch book details, for example. And then you just have another piece of code that looks like this to do that. And you can call it right away. Everything else will be handled in the background by our utility functions. All right, so I would suggest we go on in our book list view model so that we get to a working search screen here in the fastest time possible by now making use of our book repository and actually calling that endpoint that we've implemented now. And in order to trigger our search, we need to listen to state changes of our search query field. This we can do in a separate function, can be private function observe search query, in which we say state, so our state flow, dot map. We map this to our search query. We say distinct until changed. So this means that we ignore emissions here in this flow chain when these are the same. So first of all, we have our state, which is the whole state, the whole data class. We map this just to the search query. So we get string emissions whenever the search query changes, whenever you type something. We say distinct until changed. So we drop all subsequent emissions. So all emissions where these are actually the same. Then we can say debounce and add a 500 millisecond delay here. Also Alt-Enter on debounce to add this to your view model class. What debounce will do is that it will really only trigger the search if we stop typing for at least 500 milliseconds. Because typically we're typing quite quickly and we don't want to make an actual API call for every single keystroke, which would be quite bad, but only when the user actually decides to execute the search, when they stop typing. And this is what debounce will do. And then we can listen to each emission, so to the queries here, where we can then check when the query is blank. So if it's empty, then we update our state. So state update, it copy. We make sure the error message is reset to null. And we want to set our search results to our cached books. So cached books will be a simple list here that we where we just cache the last loaded list of books, so we can quickly update it if we clear the search query. So it's not really cached persistently in our persistent storage, but just in memory here in the view model by having this private var cached books list, which is just an empty list here of books. So we can then go down here. So if we cleared our search query field, we will simply show the last loaded list of books. Otherwise, if the search query dot length is, let's say, at least 2, then we want to trigger our search. So we say something like search books with our query. This will be a separate function. But what's also very important is that after this on each block, we call launch in view model scope, because otherwise this whole flow chain won't do anything. We need to explicitly launch it in a coroutine scope. So what this will do is whenever our search query changes, this will trigger. We will debounce it so that we only consider cases where there is no emission for at least 500 milliseconds. And for each of those emissions that falls under this criteria, we will then execute the when expression and ideally trigger our search. So in our new private function search books, we pass in our query to now execute the search. Here, the first thing we want to do is we want to update our state to say we are now loading. So is loading is true. Then we want to say view model scope.launch, since searching books is a suspending function and we need to execute that in a view model scope. And here we can now make the call to our book repository. The book repository, search books with our query. Then we want to check for success and error cases, which we can do with these lambdas. If that was successful, we get the search results here, which is a list of books now. In that case, we want to update our state. So update. Is loading would be false again. Any errors will be cleared if we got a successful response, of course. And then, most importantly, our search results will be the search results we got from the API. If something went wrong, however, we do get the error here, which is now a data error remote. So we know we have a type safe information about the error type that we have here, which is why I really like to work with this type of result class that I've shown you here. So if there is an error, what we want to do is we want to also update our state, of course, where we say the error message. Well, let's start with the search results. The search results is an empty list. So we just reset these. isLoading will also be false when we got an error. And the actual error message will now be a UI text. And this is now also, again, very handy that we have this UI text, because now we can simply write extension functions for each type of set of errors in our presentation layer, and then easily convert these to the right string resource here. So the way this works is we can go to our core presentation layer. So just shared presentation related utility, where we say data error to string resource. And here we will really just take these data error remotes, or just a normal data error, and we say to UI text. This will now return a UI text. And here we can then have a when expression, when this, so the data error. Alt enter to add these remaining branches. And let's actually, first of all, declare the string resource here, and then return the UI text afterwards. If the disk is full, then we can actually, let's create these string resources now in, where is that? Here's values, strings. And for all of these different error cases, we now want to have a separate string, disk full, for example. We try to insert a favorite book, but the disk is full. Oops, it seems like your disk is full. Something like this. Then we do have an unknown error. Oops, something went wrong or so. We do have a request timeout. We say the request timed out. No internet. I actually like to prepend these with error, since that makes it very easy to find all the error related strings. So for missing internet, couldn't reach server. Please check your internet connection. Then we have, let's keep this here. Then we do have, what else? Quota exceeded, too many requests it's called. Your quota seems to be exceeded. We have a serialization related error. Serialization couldn't parse data or so. And what else do we have in here? Serialization, server related errors will also just be an unknown error, since we don't want to show the user that something went wrong on our server. That could be bad for security. And other than that, that's it. So let's get rid of the last one. Make sure to make our project again. And maybe we can already access these. Let's try this out. ras.string.error. No, not yet. We do get an error here because our vModel is now has a constructor. Let's ignore this for now. Do we have access to our string resources? Error. Now we also get this pop-up. Come on. I want to try this. Error. Yeah, error disk full. Now it works. Let's do this for all of our different strings. This one would be error unknown, error request timeout, too many requests, no internet. This will also be unknown for the server side error, as I said, serialization, and this one will be unknown. Cool. Now we have the string resource, and we can simply return this as a UI text dot string resource ID, and we pass in that string resource. And now wherever we have a data related error, we can very easily parse that into such a UI text. So we don't need to have this when expression at each and every place in each and every vModel over our project, where we need to parse a data related error into a presentation readable error message. And it's all fully localized if you want. So you can just translate your app thanks to string resources. So here we simply say error.toUI text. And there we go. That's it. It's all really just utility. You have to write once for each type of error. So you might also have such an error class for password validation errors, where you have strings like too short, strings like not a valid password, things like missing a special character. And then you have another extension function for that also returns a UI text. And at all places where you have password validation errors, you would then call this function. So I hope the idea of this gets clear. We now have this search box function, and let's actually move this call in here and set this function equal to the vModel scope, and also get rid of the last closing bracket here, because that way we will also return this vModel scope job that is returned, so the running coroutine job. Since what we want to do is, if there is an ongoing search and we then change the search query, we want to cancel the previous search, because that doesn't matter for us anymore. So what we can do is, up here, we have a private var search job, which keeps track of our current coroutine job for the search, like this, initially null. And in here, we will then say the search job is equal to this, and the previous search job we simply cancel. So the moment we type something new and there is an ongoing search job, we will cancel it. And we instead start a new one. That is what happens here. All right, now we just need to call those functions to observe the search query and to search for the books, of course, which actually happens inside here, which I want to do here. When we listen to our state, the reason I want to load this initial data in there is that it's easier to trigger this from test cases. So this will now trigger when flow collection starts, when our UI starts to listen to the state. Many people will do this in the init block, which will work just fine, but it is kind of a side effect of initializing your view model. You won't be able to initialize your view model without also triggering all that initial data load possibly. This can lead to problems in tests, doesn't have to lead to problems. If this is not a problem for you, feel free to use the init block. There have been lots of debates about this. There is no single truth about where to load initial data. I also have a separate video about that, which I made a few weeks ago, but I will use the onStart operator of this flow. So as soon as we start listening to this flow in our UI, when we call collect state as lifecycle, then this will trigger for the first time. And only if our cache books are empty, so only for the very first time, we want to start listening to our search query. Because this onStart operator would be called again when we, for example, navigate to the detail screen, wait for some time and then go back, then flow collection would start again, but not if the cached books are actually already contain some cached books. Then we would not call this and rather skip it. This here then needs to be state in view model scope. So we just get a normal flow out of this onStart, not a state flow anymore. In order to convert this to a state flow, we need state in. Sharing started while subscribed with 5 seconds. So this means that while there are active subscribers of our state, we will execute this whole flow chain here, and 5 seconds more than that. So for at least 5 seconds more when the last subscriber disappears. And the initial value is just our state.value, just like that. So that way we just trigger the initial data loading here once, or we trigger listening to that flow once, and from that point on we'll be good. Okay, as much as I would like to try this out already, I think we can. Let's try this out as it is without making any more changes in a very quick way by going to our application composable here, where we initialize our view model, and let's really just initialize our dependencies in here just to try it out. Normally, I would never do this here, and you will also see in a moment how we will solve this in a better way. But let's initialize our default book repository here. Let's initialize our remote book data source here with a Ktor remote book data source. And here we need our HTTP client, for which I quickly want to create a factory, since creating that involves a few things, which we need anyways later on. Let's do this here in core data. HTTP client factory. So factory pattern is simply a class that has the purpose, the responsibility to construct a bit more complex objects. So here, this can be an object. We just have a function create. I want to pass in an engine that we want to use with Ktor. So Ktor works with these engines that, where some of these work on the JVM, that work for desktop, but then not for iOS, for example. So depending on the platform, we want to pass in a different engine here. This will return an HTTP client, which we can create here with HTTP client engine like this. And here we can now install certain plugins from Ktor. So depending on the functionality you want to use with Ktor, there is a plugin for that. For example, if we want to be able to automatically parse JSON responses into our data classes, then we need the content negotiation feature, which will do that for us. In here, we can then configure how our JSON parsing library works, how that is used. We can use this JSON function to say we want to use Kotlin X serialization. And we want to say the JSON that is used here, the JSON object with our desired config, will on the one hand ignore unknown keys. This will be true. That's actually the only thing we need to do here. But what this will do is if there are more keys, more fields in our JSON response that we don't explicitly need in our data class, then these will be ignored. So our app won't crash because of that. Then what we can do is we can install an HTTP timeout, so that we can set the timeout of our requests when we don't get a response for a certain milliseconds. For example, the socket timeout milliseconds, and set this to 20 seconds. Same for the request timeout milliseconds. And here we can then go on with installing features, for example, call logging. Do we have that? Or is it just called logging? Yeah, logging. So that will simply log our requests, which will be very useful for debugging. We can set the logger here to an object of type logger from Ktor. Here we can then override this log function, and let's just use a super simple logger by printing these. So by printing the log message. And we can say the log level that we care about is log level all. So we want to see the whole request that is being made in our logcat. And lastly, we want to say default request. What we want to configure for each and every request in our application. And that is that we want to set the content type to application JSON. Because every request is working with the JSON data, and we need to press that here with a content type header, so the client knows what kind of data it can expect. And now we can use this factory to create an instance of our HTTP client here in our app Composable by saying HTTP client is HTTP client factory.create. And well, which engine do we actually pass in here? This engine, as I said, is dependent on the platform. On Android, we can use a different engine than we can on iOS, than we can on our desktop. So we somehow need to pass these in from the outside here. And for now, let's just pass these in here. That won't stay like that, but the engine will be an HTTP client engine. And from wherever we now call this app Composable in our platform-specific code. Oops, this does not look correct. Let's do this. Here, where we create this app, we can pass in an engine in form of remember block, where we say this one will be OK HTTP, the client engine here, not create. So for Android, we can use the OK HTTP engine that drives our requests. Let's get rid of the preview here. Then we need this app Composable in desktop. On desktop, we can also use OK HTTP since it's also a JVM environment. So here we can say the engine is remember OK HTTP. .create. And lastly, in iOS, that we can't use OK HTTP since iOS is not a JVM environment, but here we need to use the Darwin engine. So remember, this will be darwin.create. Darwin comes from our libraries. So in case you need to add something like that, just to a specific platform, here in your build.gradle file, in your source sets, you have this native main, for example, which works for macOS, iOS, and so on. Here we then add this Darwin engine that is then really only available in our iOS main module. This way, we should now be able to go to application and construct this HTTP client here with our engine. And I think this should be ready to try out. It says we have an error here, but apparently not. Let's run this. Let's see if we can search for books. No, okay, we do get some import issues here. No favorite books. Yeah, let's get rid of that. Or what is the issue with that? Okay, apparently, did I remove that resource? Let's quickly take a look. Maybe I accidentally removed that in our strings XML. Apparently I did. Let's duplicate that again. No favorite results. No favorite books yet. Just like that. Try this again. And okay, do we need to make this again? No favorite books. Did I call it the same way? No favorite results. I'm dumb, sorry. No favorite books. That is how it was called here. Do this one more time. Yes, it's launching. And it's loading. And it's crashing. Let's take a look. We get a big error message. Okay, what's the issue? Let's debug this together. We do get a serialization exception, JSON decoding exception. Okay, we actually need to catch that as well. Unexpected symbol O in numeric literal at path cover addition key. What's that? So the way we need to debug this is we need to take a look at exactly this sequence. So it says, okay, we had this docs field, which contains our search results. The first result is affected, and specifically the cover addition key is somehow off. There is a certain character in that cover addition key that it did not expect. specifically this O. My guess would be that I'm trying to make this an integer maybe, and it's actually a string, but we can only take a look to find out. Search book DTO. We have this cover edition key. I said it. This must be a string because, parsing a string into a string is obviously not an issue, but parsing an O into an integer very much is. So let's relaunch this and take a look. There we go. We again see our dummy books for a moment, but then we are loading some results. And there it is. We see our books. We can probably give this the loading indicator some width, so the same width as the book covers. So these widths don't vary here. This is pretty much a working book list. Awesome. And if we now search for something, there aren't any books for your search query. Okay. We search for Harry Potter again, 500 milliseconds delay, and then we search something. And there it is. There are our Harry Potter books. Isn't that cool? Can't yet click on these, nothing happens. But if we also take a look in Logcat, we will see all of our requests being made, and we just get the fields that we actually asked for. Very cool. I think this is our first real milestone here in this project. Has been quite a lot of work, but we're not where we want to be yet. So I think as the next step, now that a very important part of the functionality is working, as a next step, I would just organize the code base a bit better. So that means I want to set up Koin for having a proper dependency injection setup. That means that we don't want to do something like this and initialize everything in our composable, but rather have our dependencies or actual class instances at an organized place and be able to easily inject these wherever we need these. After that, I would like to set up our navigation graph so that we can that we have everything we need in order to get into the detail screen and actually also jump from this one to the detail screen when we want that. Okay, in order to set up Koin, our dependency injection framework, and I will also explain in short at least what that is in a moment, why we apply dependency injection in the first place. But in order to set that up, we need so-called modules, which are in the end just containers for our dependency. So what is a dependency? I've mentioned that before. A dependency is nothing else than an instance of a class that we might want to use in our project. So just something another object might depend on. That's why it's called dependency. Don't confuse this with Gradle dependencies. So that's also kind of a dependency since our project depends on these libraries. But in our code, when we talk about dependencies, we mean instances of classes like this book list view model, this repository, this data source, and so on. And the reason why we want to have a proper dependency injection setup, so dependency, class instance, injection, passing this class instance to another class instance, passing this book repository to this view model, for example. Why we want to have this is, well, because this right here, if we would have this in our real project, would be rather terrible, because while this works, what would happen if actually another class would actually also need to make use of exactly that repository instance or that data source or our HTTP client? So it's very likely that if we have multiple different data sources in a project, then all of these could use the same HTTP client, because the config of the HTTP client is likely going to stay the same across multiple data sources. So we need a central place where we manage those dependencies, and from where we can then take these and pass these wherever we need them. This will also make things much easier when we actually want to test our code. Because what happens if for our test code, we actually don't want to use our real repository, but a fake one that does not make the actual network calls, but just simulates them for a test case? Then right now, we would be forced to always pass this default repository here. But if we use a dependency injection framework or just proper DI, which in its simplest form is really just passing stuff to constructors, if we do that, then we're also flexible in deciding what to pass where. So as I said, with Koin, our chosen dependency injection library, which is the typical library we use for that in a KMP project, with that, we need so-called modules. So a module, just a container for such dependencies where we kind of teach Koin how certain dependencies, how certain class instances are created. That's, of course, what it needs to know. It can't guess how our HTTP client looks like. So in our common main, we want to create a new root package here in Bookpedia called DI, dependency injection. And in this DI package, we will create a modules file. And now if you are maybe already familiar with DI on Android, for example, then one new concept that we will actually have to work with in Compose Multiplatform projects like here is that certain dependencies, certain class instances are only for specific platforms, or the actual creation, the instantiation process of these differs depending on the platform. But some of these we can also just create in our shared code right away, since for all platforms these are the same. So these are just some things we need to keep in mind here. And that's why we'll have, on the one hand, a shared module, which is the container for our shared dependencies. So this will be a module. And in here we can now define singleton dependencies, so where we really just have a single instance across the lifetime of our application with single or single off. So with single, we actually get this lambda block here where we can now say, okay, this is how our class is instantiated. For example, Ktor remote book data source. We need an HTTP client, which we don't want to create in here because we want to have that as a standalone dependency. So we can also pass it to multiple different instances. So we might want to, first of all, make a single for our HTTP client. And we create that with our factory.create. And well, what is the engine of that? The engine is the first thing that now differs depending on the platform. So you've noticed what we've done before. For iOS, for example, we want to use this Darwin engine, while for Android or desktop, we use the OKGP engine. So this dependency, the engine, differs depending on the platform. And this is, of course, a problem that we only face in a multi-platform project and not on native Android, for example. But we know we definitely need to use OKGP. So this is something we will work with in a moment. For now, let's just write get here, which kind of instructs Koin to get a dependency, at least to try to get a dependency. But if this dependency is not provided, that's how we call it, with such a single block that Koin doesn't know these, then it would crash, obviously. So we still need to keep in mind that we also provide this dependency at a later point. We will do this after declaring the shared module. But now that we have a single block for our OKHTTP client, or Ktor HTTP client, of course, we can also say get in here in the Ktor remote book data source, because now Koin knows, okay, this is how I create an HTTP client. And here we need an HTTP client, so let's just take this one and pass it in there. That's really the whole magic to the eye. And before people comment, yes, Koin is strictly seen as a so-called service locator. So we just have a pool of objects, and when we need one, we just try to access it from that pool of objects. So it's not really DI, but we get the same advantages from using Koin than from a library that uses real DI, like Dagger, for example, on Android. But we can improve this a little bit, since now, if we actually construct this Ktor remote book data source and our constructor actually changes, so we might want to add another field, another class instance that this might depend on, then we would always need to go back here and add another piece of get here. This is not ideal. So instead, what we can do is we can use single off, which will just instruct Koin to try to create the instance with dependencies it has already available. So we can say, Ktor remote book data source, put a double colon in before. And now for all the constructor arguments in here, Koin will just try to check if it has these available, if we provided these before. Something we also want to do is want to call bind afterwards and make this a remote book data source, because this is the actual type of the dependency we pass, but this is the implementation. So here in our repository, where is it? Book data repository, default book repository. Here we actually don't pass a Ktor remote book data source specifically, but the abstraction of it. And to instruct Koin to use this specific implementation, we use bind. Something we then want to do is we want to provide our default repository. We always need to remove these double colons before, then import this and then prepend these. Then bind this with our book repository this time. And then the last thing we can provide for now is our view model. View models are provided a bit differently here in Koin. We need to use this view model off this time and say booklist view model with double colon in before. This does not consist of an abstraction, so we don't need a bind here. But what's missing now is this engine. So we need to kind of instruct Koin to say on Android and on desktop, we want to use OKHTTP. And on iOS, or native in general, I want to use Darwin. And here we need to first of all introduce a concept that Kotlin multi-platform projects introduce. And that's a new keyword, or a new set of keywords called expect and actual. So the thing is, this engine that we create here is used in our shared code, because every HTTP client instance certainly needs an engine, but which engine we use, that differs on the platform. So it's not the case that we just need an engine on Android, then we would just put it in Android main, but that on all platforms we need an engine, but the engine implementation differs. And whenever you have that problem, we need to work with an expect val, which is really kind of an abstraction in our shared code, where we expect to have a certain type of object, which we might want to call platform module, which is a Koin module, which then contains the platform-specific dependencies. And if we declare this as an expect val, then it's really comparable to an interface where Kotlin Multiplatform now expects us to have actual implementations of this platform module for each and every platform, where we say, okay, for Android, the platform module looks like this, for iOS, it looks like this, and so on. You can also see this here. We can click on add missing actual declarations. We want to have these for our iOS main, desktop main, and Android main. And then click OK. And there it is. Here we have modules Android with an actual val now, where we have the actual implementation of this module, module desktop, and modules iOS. So for Android, as I said, we want to make this a module. And here we can now provide our singleton engine with OKHTTP, because here we are in an Android environment now. We are in our Android main source set or module, and therefore we have access to JVM dependencies. It's important that we also specify that this is an HTTP client engine. So whenever we try to inject that, it will use the OKHTTP engine. We can then copy this, because for desktop, it will be identical. Here we also have access to OKHTTP. But for iOS, you will notice if we paste this, it won't be able to resolve this, because in iOS, we don't have access to OKHTTP. Here instead, we want to use Darwin. And now that we have such an actual implementation of this platform module for every single platform, Compose Multiplatform will know, okay, for iOS, we will use this engine, and for all the other platforms, we will use the OKHTTP engine. Other than that, what we need to do is we, of course, need to instruct Koin to use these modules. Right now, those are unused. We can go to our common main, di, create an init Koin function init Koin, which just initializes Koin and tells it which modules to use. We can pass in a config, which is a Koin app declaration, nullable, and null by default. This in the end is kind of a lambda hidden behind, I don't know what that is. It's a type alias, so it's really just a lambda here that extends Koin application that lets us configure a specific Koin setup for a specific platform. You'll see in a moment how this works. But we just want to call start Koin to start our Koin library. We then call config.invoke with this. So we get this Koin application scope here, and then we can declare the modules we want to use with our shared module, as well as the platform module. So we now do have access to the platform module in our shared code because we used expact val here. We don't have the actual implementation of this here, but we do have an actual implementation for every platform. So we can certainly make use of that in the shared code as well. So where do we now call our init Koin function? Well, every platform now has a certain entry point. On Android, that's, for example, our application class, which has an onCreate function. And we, in the end, just need to call this once per app launch. So, for example, for Android, in Bookpedia, we can create our book application, make that a class, make this inherit from application, and then we can override onCreate in here. And this is the place where we can now call init Koin. You can see we can pass in a lambda here to further configure this, really just for Android this time. So if we had a certain module that contains dependencies that we just want to use on Android, not like our engine that we use on all platforms, but if we have dependencies that are really just required on the Android platform, we could also add these here with further modules. We don't have this in our case, but something we do need for Koin on Android is, on Android we have this concept of a context, which is really unique to Android. And we need to instruct Koin to know this context with Android context, so that if this context is needed to construct certain dependencies, Koin knows how to retrieve this. So here we can just pass this book application. We also need to register this application in our Android manifest. So we can open this. In the application tag, we say name, book application. So this is how we start Koin for Android. We can then do the same for desktop. Here it's a bit easier. Open our entry point, this main function. This application here is composable, so we don't want to call start Koin in here, which would be a side effect that would call with every recomposition, but rather cut this out and make this a normal function body and just start Koin before drawing our window. Here we don't really have any extra config, so we can just call start Koin like this. What is the issue? I actually called it init Koin, of course. Init Koin, and then we don't have any issues with that. Lastly, on iOS main, open the main view controller. And here in this Compose UI view controller, we do have a function, this configure function, which also calls just once, where we can init Koin. So this should be everything we need in order to be able to now inject these dependencies that we've provided in Koin. We still need to adjust our setup here. So this application class should not now take an engine because it doesn't need that. We can remove this, go inside of application, remove the engine here. Then we suddenly can't construct these dependencies here anymore, which we don't need because we have these in our Koin modules. So let's rather get rid of all that, because the only thing the screen, the actual UI now needs, is the instance of the view model. And the view model gets all the rest of our dependency chain. It gets the repository implementation, the data source, the HTTP client, all behind the scenes. But in our UI, we really just need the view model. And this works with val view model is equal to Koin view model. This is just used to check if there is a view model implementation of our book list view model. And if so, Koin will retrieve it and properly bind it and couple it to our composable screen. We can then pass this here to our book list screen root. And here, since the book list view model takes in the repository, Koin will automatically also create this chain of dependencies that the view model relies on, depends on, and inject these automatically. So this way, we should still be able to actually launch our app and use it just like before, where we had this remember block here. No, we're not, because we did not fix these remaining issues where we pass in our engine, of course. Let's remove this. Same in desktop main here. Try this again, checking this on my device. There we go, it's launching. And that looks hopefully good. I'm not sure if it crashed because it flashed a little bit. Was there a crash? No, it seems like it was successfully loaded. If we, that's a very long log here. Yeah, let me just relaunch this quickly. Then we should see this once and for all. There we go. Yes. Okay, the flash was just because we have our dummy books, which we can actually remove now since we are able to load books from the API. So where did we declare these? I think in our state class. Did we? The book presentation. Book list state, yeah, let's remove these dummy books and just make this an empty list, because if we then launch this, also in our preview, in the preview we actually do need the dummy books. Let's put these then as a private val in the preview, but not assign this to our state. So we go to our preview. We need to extend this a little bit here. In our preview, we can then put our list of dummy books, make it a private val. So we do have it for our preview, but not for our initial state. Let's open the preview again, like this. If we now relaunch this, then we should not get this flash with our dummy books, but we should immediately see the loading indicator. No, we did not, because the loading value is false by default. Let's try this once more. Yes, now we get it immediately. And then we load the books and we see everything. Very cool. So we now have our dependency injection setup in place. And when we now add more classes, more instances to our code, it's very easy to extend this by just defining the declaration here in our modules, in our shared module or platform module, depending on the dependency. The next thing that I would like to do, as I said, is setting up our navigation so that we have everything set in place in order to then get to the detailed screen. Where should navigation happen in a Compose Multiplatform project? And what do we actually use for navigation? Well, I would recommend to use the official navigation library that comes from JetBrains. It's usually a good idea to stick what comes from the makers of something. Not always, but for navigation, I would say so. There are other navigation libraries that you can also use, like Voyager, Decompose, which are also quite decent. But since I'm just so used to using this navigation library from Android, I also want to use it here. And our app Composable is the perfect entry point for that. So let's go in here. And first of all, let's wrap everything with our material theme. So we also get proper theming values. And in here, we can then declare our nav controller, which is the central instance that we use to jump from one screen to another. We get that with remember nav controller. And we can then declare our nav host. So the nav host is really just the place where we say, okay, this is our nav controller. This is our start destination, our very first visible screen. And here we have all those composable screens that we want to have in our app and that we want to be able to navigate to. So here for the nav host, the nav controller is just our nav controller. We've created above. And then we want to have a start destination, which is of type any here. Because Compose navigation, Compose Multiplatform navigation now also supports the type-safe approach. So that means we have really type-safe routes without having to define any string routes anymore, like a web URL. That was very error-prone, but now with type-safe navigation, this is a lot better. And I would like to define these in a separate file. Let's actually go to our Bookpedia package and create an app package. So this is just the logic that is used to really wire things together. So typically this would be navigation, this would be just initial setup of something. And this app package is allowed to access any other features and packages in our project. So here we don't have these constraints with domain data presentation, because if we think of a multi-module project on Android, then we would also have an application module, which is the entry point for our Android app, where we would define the navigation and all that stuff. But that is really something for the Essentials course. It's a 23-hour course bundle. This would be too much for a course like this. But in this app package, we can move in our app Composable, And then also define something like a routes class, or sealed interface rather. So we have a sealed interface for our routes, in our case, list screen, detail screen, where we can say we have a data object for our book list, which is, let's call it route, because we always deal with a single route. And this also needs to be serializable, because Compose navigation will then figure out a way to serialize this and pass it to another screen. In this case, our book list screen does not have any screen arguments, but the second screen, our book detail screen, does have arguments, which is why it needs to be a data class. We call it book detail, because the argument we need on the book detail screen is the actual ID of the book that we clicked on. So this will also be a route. Serializable, but this way we have type-safe arguments. We can create a book detail instance, say you want to navigate to this specific book, and then the navigation will just work. I also like to bundle each feature in an app into a navigation graph. So a graph is really just a bundle of multiple screens that all belong together, where we say data object book graph, which is also a route. And these are already the routes we need in this app. So here in our nav host, we can say the start destination is our route dot book graph. Then here we want to define this book graph with a navigation function. This is how we define a navigation graph here in Compose. We have to pass the class that makes up the graph. So it would be route book graph again. A graph, since it can consist of multiple screens, therefore also needs a start destination. So the first screen that shows up when we navigate to a graph, which in this case will be route book list. And here in this navigation graph, we can now define our actual screen destinations with these composable blocks. We also need to say this one is for the book list screen, which we can then put in there. And then we have one for the book detail screen, which we have in here. We can then easily extract the arguments that we use to navigate there from args, or this is actually just the backstack entry, but the args we can then retrieve with entry.toRoute, which will then return our route book detail. And then in our args, you can see we find this ID, so we can work with that. Something we now can already do here in our navigation graph, when we click on a book, we do get the book reference. What we certainly want to do is want to use our nav controller and now navigate to our detail screen. So we say nav controller, navigate to, navigate, and we want to get to our route book detail screen. And we now need to pass in the ID of the book we want to navigate to. And guess how we get that? Well, from this book reference, of course. So we pass in book.id. And then for now, we can really just put in a dummy box in here for the book detail screen, modifier fill max size or so. And then I actually need to import this. You might also want to center something here where we say content alignment center. And here we might have something like a hello world text. Or we say book detail screen. The ID is args.id. And if we now actually launch this again and try this out, we should be able to navigate to the detail screen. So this is really how easy we can now set up navigation with Compose Multiplatform, thanks to this type safety. Before that was really a pain. We now have a book, and when we click on that, we get to our detail screen. So you can see the ID is actually /works, blah, blah, blah. That's actually something we need to adjust because the actual book ID is what comes after this /works. So we do need to adjust this in our book mappers, since this /works/ID comes from the API, but we only want to have this in our project. So we want to go to our mappers, where we take the API book and map it to our domain book. So here for our ID, we don't just want to take the ID, but we want to take the substring after last and pass in this /. So we will just take the string after the last slash in this long string. So if we relaunch this, then we should be able to just see the real book ID after loading some books. Click on this one here. Yes, now that looks much better. However, one problem we have with this API is that there is no real dedicated book detail endpoint that contains all the data we need. So there is a book detail endpoint, but the only kind of extra data that it adds is the description, but it then lacks all the information about the book that we already have fetched before, like this one here. So the only real way to get this information of a book again on the book detail screen is, then we would have to execute the search for that book again and then refer to the first item of that book list, which is of course everything but ideal because we're making an API call for a book that we have already fetched. Well, if you would now have a real local cache for all the books, so you have you fetch them from the API, and the moment you load them, you just insert them all in your local cache. Then you could just load a book on the detail screen by its ID from your local database. That would be super fast. And this is the typical way how this works when you have a local database and a remote API. However, we don't have that. We don't cache all of our books in our local database, but just the favorites. So we somehow need a better way, a different way to actually still get the book information that we've already loaded on our detail screen, while not having to pass such a big book difference, such a big book instance as a navigation argument. Because generally it's really discouraged to pass big data as navigation arguments, since there are limits to how much we can actually store in a bundle. That's how it works internally on Android. So if this book gets more and more fields over time, and especially if it has lists like authors, where you don't know how big these might be, then in certain cases your app could crash because it's just too big to navigate with that object. And whenever you have such complex data that is hard to serialize, or that could just become very large when serializing it, but you still need to share that between multiple screens, then it's typically a good idea to implement a shared view model. So while our normal view models that we've declared in our app here, the book list view model, that is really just bound to the backstack entry where we're currently in. So from this book list screen, it's really just bound for the book list screen. And when this screen is cleared from our backstack, then the view model will also be cleared. But what we now need is, we need a view model that both book detail and book list are able to access. So the same instance of the view model needs to be shared between two screens. And this works when we have a navigation graph, because a navigation graph also has a backstack entry. So we can take a view model and scope it to the entry of the navigation graph instead. And the navigation graph will stay alive as long as any of these screens in the navigation graph stay alive. And that's exactly what we want. So if we now go ahead in our book feature, in our book list package, actually not book lists, but just presentations, and so now we have a shared view model. We can call this shared or just selected book view model. And this will be a super simple view model. It really just has the purpose of sharing data, sharing the selected book. We do declare this in here, a private val selected book, which is a mutable state flow, which is initially null. So initially we did not select a book. But if we do, it's certainly a book instance. And then the public variant of that selected book is, selected book as stateflow. And then we have a function on select book, pass in the book, nullable. And here we really just update our value with book. So this is how our shared view model looks like. That's really all the code we put in this, since it really has the purpose to just share the selected book. And this is what I can highly recommend you if you really need a shared view model, which you often don't. Very often there are much better ways to share data, like passing it via navigation arguments, like reloading it then from the database, like just persistent storage in general. But in cases like these, a shared view model is very reasonable. But what many people would now do is, they would create one big God view model that is shared between these two screens, which has all the logic for the book detail screen and all the logic for the book list screen. But I can only highly recommend you, if you create a shared view model, just create it for the state that needs to be shared, and rather use two view models per screen than one that contains all the logic for all screens. So with this selected book view model, which now has to be shared, we can go back to our app composable and declare this here. And for that, I will actually create a little utility function, which you could use for any shared view model on Android or Compose Multiplatform. Will be a private inline function actually, which will get a reified T of type view model. So it works for any type of view model in the end. It will extend a nav backstack entry, and we call this shared Koin view model, because that's what it is. Alt enter to import this nav backstack entry, and in here we then pass in our nav controller reference, because that's also needed. It will then return our type T, so the view model we want to create, we want to share with that. And first of all, we now need to use the nav controller, or rather the nav backstack entry, which is the one where we call this function in. So either the nav backstack entry of our book list screen or the book detail screen. We now need to use this nav backstack entry to fetch or to retrieve the parent backstack entry. So that will be the entry from the book graph. Since this is the backstack entry, we want to scope the view model to. So here we can say val nav graph route to first of all fetch the route of the parent nav graph. And that's equal to destination, so the current destination, book list or book detail, dot parent, which is a nav graph, dot route. And if that doesn't exist, we can just return a Koin view model here of type T. We also need to make this a composable here, by the way, composable function. Then we get rid of these issues. And now with this nav graph route, we can get access to the parent entry, so to the actual backstack entry of our parent navigation graph. We can say remember, where we pass in this as the key, so the nav backstack entry. So whenever that changes, this will re-execute. And here we say nav controller dot get backstack entry, and we pass in the nav graph route. So we now have the backstack entry of our navigation graph in this parent entry, and we can then return a Koin view model where we say, okay, the view model store owner is now the parent entry. So we explicitly scope this view model to our parent nav graph rather than to this navback entry that would just scope to a single screen. And this function really works for any type of navigation graph and any screen feature structure that you have now. So you can really just copy paste that in your project and it will work. But what we can now do is in here, book list, we can say val selected book view model is equal to it, so the backstack entry, that shared Koin view model. The specific view model that we want to share here is the selected book view model. And here we pass in the nav controller. Let's also move this somewhere down here. It's a bit unlucky. Like this, I think it's a bit better. And if we now have the exact same line down here in our book list, book detail screen, here it's actually called entry. Let's remove this. We can also remove the arcs. I don't think we need these here. If we now call this here, this view model instance will be the same as this view model instance. So this one is now shared, while this one will only live as long as the book list screen is on the backstack. And what this now allows us to do is that we get the full book information we clicked on here in our detail screen. So what we can do is, instead of just displaying the ID, for example, we can also say we display the whole book. So actually have our state here, val selected book by selected book view model, selected book, collect as state with lifecycle. So we just collect that state flow as a compose state, and we then simply print this book here. If we then click on a book, we not just want to navigate, but we also want to update the currently selected book in the shared view model. So we say selected book view model on select book, and we pass in the book. And if we get back to this book list screen, then we want to reset the selected book again. And this works with a launched effect block with the key true, since this will fire whenever this screen appears somehow. So either when it launches the first time or when we get back from another screen. So here I want to say selected book view model on select book and pass in null. Because whenever we are on the screen, we want to reset the selected book since no book is selected at that point anymore. And if we now relaunch this, then we should be able to really get the full book information here on our detail screen, which you can then immediately work with. No, it actually crashed. Let's take a look what that is. The very bottom here. There we go. There's our crash. Here. No definition found exception. Oh, okay. Maybe you can already guess what this is. So it says Koin was not able to find a definition for the type selected book view model. And we should check our modules configuration and add missing type or qualifier. So what Koin complains about here is, you actually want me to inject a view model that I don't know how to create. So what we need to do is, need to go to our modules and actually have a reference to this view model here with this view model off. So for each and every view model, we need to say, we do have a selected view model, a selected book view model now as well. And the moment we register this here, Koin will know how to create this. In this case, it's super simple since it does not require any arguments. Still, we need to do that. So relaunching this. There we go. Our books are loading. And if we now click on a book, then we get the full book information here on our detail screen. So this is now what we can work with on the detail screen as well. If we select a different book, for example, this one, then we also get the different book information, as you can see. So now with this information, we can work with on the detail screen to simply display those book list details or the selected book details in a bit more visual way. So let's get into that book detail screen right now. Where do we put this? Obviously, as part of the book feature, It's a screen, so I want to put it in presentation. And since it's a new screen, we don't want to put it in the existing book list package screen, but we want to create a new one for that. So new package, book_detail. This one might also have a package for components, so for all reusable components that are just used for the book detail screen. And in the screen, we want to create, let's start off with our state. So book detail state. Same structure again, just like for the book list screen, just that this time we talk about the state that we need for the book detail screen. So any values that can change and have an impact on the UI. On the one hand, we have an isLoading value. Oops, not a book, which is false initially. Oh no, actually true. Because even though we have most of the book information immediately available on the book detail screen, there's still a missing piece we have to fetch, and that is the book description. So that comes from the from a separate API endpoint, and for that we can display a loading indicator. We can then have a val is favorite. That can change, which we will then use whether we want to make the heart icon filled with red or not. And lastly, we also do need the book that was selected in here, which is null initially. So you might now wonder, okay, don't we already have that in the selected book view model? Yes, but the logic to actually display that book and to do something with that just for the book detail screen will be in the book detail view model. So we need to kind of observe the selected book here in our screen, and then whenever that changes, also forward it to our book detail view model. So the selected book is kind of synced between these two. Next up, let's go to book detail and create a book detail action. So our CL interface that again couples what a user can do on that screen. On the one hand, that will be a data object on back click, book detail screen, book detail action, I mean. Let me actually launch the other app so you can see what we're actually building here. There we go. It's loading. If we now click on a book, oh, you can see I still have the red box here when I debug this padding issue. Never mind. Let's click on a book. You can see here is a back button that we should actually make in white or so. We will do this for this project. But when clicking this, we obviously get back. And here we have this heart icon. When we click this, we mark the book as favorite or not. So this is another thing we can do by saying data object on favorite click book detail action. And lastly, a data class on selected book change. We pass in the book. This can be non-null here, since on the book detail screen we certainly know that we have a book selected. Book detail action it is. And there we go. That's already everything we can do on the screen. And I would say, first of all, we get started with creating the reusable components. So specifically, that will be those chips that we have here together with these titles. And we will create a layout that will help us to draw this blur background here a little bit better. And we will do this in book detail components. So let's first of all create a book chip. So for one of these blue boxes, make this a file, book chip. We'll take a modifier for sure. It will take a size. So certain chips, as you can see, are larger than others. So the language ones are smaller than these ones. So we want to pass in a chip size, which we can create here with an enum class chip size, where we have small and regular, for example. So by the way, a recommendation I can also give you. Some people might work with a Boolean here rather. So they might have something like is small as a Boolean, which is true if we're talking about a small chip, and false if we're talking about a regular chip. But whenever you're working with a Boolean condition like this one, where the negated variant of that is not obvious to someone who does not know the code, so where it's not obvious what is small actually stands for, because that is not obvious. Does it mean that the chip is big? Does it mean it's regular? Does it mean it's XXL? We don't know. While for a Boolean like enabled, it's completely obvious that when we negate this, it's disabled, because there are only two different variants of this. When it's not obvious, even if you just have two options in your case, work with an enum class instead. This makes things much more readable, and you can extend this much more easily. So we want to work with the chip size enum class here instead. And by default, it's chip size regular. And lastly, we want the chip content here. So what is actually drawn in the chip, the text here, to be a composable lambda, like this. And this is in the end quite simple what a chip is. We can make this just a box. We say the modifier is our modifier here. We say width in again, where the minimum width of this chip is dependent on our size, our chip size. Oh, I actually kept it on is small, so this would be the size, of course. So depending on what our size is, we can add the remaining branches here. If it's small, then it should be 50 dp wide at minimum. If it's regular, it will be 80 dp. We can then say we want to clip this, so we have rounded corners, to a rounded corner shape of 16 dp. We then give this a background of our light blue, and we add some padding, specifically vertical padding of 8 dp and a horizontal padding of 12 dp. And then we get the look that we have here depending on our chip size. Furthermore, want to center everything in this box here. Center, and then in here we really just have the chip content lambda that we can call and add to our box. That way we are really flexible what we want to show here. Since for the rating we actually have a row with a text and an actual icon. For the other chips we don't have that, where we just have a text. Let's now next come up with an actual composable that helps us to show these chips with an actual title. This is what I would call titled content. Also here, titled content, make this a file, composable, titled content, which will obviously take the actual title I want to show. It'll take a modifier and again, a content lambda. In here, this will just be a column. So makes sense, I think, that the title and the chip are now arranged in a column-wise fashion. The modifier will be equal to modifier. We want to set the horizontal alignment to alignment center horizontally. And then in this column, we have the text that says the title. We can give it a text style from our theme, material theme, typography, title small. And after that, we simply draw our content. It's a super simple composable, but since we have multiple of these chips here, it makes sense to create a reusable composable for that. Okay, the next composable we will create will be a bit more complex because it will be for this blurred image background. So this will be a layout where we can then pass the rest. Let's start off with that again in our components package, since it's just needed for the book detail screen. And we have our blurred image background. We make this a file, composable, blurred image background. So what does this blurred image background need? It definitely needs to know the image URL, which it should load the image from. This can be null. It needs to know whether we mark the book as a favorite or not, since the book cover will also be part of this background. We get a lambda when we click on favorite click. And we also draw the back button there, so on back click. And in here we will do something very similar to what we did before, that we work with these image load results, since we need to load this image now with Koin again. But since Koin already cached this image on the book list screen, this will be loaded instantly from our cache. But we still need to, of course, instruct it how it should be loaded and what should happen if it failed to load. So var image load result by, remember again, oops, not remember on back click, where we say mutable state of, which will hold a result, a Kotlin result this time again, of a painter from Compose UI graphics, which is nullable and null by default. Then we can hit Alt Enter twice to import this. And the actual painter reference will then be remember async image painter, where the model is our image URL. And on success is a lambda we need here, where we simply update our image load result with whether the image has valid dimensions. So it result result, what was it called? Actually, it.painter it was. Intrinsic size. Let's save this in a variable. So val size. So if the size that width is larger than 1 and the size that height is larger than 1 pixel, then we say that was a successful result with the painter. Otherwise, that was not a successful result. So result failure, and we say the exception is invalid image dimensions. So let's first of all think through how this should work with this blurred image background. So in the end, we will have a big box that just surrounds our whole screen. In this box, we will have a column that consists on the one hand of this blurred image section, as well as this white content section of the screen. The blurred image background is in the end just another image we load with Koin. So we just load this image from our cache twice, with the difference that here we will just blur this. Then we will have an invisible spacer for exactly half the height of our blurred image background. So we then draw our image card, or actual image here. And then everything that comes afterwards will just be dynamic content that we pass, that we actually need to pass here to our blurred image background. So we need a composable lambda so that we can add our screen content here. So let's first of all start by defining our box. This really doesn't need any modifiers. We will figure out the rest here inside the box. So let's start off with the big column. This column will fill our whole screen's size, fill max size. So this will now be the column that consists of this blurred image background and this white section. Then for this blurred image background, we will make use of a box again, which will get a modifier with weight 0.3f. So it will take up 30% of our height. We say fill max width to just fill the whole width of our screen, and we give it a background of dark blue. This will only become visible if there is no image to load for the blurred background. I actually not fully remember what happens when we click on a book like this. Yes, then you can see here the blue background will actually show, because blurring this error image would look quite ugly. So that's something I want to do. Inside this box, we can now draw our image. So we have an image composable, give it our painter. So the image load result, or rather we need to have a null check here, whether the image load result dot get or null, which will return the painter if it was a successful result. If that exists, we can draw the image. So the painter one here. Then the content description can be our book title. Do we have the book in here? No. Then let's just say we have a string resource, res dot string dot book cover. Let's call it like that. We can then go to string resources, compose resources, values, strings XML, and maybe we can just add a bunch of resources here that we need on the screen anyways, so we don't have to rebuild this all the time. So let's just duplicate this a few times here. On the one hand, we have this book cover string, book cover for the content description. We then have our rating string. We have our pages one, languages, we do have synopsis, we do have a description not available, and we say description not available. And I think this should be it for now. I'm pretty sure we will need more string resources in this course. Maybe not, maybe we do, but now we already have a foundation for the screen. Let's rebuild this, get back here, then we should be able to import this book cover. Yeah, now it was actually quick. Alt-Enter to import this. We want to pass the content scale crop. So this will simply make the image fill the whole width of our image here, and then cropping the top and bottom edges so that it perfectly fits. And lastly, very important, the modifier. Since we want to fill the max size of our parent box, we then want to blur it with a blur modifier, give it a radius of 20 dp. So the more you choose here, the more the blur will be applied. And that's already enough to draw this blur image. Pretty simple, I think. Below this box, which is now in our outer column, so where we have this blur image, we now want to draw this white section, so the actual content section, which spans 70% of our screen. So here, we will simply draw this. It's really just a container composable here with a box, modifier, give it a weight of 0.7f this time, make it also fill the max width of our screen, and give it our background of desert white. And I think we can already try this out. I think from now on we can get rid of the preview here and rather just launch the app since we already have valid data available. So I will remove this one here and rather go to our screen, which we don't yet have, I think. Let's go to book detail and create our book detail screen. Composable, again, same pattern as for the list screen. Book detail screen root, which does take an instance of our view model, which is our book detail view model. You can also quickly create an empty one for that here in book detail. Book detail view model will be a view model. We will have our state in here, our book detail state it is, we have a public state underscore state as state flow, and we do have an on action function that takes in our book detail actions this time. So just an empty view model. Let's also immediately register this here in Koin, so we don't forget about that. Duplicate this, make this a book detail view model, double colon, and we're safe. So now in our book list screen again, book detail screen, we can observe our state from this view model, collect as state with lifecycle, Alt enter to import that, and then we can come up with our private function book detail screen. Contains the actual screen contents, where we pass in the state, where we pass in an on action lambda with book detail actions. And we mark this as a composable, of course. We can then add the screen here. We don't need a modifier for this one, but we do need a lambda for on back click, since in that case we need to pop the screen from the back stack. And in here, we can then say book detail screen, pass in our state, on action lambda, where we do get our actions. We want to check if that action was to go back. So if that is a book detail action, on back click, which in that case, we want to just trigger our on back click function. Otherwise, not do anything. So those are really just all the actions that we need to act on in the UI outside of the view model. So everything else we can then submit to the view model so we can handle and update the state there. So now in this book detail screen, we should be able to create our blurred image background. So we can just preview that a little bit in our real app. The image URL will be state book image URL. Make the null check here. Then is favorite will be state book is, what is it? No, state is favorite. It's not part of the book. On favorite click. Here we will trigger on action, book detail action, on favorite click. Then we have on back click, where we trigger on action, book detail action, on back click. We have the modifier, where we just say modifier fill max size. And lastly, we have our content, which will be displayed for this in this white box here. So everything starting from Kotlin programming. We didn't make use of this lambda yet anyway, so we can leave this empty for now. So the only thing that's left in order to try this out is taking this book detail screen root and adding it to our nav host. In application, book detail, and here we can replace this one with, with the book detail screen root, where the view model is now a view model we can create here, just with Koin view model, since this is now bound to the screen again, called book detail view model. Pass this in here, and our on back click lambda, when that is called, we can say nav controller navigate up. So we just get to the previous screen. What's important is that whenever the selected book changes in our selected book shared view model, we also need to submit that to our screen bound view model, which we can do with the launch defect block. So whenever this selected book changes, we say view model, or detail view model, on action, book detail action, on selected book change. And we pass in the selected book. Actually, only if it's non-null. So selected book, question mark let, and then we can pass it here instead. So this way we just know the selected book in our screen bound view model. So we'll also see the book information in here, since we pass in the image URL as favorite and so on. So I would say we try this out. Let's launch this and hopefully see a valid blurred image background. We're loading, at least no crashes this time. Click on this one and no, we don't see a blurred image background. Why is that? So apparently loading failed. So this code seems to not execute. What happens if we just use the normal painter here without checking for a successful result? Like this, click here, and no, that also does not work. That is a little bit strange. Can we maybe see something in our logs here? I don't know if we filter for coil, maybe. Let's actually print these logs here. So if there is an error, then we can say it dot result dot throwable print stack trace. So we can see what went wrong here. Going back to our logcat, we click on a book And there we get our exception. Coil null request data exception. The request's data is null. So it seems like the image URL that we pass in here is null. Why is that? I know why that is. Because in our book detail view model, we don't yet accept these actions and update the selected book in here in our book detail state when that changes. Of course, that makes sense. So if the book detail action is actually selected book change, we need to update our state with that. So we need to update our state with it.copy, and our book here is now our book that comes from the action. What else do we have here? If book detail action on favorite click, which we don't implement yet, and otherwise we ignore that since the back clicks are handled on the UI level. This should hopefully fix it. There we go. Loading this, here it is, and yeah, now it works. Now we do see our blurred image background. Let's see how it works like this with our error images. Yeah, that's also how it's intended, because for error images, we don't want to have this blurred background. Very cool. So we can leave this as it is and get to working on our blurred image background, since we're obviously not where we want to be yet. So I've opened the sample app again. The next thing that we want to add is this icon button to go back. And that is also why we have this outer box, so we can easily align things like this icon button in any of the corners of this box. This is very easy. So just below this column, right here in this box, we will have an icon button. When we click this, we say on back click. And the modifier here is modifier dot align. So we're going to align this in our box at the top start. So right here, as you can see, we want to give this a bit of padding, specifically the top padding 16 dp and the start padding of 16 dp. So it's not exactly in the top corner here, but a little bit padded to the right and bottom. And we also want to add our status bars padding again that will just be the height of our status bar here. So we push this to the bottom. And the actual icon we use for this icon button is an icon with an image vector icons default back, arrow back. Oh, it's in this auto mirrored thing again. Auto mirrored dot filled back, arrow back. There it is. Content description is, I think I missed this resource. Res string go back. Okay. Let's add this and also add the content description for the favorite button in our string resources. Oh, I closed it on dump. Here. There we go. Duplicate this twice. We have the go back content description as well as mark as favorite or remove from favorites, because that actually differs depending on the state of the icon button. Mark as favorite. Remove from favorites. Make this again. Here we can then import this, hopefully again as quickly as it was before. Yep, there we go. Minimize this, Alt Enter, import that one. And as I said, we want to give this icon, let's say a pure white color, so it's visible on our book background. Like in a real world app, I would probably calculate if this image is rather dark or light, and depending on that, decide about the color of this icon button. But let's keep this at white, keep this at black if you want. There will always be book covers that this will be hard where this will be hard to see on, but I think this will be a bit too much for this course. All right. What comes next and last for this blurred image background is of course the actual book cover together with this icon button for marking it as a favorite. Of course, this book cover now needs to be offset a little bit here in this outer box. And we will achieve this by putting this in a column together with an invisible spacer that gets exactly half the height of this 30% blurred image section. So after this icon button, we'll add a column that will have a horizontal alignment modifier of alignment center. So the book cover is obviously centered. And we will give it a modifier of modifier fill max width. In this column, we will then have our spacer, so our invisible spacing, where we give it a modifier of fill max height, but for the fraction, we choose 0.15f. So the column actually spans over the whole screen now, not just over this blurred image section. So that was wrong, sorry. But it spans over the whole screen. And since 15% of our screen are just half the height of our 30% image height here, this will just offset the image by exactly half the height here. And then below this, we can have an elevated card to draw this image on, which gets a modifier with a fixed width of, let's say, 200 dp. So that will be the width of our book cover, and an aspect ratio of 2:3. We give this a rounded corner shape of 8 dp corner radius, some colors where we can say card defaults, card colors, or actually elevated card colors it is, where the container color is just transparent, color that transparent, since we don't want to have a real container here. This is just used to show off a little bit of shadow and also be able to draw content on top of that, like our favorite button. Then the elevation is something we want to override, where we can say card defaults, elevated card elevation, where we say the default elevation is, let's say, 15 dp. And then we can give this card some content, which on the one hand will of course be our book cover. So here we can actually also make this an animated content, which is a composable that allows us to animate between different composables based on a certain target state, which will be our image load result. And then in here, we get this result and we can add our when expression here. So depending on what that result is, if it's null, we want to show our circular progress indicator for now, but later on our pulse animation. And otherwise, we want to draw our image again with our painter. But here we need to check if it's successful or not again. So if the, what's it called, result is success is true. Oh, no, it's actually non-nullable in this case. So if this is successful, we use the painter, and otherwise the painter resource, and we pass our error image again. So here ras drawable book error. Content description can again be a string resource, ras string book cover. We have a modifier, which is modifier.fill max size. So I want to fill the whole size of our outer card, and then give this a background of transparent. So in no cases we have any background of this book cover, but really just the image itself. The content scale also is important here, which again has the same rule as for the list screen, that if this result was successful, we make this content scale crop, and otherwise we say fit. Like this. And actually this image also goes in a box, since we want to also now draw the icon button here in the bottom right corner. So let's put this in a box. And then here below this image, we will have our icon button. When we click this, we say on favorite click. We say the colors of this. Oh no, we actually adjust this for the icon itself. What else do we need here? The modifier, since we need to align this in the bottom right. So we say align bottom end, and we want to give this little glowy background, so it's better seeable even on a red cover. And this works with a gradient. So it's in the end just a yellow gradient towards transparent. And we can do this with a brush by saying brush.radial gradient. So we want a circular gradient in this case, where the colors for the gradient are a list of, on the one hand, from sand yellow, from the center of the circle, towards color.transparent. And the radius is, let's say, 70 pixels. Inside of this icon button, we then draw our icon with the image vector, icons, default, favorite border actually. Oh no, that actually depends on whether we mark this as a favorite or not. So if is favorite is true, then we want to use the filled favorite, actually make this explicit here with icons filled favorite, and otherwise icons outlined favorite border. We want to set the tint of this to color.red, and we want to set, I need to give this a content description, which is also now dependent on whether we mark this as a favorite or not. If this is a favorite, we say string resource, string, remove from favorites, because if we marked it as a favorite, clicking it would remove it again. So always remember that these content descriptions are mainly used for things like screen readers that would read what would happen when we click on this button. And if it's marked as a favorite, we would remove it. Otherwise, we would add it. Mark as favorite. Like this. And that should be it for this blurred image background. The last thing that's missing is that we actually use our composable lambda, so we can also draw the remaining stuff here. And this composable lambda needs to come in this column after this elevated card. So let's highlight this, go down here, and this should be the place where we now want to draw the content. I think it's quite a long composable, and we could argue about extracting certain parts into separate composables, but I think it's okay. Might want to use this modifier here as well for the box. Modifier is modifier, but we don't need to change this in any way. Let's try this out. Let's launch this, and we should hopefully see the same as on the left, just without these texts here and the synopsis. So launching this, there we go, loading our little books. Here we are. If we click on that, oh, that looks pretty cool, I think. The book cover is a little bit larger than I had it in the preview, which I don't know why from the top of my head. Let's click on go back. That at least works. Why is this larger? So the elevated card has an aspect ratio of 2:3. And the issue is that this should be a height. So we want this to be 200 dp high, but not wide. But of course, feel free to adjust this. If you like this size of the book cover, I think it looks decent, especially with a shadow here, then do so. But oops, let's relaunch this now with a height of 200 dp, and it should look similar as I had it. Let's search for a different book. Harry Potter again. Okay, let's use, I don't know, that one. And yeah, that's how it looks like. Pretty cool, I think. I think it could be slightly larger, actually, when I think about it. What if we make this a height of 270, maybe? Let's try that. There we go, Kotlin programming. I think this looks decent. So obviously we need to make this thing scrollable, or rather the section below here. Like the best case would probably that we implement somehow that we have a collapsing toolbar, but that would also make this video way too long, and that's rather something for a premium course of mine. I think, yeah, it's slightly too large. Let's make this 230 and that'll be good. You could, of course, also make this dependent on the actual device size and so on, so to show a larger cover on desktops than on mobile, but I think this will be fine. So now we can use this in our book detail screen, and what we put in here will then show up below. So if we have our hello world text here, launching this one last time before we go on with this UI here, if we do this, then it will show up just after our book cover. I think this looks really cool. So we can go in here and say, if there is actually a selected book, so if state book is this nullable? State book, yeah, it is. If this is not null, then we show our actual book data. This will be shown in a column, of course, which takes in a modifier. Modifier is modifier fill max width. Again, we want to limit the width a little bit on larger screen sizes. We say max is 700 dp. Alt enter. Within it needs to be within like this. We give this some padding, so it's not immediately below the book cover, but just pad it a little bit. Let's say vertical padding is 16 dp as well as horizontal padding. I mean, that should be a bit more, 24 dp. And we can give this a vertical scroll, passing in remember scroll state. And then we should be able to scroll this column here so that the book cover won't be scrollable, but the content's down here. And everything in there should be centered horizontally. Alignment center horizontally. So I've opened the sample app as reference again, so we can now build this remaining part of the screen. First of all, I want to have a title text, which will be the state book title. It will have a style of material theme, typography, headline small, and we set the text align to center. Not snap position again, text align center. We can copy paste this also for the description. Actually, the author it is state book authors. And since those are multiple authors, we could say join to string, which will take the list of authors and concatenate them with a comma in between. Or if you say you just want to highlight the first authors, like the main author, you can also say authors that first. This will have title medium as a style, also text align center, I would say. Then below this text, we have a row of 2 of our chips for rating and pages. So row, modifier is modifier, add some vertical padding of, let's say, 8 dp. And we want to add horizontal arrangement that's spaced by 16 dp. So we just want to have 16 dp of spacing between these chips. And in here, we can then have these chips. So if there is a rating, if state book average rating exists, we want to have our titled content where the title is our rating. No, actually not the rating, but this is the description for the rating. So string resource, res string rating. The modifier is not necessary here. So we can just open the composable content in which we will have our chip or book chip. How do we call it? Book chip. Yeah. And here for this one specifically, we show the actual rating text. We can again round it. So we say rating multiplied by 10 divided by 10.0. Put this actually in a string like this. And but after that, we want to show an icon for our little star. Image vector icons default star. Give this a content description of null and a tint of sand yellow. Same thing we now do for our pages. So state book pages, number pages, .let pages or page count. We can have the same type of titled content, copy paste it here. The title here will be pages. The text will be page count toString. Here we don't need to round anything. And the icon is not necessary for the page count. All right, then in the next row, after this row, we want to show all of our languages. So you can see that for books that have a lot of languages, like Harry Potter again, we will see all of these languages here when clicking on this right here. So lots of languages, and we want to show these all, if you want at least. So we will have a languages text, and then we will make use of a so-called flow row. So just a row that arranges all these chips in a row-like fashion. But if they get too wide to fit in a single row, then these will jump to the next line until we looped over all of them. So below this row here, we want to have a check if state book languages is not empty. So if we have any languages to show, then we say we again have our titled content, where the title this time is a string resource, res string languages. The modifier is again one with a bit of vertical padding, so vertical 8 dp. And then we have our actual content. So this is now the titled content that shows this languages text together with the content, which is this flow row. So flow row, give it a horizontal arrangement of arrangement center, so that in the last row everything will be centered. We can give this a modifier of modifier wrap content size, also pass in center here, and then simply loop over all of our books, all of our languages. So state book languages for each language. We have our book chip, which shows the text, so the language, actually that uppercase. We can give this style as well. Style, material, theme, typography, body medium this will be. And these chips specifically will be small chips. So the size will be chip size.small. And we add a bit of padding between each chip by saying modifier padding 2dp. So with that, we just achieved this tiny spacing between the chips. The flow row is marked as an error because this is experimental. So we want to alt enter and opt into this experimental layout API. And then below this languages section, after this if statement, where is it? Here. We will have our description, so our synopsis. The description we still need to load from the API, but we can already draw the headline for that. So text, that's a string resource, res string synopsis. The style will be material theme, typography, headline, actually title large. Title large. Give this a modifier of modifier dot align. Align this to the start of our column, so it's all left aligned here. Alignment dot start. Give this some padding. Actually, after we say fill max width, give this some padding. specifically top padding of 24 dp, so that we have this spacing here, as well as bottom padding of 8 dp, so at the very bottom here. And then we do have our description text. So text is equal to if the state book description, do we only have that field? Yeah. If that is not null, then we say the text will simply be the book description. If it is null, which it will be in all of our cases right now because we didn't yet implement the API or the endpoint to fetch that. If it is null, then we say string resource ras string no, what did I call it? Book description unavailable. This is foldable. If we do this, yeah, we can do that. That's a bit better, I think. Oh no, let's actually keep this because some of these descriptions are actually blank. So let's check for is null or blank without the null check here. And in that case, move this in here. Sorry, that's a bit of a mess here. But this way, it's now better. So if it's blank, if there is no description and we just got an empty string from the API, then we also want to show it's unavailable, and otherwise we show it. For the style here, we can say material, theme, typography, body, medium. The text align here, I would say, is justify, so that it always fills the whole width here. I think this looks decent. The color of this depends on whether we have a valid description or not. So if state book description is null or blank again, we will use a color like color black, but we say the alpha is only 40% and otherwise just color black. And the modifier of this one will be modifier, give it vertical padding of 8 dp. And I think that should be it. Something we might also want to do is want to show a progress indicator here when we load. So if state is loading, then we say, okay, we have a box, modifier fill max width and weight 1f. So we just fill the remaining height of our screen and we center the progress indicator here and then simply pass that in. If we're not loading, then it really depends on the description that we've loaded. Okay, let's launch this. This should contain almost all of our UI for the screen now. So what's missing is, of course, on the one hand, the functionality for loading the descriptions, and on the other hand, the functionality to mark books as a favorite. Let's click on a book, and there we go. The rating looks very off, but other than that, it's a bit weird that we don't see the progress indicator here for the description, because we are actually loading by default, I think. So book detail view model, let's take a look at the state. This is true. So I don't know why that isn't showing. What if we just put the progress indicator in here and comment this out? Let's also take a look at the rating very quickly. Book app chip. I think what we could do to easily fix this is, like on the one hand, we could of course put these in a row, which we should have done, but I would say in most cases, if we have multiple composers in here, these will be arranged in a row anyways. So what we could do is, we could make this chip content actually extend a row scope. So we automatically provide this row scope by putting this in a row here. We can say vertical alignment is alignment center vertically, like this, and maybe also horizontally, arrangement center, and then that should be fixed. Let's also check the description issue. There we go. Kotlin programming. Now we see the progress indicator. I think this is okay. And this won't hide in this case because we never update it to false, which is what we will do next. So loading the description and then marking things as favorites. So we don't yet have any database implementation, of course. That is what will come last. Let's spend time on working on fetching the description. Let's quickly actually take a look at Harry Potter again. If that now also works. Yeah, multiple languages. That looks decent. We can scroll here, as you can see. Very cool, very cool. We slowly get towards a working app. So yeah, as I said, next up is the book detail endpoint, fetch the description, merge that into our book, and then be able to show that. And lastly, be able to also have some favorite books here, which we also still have to do. Let's think about how we implement the book detail endpoint to fetch the description of a book, because that's really the only piece of data that's missing for a book, at least for our app here. And it might sound easier than it will actually be, because as I already said, the API design is really bad. And what I mean with that is that if we take a look here, I have prepared two of these detail responses. So you can see the endpoint is openlibrary.org/works, so to find out a specific book, and then we pass in the book ID.json. And I've prepared two of these. And if you take a look at the JSON response, then we will notice, okay, here's the description that we're looking for this particular book. All the other fields we don't care about here for this endpoint. So you can see that description is simply a string. However, if we take a look at the different endpoint, like it's the same endpoint, but a different book, then the description is suddenly a JSON object. So it's not a string anymore, but the string is inside of this JSON object, hidden behind this value field. So for some books, the API responds the description as a real JSON object, and for some other books, it responds that as a simple string. And this really shows me that this API was not designed for mobile development, since in mobile development, we typically work with type safety when it comes to parsing JSON data. And a JSON structure like this is easy to parse if you're using JavaScript and you're building a website or so, but it's terrible to parse this on a mobile environment. Still, that is something we have to work with, and that is also something you will often face in your daily life as a mobile developer, that you just have to work around such bad API design, since that's in the end what's given to you and you have to make the best out of it. So I think this will still be a good practice, how we can work around that. So we can start by again going to our book feature, since that's obviously part of that. Going in data, DTO, because now we want to define a different DTO, data transfer object, or Kotlin data class representation of what we want to parse this JSON into. And we call this book work DTO, for example. This will be a data class. And here we will really just want to define the description and ignore all other strings. The description is still nullable, so even though some books have that as a JSON object, some other books have it as a string, there's still also books that don't have a description at all. And we would need to annotate this with serializable again, but by default, if we would just do it like this, this would not work. It would only work for those book work DTOs, for those JSON responses where the description is really a string field. But if it's an object, then the serializer by default won't know that it needs to find the description inside of this object. So what we need to do in order to work around this issue is we need a custom serializer. So if we take a look here in this annotation, and we open parentheses, and then we actually have this width parameter, which is a K serializer. So we can say that this book work DTO specifically should be serialized and deserialized with a different type of serializer, where we can then define our own logic. And we want to create this here in DTO as well, called book work DTO serializer. This can be an object, and it will inherit or implement this K serializer interface, which needs to consist of the type of object we want to serialize or deserialize. Then we can hit Command I here to override these three fields and functions. And on the one hand, we need to define this serial descriptor. So this really just gives the serializer kind of an outline of which fields we're actually looking for to deserialize. And we can actually just set this equal to build class serial descriptor with the serial name, so that is the class name, book work DTO. We could also, I think, give this the dynamic name dependent on our DTO. So this would also adjust if we would rename this. This should work with book work DTO : class dot simple name. I think this is the simple name of the class as it was declared in the source code, or null if the class has no name. And apparently this can return null, which it shouldn't, because our class definitely has a name, so we can assert this here. And then we can open a block of code here in which we specify those elements. So those are now the JSON field elements that we care about here. In our case, that's really just the description. It needs to match the field of the JSON field, and we need to specify what type of object that is. In this case, it's a nullable string. We need to Alt Enter here to import this element, and then we also don't have any more errors. And now this serializer gives us a deserialize function, which just gives us this decoder, which you can now use to step by step decode those fields that we care about and return these as our desired object, the book work DTO, and a serialize function. So if we would have a book work DTO and you would want to push that with the API, for example, then we have to take this Kotlin object and serialize it as JSON. And that is what we define with the serialize function. This actually we don't need, because we only fetch book work DTOs. Still, for the sake of completeness, I would implement this as well. It's really super simple for this one. Just the deserialize logic is a bit more difficult. So here for this deserialize function, what we want to do is we want to set this equal to decoder that decode structure and passing in this descriptor here. So this is just how we initiate this decoding process here of the JSON that was returned. And in here, we then want to have a var description, which is our nullable description. We set this to null initially, since at this point we don't yet know the value of that. And then we want to have a while true loop. So a while true loop in which we check, where we say val index is equal to decode element at index. This function now comes from this decode structure block. So we're just now trying to decode this whole object by passing in this descriptor again. And then this function returns a specific index, which corresponds to the elements that we've declared in here. So in our case, we just care about a single field. So we only care about the index 0 because this is the first element here. If we would also want to decode something else, like the title, and we would have the title here, then if this returns index 1, we would know, okay, we're talking about the title field. In this case, if it returns index 0, we know we're talking about description. And that's all we care about in this case. So we can remove the title again. Just that you know that this index does not refer to the actual index of the JSON response, like the order of the field, but to the order that we've specified up here. And if this index is now equal to 0, that means we actually decoded this description field, which can now be a string or a JSON object. We can now define this logic to decode this, these two cases in here. First of all, we need a JSON decoder, which is equal to our decoder as JSON decoder. If this is not castable here to a JSON decoder, that means the response was not in JSON. So in that case, we can throw a serialization exception where we say this decoder only works with JSON. And now we can say val element is equal to JSON decoder dot decode JSON element. And a JSON element here is really just anything relating to JSON. So this could be a JSON object. This could be such an object here in curly braces. This could be a simple field, like just a string. This could be a list, like here. So this is what we need to check next. So we can say description is equal to if this element is actually a JSON object. So we're talking about a real object that we need to deserialize here, which would be the case, again, here if the description is an actual object. Then that means if it is an object, the description should be assigned from this object specifically with the value field. So we go back. Here we can then say decoder that JSON dot decode from JSON element. Since we have a JSON element here and we want to now decode that whole object into our own DTO class again, which we have to create. So here in DTO, we say description DTO, which is a data class, serializable, and this actually contains the field value, also nullable. Let's leave this like that. And I think this is actually non-nullable if we do have this description DTO. So if we actually have a whole JSON object the API responds with, then the description exists. Just if we don't have this response type of an object, then it might not exist. So our goal is now to go back to our serializer. We say we want to decode from JSON elements, so from this one, where we now know, okay, this is actually a JSON object. So we definitely currently have to deal with this certain type of JSON element structure, JSON object structure. So we need to pass that we are actually working with a description DTO. The element here is our JSON element, and the deserializer for that is our description DTO serializer. And this will now just normally decode this element here into such a description DTO. But since our description is a string and not a description DTO, we need to refer to that value. This is now the value that we got from the API here. So this specific string. However, if we are working with a plain string, so if the description is directly here as a string, that is now what we need to put in the else case. So here, if it's a JSON object, we now have this logic. If it's not a JSON object, specifically else if this element is now a JSON primitive. So for example, a string, an integer, anything like that. And the element is also a string. So only then we know we are dealing with a valid description. Then we can simply say element.content, which will be the actual value of the description field. And in all other cases, so else, if it's not a JSON object or a JSON primitive, or it's simply not a string, maybe it does not exist or so, then we will just assign null. Okay, furthermore, here in this when expression, we want to catch the case of Compose composite decoder, decode none. So that means we're just done with deserializing. In that case, we can break out of our loop. And in all other cases, we can throw an exception, unexpected index or so. And we pass in the current index. So now we just assigned a real value to our description. So after this loop, once we break out of that, when we went through all of our indices, we can go down here and return at decode structure our actual book work DTO with our description. So this is now our custom serialization or deserialization logic. You can see it's quite a pain to make this work with a single field like this. So if you are working together with a backend team and you are actually in communication, so you kind of own the API as well in your company, then talk to them that they don't do this because this is really something mobile developers hate. And web developers typically have no idea that we have this type safety here in the mobile world, and they can just make easy type checks with JavaScript. They can just check, okay, use this field if it's not null, and otherwise use this field and then decode it as an object. This is much easier in JavaScript, but in Android or also iOS, things work differently. For the serialize function, we now get a value, a book work DTO, which we now have to serialize into this encoder, so as a JSON string. And this is really easy. We can just say value description dot let. So if that exists, we just say encode string, actually encoder, encode string, actually string element, but we do also need to call encoder dot encode structure again. So just the opposite of decode structure. Pass in the descriptor like this. Then we can say encode string element, there it is. Pass in our descriptor, the index is 0 and the value is simply it, so our description. But as I said, the serialize function won't ever be called in our app anyways, since we don't need to serialize such an object back to JSON again, since we don't need to push that to the API in any case. Still, I also wouldn't leave this unimplemented, because if you later need this, then it would lead to issues and you would first of all be confused why. Okay, now we have the serializer, which is still unused. So we need to go to our bookwork DTO and say with bookwork DTO serializer ;class. So we say this particular serializable class should now be serialized and deserialized with our custom serializer. All right, now we're actually settled to add the endpoint to fetch a bookwork by going to our network remote book data source. And in here, we simply add another function. So we say get book details, where we say we pass in the book work ID. And we then get back a result of our book work DTO and data error remote again. And now we can hit on this arrow to go to our implementation, our Ktor remote data source, where we now have to implement this. So here we can just have our get book details function, where we can just say return safe call again. And in here, we use our HTTP client to make a GET request with the URL string. What did we call it? Base URL. Actually, let's have it like that. Base URL /works /bookworkid.json. This is exactly the endpoint I've shown you here. So if we take a look again, you can see open library /works. This is the bookworkid.json. And then we get this type of data. So you can see how easy that now is thanks to this save call function, which automatically parses the result of this call into a result class so that we can perfectly work with that. We should also be very explicit about the type here. Actually, it doesn't accept that for some reason. This is actually the place I'm noticing that takes the specific type of data we expect. So sorry, we should specify this here. Bookwork DTO. And probably also here with a search response DTO. Able to fetch book details. We can go to our default book repository to also extend this one here with a function for that. And since in our case, we really just care about the description of a book, and that's also all we fetch in the book work DTO, let's call this function in the book repository that we also expose to the presentation layer, get book description. Pass in the book ID. And that gives us a result of a string and a data error. Here I'm not actually using data error remote because later on we might also fetch this book description from our local database. It could also very well be a data error local. Searching books only works via the API, so it's clear that if we have an error, it must be a remote error. But to get the book description, this happens on the detail screen. And if there's already this book in our favorites, then we can load the description immediately from our DB. So back to book default repository, get the book description. Here we can now return if, or actually not if, we can just return our remote book data source dot get book details, pass in our book ID, and then that gives us a result of book work DTO. We need it as a result of string, so we can simply map this to the description. And that's how we fetch a book description. So we can now go to our book detail view model. We can then add a function down here, fetch book description, for example, view model scope.launch, since it's a suspending call. And here we say book repository, or did I just call it? Oh, don't we have a reference to that yet? Oh, okay. Still need to inject this here. Book repository, make sure to use the abstraction. And then we say book repository, get book description, pass in the book ID, which you can get from our navigation arguments instantly after navigating. So we want to use saved state handle here. Saved state handle, since that is what allows us to actually get navigation arguments also in a view model. So this is really nothing else than a persistent map of items or a bundle of items where we say, okay, this key is mapped to this value, book ID is mapped to this specific ID, for example. And yeah, Android will just pass the navigation arguments over there as well, or rather KMP, we're not on Android here. And then we can pass this down here by saying book ID is saved state handle to route, specifically our book detail route, and we refer to the ID. We can also cut this out, have it available as a global field, because we might need this multiple times here on the screen. But this way we just get a type save ID, which we can then pass here, ID or book ID, and on success. So if this API call was successful, we simply update our state.update, it.copy, and we just say our already loaded book is it.book.copy, and we update its description with with the description we fetched here. Like this, that's the description. We also want to set is loading to false now, and then we can call this function again in our onStart function of our state flow. So we can say onStart, so really same reasons as why we did it for the list screen. So here we can say fetch book description, and we say state in view model scope, shearing started while subscribed with 5 seconds and underscore stated value as the default state. I think this should be ready to try out whether we are able to load descriptions or not. I will launch this. Take a look on this device here. I think, what's complaining here? Unresolved reference. Is that an issue? Apparently not, still launched, so that was a bug. Here we have our list of books, and now the magic happens when we click on a book, and it has description unavailable, because for this book I think it also is not available. But let's look for a book like Harry Potter again, which certainly has a description. There we go, Harry Potter, and clicking on one here. And yes, we did fetch the description. Very cool, there it is. If we go back and click on another book, also description, and so on. So this seems to work just fine. We can also look for actually the same books that I opened up here. So this 48 Laws of Power, for example, had a description where it was directly a string, so that we certainly also test this type, 48 Laws of Power. There we go. Click this. Yes, it also loads the description for this book. Amazing. So next step is to implement our favorite function, which we currently don't have. So if we click here, nothing happens. So we need to add a database, a local database with room that we can save the books that we've marked as a favorite. And as a last thing, we also still need to implement certain animations, like the polls animation that I've shown you. But other than that, we are done. So let's get to the database first and then the animations. For the database, I will go back to our book data package, obviously. And here we should probably just have a database package in which we first of all create a book entity. So an entity is really just the equivalent of a DTO, just for local storage. So in the end, just a database table. We're going to make use of room here, which is completely KMP compatible, in which we need to annotate these entities with entities. So room knows, that's actually an entity, that's a table. And then in here, we can have things like the ID, which is a string, not a string resource, just a string. We need to annotate this with primary key to tell room this is our primary ID, but we don't want to auto-generate it. So this should be false because we get these unique IDs from the API already. We have a title that we want to save with the book. We have a description, which is a nullable string. We do have an image URL, which can also be nullable. We have languages, which is a list of strings. We have authors. Well, authors, also list of string. First published year, which I think we don't even make use of. Let's add this here. Val ratings average is a nullable double. Val ratings count is a nullable integer. Val number pages median is a nullable integer. And lastly, the number of editions is an integer. And now when we have another such data model, just like a DTO, this is also now a data model that specifically couples this object to our local database framework, to room, since it also adds room-specific annotations, which is why this should definitely be a separate object here. Because we have that, we also do need another mapper. So just like we had a mapper here to transform our search book DTO to a normal book domain model. Now, if you want to have a book domain model and we want to save that in our database, we need a function that takes the domain model and maps this to our entity. So just book to book entity, and here we return a book entity. The ID stays ID. This, in the end, all stays the same here. So we can just pass all that stuff as it is. The languages, authors, first published year, ratings average, ratings count, num pages median, and lastly, number editions. Like this. Rating count, this should be rating average rating, I called it there. Okay, so we now have a function to take a book, convert that to our database entity. So the next step when implementing a room database is always to come up with a so-called DAO, so a data access object. It's pretty much just an interface that outlines the functions that we need in order to interact with our database. So in the end, we just define the different queries that we would like to work with when it comes to the use of our database. This also goes in database. So a favorite book DAO, for example, will be an interface that we need to annotate with a DAO. And here we can then outline the functions we need. For example, a suspend function to upsert a book. So insert it if it doesn't exist, and if it exists, we update it instead. And the book here is simply of type book entity. We annotate this with upsert, and room will do the rest for us. Then apart from that, we need a function to actually fetch our books. So function get favorite books, for example, which will return a list of book entities now. And actually what we would like to have here is reactivity. So we want a function that always automatically triggers when we change something about this query, when we change something about the favorite book table by, for example, adding a new favorite, by deleting an existing one. So what we want is we want to wrap this in a Kotlin flow. This is something a room luckily supports. So thanks to this flow, we can observe this list of book entities, and it will always give us the most up-to-date list when something about our query changes. We do need to specify this query, of course. So how we want to fetch those books, that's now SQL, which goes in this query annotation, for which you can say select. I want to select everything, so all the fields, all the columns from our book, book entity, there is no auto-completion, probably just book entity. And there's also no where condition because we just want to fetch all books from our table. This is not a suspend function here because a flow is already asynchronous by default. So it's really not a one-off call, but just a call that gives us this flow, which in and of itself does not do anything until we launch it in a coroutine scope. And then we have the scope again, which gives us this suspending ability kind of. And that is why if you return a flow, it does not need to be suspending, because constructing a flow isn't suspending, but just launching it is, which we then still have to do in our view model later on. Then we do need a function, a suspend function again, since this is, again, a one-off call, to get a favorite book by its ID. We pass in the ID and we want to load the details of that book. So we say book entity nullable, since it may not exist. And this will be a query where we say select everything from our book entity table again. This time we do have a weirder condition, since we want to say where the ID of our book is equal to :ID, so that refers to the ID that we've passed as a parameter here. So we just get all the fields from our book entity table where our ID matches with this one. And lastly, we want a function to delete a book. So that means if we kind of unfavorite a book, then we obviously need to delete it again. So delete favorite book by its ID. This doesn't return anything. And here instead of select from, we say delete from, where the ID matches. And now what's missing is we need to define a database class. So we need to explicitly tell Room what our database actually consists of, what are the DAOs, what are the tables we work with, what is the database version, is there any other config? That is what we need to tell it, which you can do in here again. Call this favorite book database, make this a class, actually an abstract class. It needs to be of type Room database. We annotate this with a database. We need to specify our entities or different tables. In our case, we just have the book entity table. And we need to give it a version which starts off with 1. So whenever you change the database schema in future, then you would need to increase this version. So Room knows that it would need to migrate your previous version to the new one, for which you would then also need to provide a migration. But this is only relevant if you actually have an existing user base that has your database installed, and then these existing users get an update with a new database schema. So this somehow needs to be migrated in that case. Then in here, we can say we have an abstract val for our favorite books DAO, which is a favorite book DAO. This will automatically be assigned by Room. Let's stay consistent here. Favorite book DAO. And we could give this a companion object or so to specify the name of our database, and a const val db name is, for example, book.db. Something else we need to do is, if we take a look back at our book entity, we are saving lists of strings here. And by default, lists can't be just saved in a database. We can really just save primitive fields or a byte array or so in a database field, but not lists. That Room simply doesn't know how to save that. Because we might very well also make this list of strings for languages a separate table where each language gets its own element. But this would be, I would consider this definitely overkill for this smaller app. If you would save a lot of languages here for a lot of books, then it would absolutely make sense to work with a separate table here so that each language is just saved once. And then the book is just linked with those languages. Because right now, if we save 2 Harry Potter books and both books actually add 20 languages here, then we would save those 20 languages twice, one for each book. And same for the authors. So if 2 books have the same author, then we could technically reuse that data that we've saved, but only if we make that a separate table. But this is really something I don't want to do in this video, since separate tables add quite some complexity. So what we will do is we will simply take a list of strings, serialize that into a JSON string, so then we again have a string that we can easily save in a database like this URL or the description. And when we then load a book from our DB, we again deserialize that string. And for that, what we can do is we can define a so-called type converter. So we can say actually string list type converter, because that's what it's for, that's what it converts. This will be an object which just contains 2 functions. On the one hand, a function to convert from a string. Here we get the value, what we've saved in our database, so the JSON string, and it needs to convert, it needs to return a list of strings. Here we can really just say we want to return JSON, Kotlin actualization, decode from string, and pass in the value. That's it. You need to make sure to annotate this with type converter, this one here, the singular form. And then we need to have the same function just in the other way around. So a toString function, or we call it from list, for example, where we now have an actual list of strings. So when we try to save such a book entity in our DB, we would assign these lists of strings, which we now have to take and transform to JSON. So to a string after all. In this case, we say encode to string, and we want to encode our list, Alt Enter, and there we go. That's our converter. We can then add this to our database by giving it another annotation called type converters, the plural now, to specify all of our type converters, which in our case is just a string list type converter. And that way Room knows which type converters we want to use. So this is how defining a Room database would work on Android. It's, as you can see, exactly the same on in a KMP project. The only thing that is unique to KMP is that we need a so-called a database constructor. So the way this works is we can create a new class called book database constructor. This will be an expect object. So just as I said before, where we had these expect vals for the Koin modules, this just says that we do want to have this constructor in our shared code to be able to initialize this database, but the actual implementations of that differs depending on the platform. But the thing is, if we make this a Room database constructor here of type book database, favorite book database, and we then override the initialize function, just like that, then that is all Room needs to know. We do get an error here because there are no actual declarations in our platform modules. But the thing is, for this class Room, the Room compiler will actually generate those actual declarations. So that will all happen behind the scenes. We still get the error, but we can suppress that by saying suppress no actual for expect, and then it will be gone because, as I said, Room will generate these actual declarations for each platform. I actually don't know what this does exactly under the hood, but it's just something that Room needs for KMP. But something we do need is still a way to initialize our database on our own. So we still need an expect actual declaration here to create a database, but this is needed in addition, apparently, at least based on the Room docs. So one last class or one last thing we need to do in order to be able to create a database instance is the database factory. This will be in our shared code. It will be a class, an expect class actually, which will have a function to create an instance of a Room database.builder, and we pass in our favorite book database. And this is now a class where we also need to provide the actual declarations. So if we click add missing actual declarations, want this for desktop, Android, iOS, click OK. Then we now need to implement these. So this one here for iOS, for example, we need to now say where specifically we want to save this database file on the iOS operating system, since the file system and how that works obviously also differs on Android, iOS, and desktop. So now for each platform, we need to specify how and where that should be saved. So for iOS, we do have a DB file, which actually depends on a so-called document directory. So it's kind of the internal storage on Android, which is a function we want to create here. Document directory, which returns a string, so simply a directory path. And the document directory here is equal to ns file manager dot default manager dot URL for directory, where the directory is equal to ns document directory. So again, kind of the internal storage. In domain is simply ns user domain mask. So you can kind of filter things that way, I think. The appropriate for URL is something we don't need. We can set this to null. Create is false. So that means to create this directory if it doesn't exist, but the user directory definitely exists. And the error can also be null. And then we can return this whole thing. We can say require not null, specifically the document directory, that path, like this. This here requires this experimental foreign API, which you can add here, or let's add this to the file, Alt Enter here, opt into this by adding this to the top of our file. And then in here for the DB file, we can say we use our document directory, so the internal storage and we simply add our favorite book database DB name. And then we can simply return room.database builder, pass in a favorite book database instance that we want to construct here, and the name is our DB file. So now we have an actual implementation where we say, iOS, this is how you specifically create a room database. Next up, we can jump into desktop. This is the second most difficult operating system to work with when it comes to the file system, since it doesn't need to be a single operating system here. So we are running this on the JVM. So this could run on macOS, this could run on Windows, this could run on Linux. And depending on the specific OS, the path where we might want to store the database file might just differ. So we first want to be able to actually check which specific operating system we're running on. So val OS is equal to system get property, and we can get this from os.name and convert this to lowercase. Furthermore, in order to just get access to the specific directory where applications typically store data like a database file on a specific operating system, we need access to the user home, so to your home directory on your operating system, which we get from system get property user.home. And then we can fetch the application data directory in this one expression. Depending on whether the OS actually contains Win, then it will be running on Windows. So this is the typical application data directory on Windows. So here we can say system.getEnv because the specific app data directory path is an environment variable on Windows, and the name of that will be app data. So this will give us the path of our app data directory, and then inside of that, we want to create another directory just for our application. So we can say Bookpedia. So a file doesn't need to be strictly a file, but it can also be a directory. And by doing this, we will just take a look in this app data directory, create a Bookpedia directory in there, and that is the place where we will save our DB file. If the OS is actually Mac, then we will create a file in our user home directory, and then we say library/application support/Bookpedia. So this is the typical user data directory or application data directory in a macOS environment. And lastly, else, if we're running on Linux, it's a file in user home, and the relative path from there is .local/share/Bookpedia. And this is now the directory where we want to save our DB file in. We want to check if this actually exists, because on the first run, this won't exist, since this Bookpedia directory will definitely not be there. So we can say if the app data directory does not exist, then we say app data directory mkdirs. So we want to create those directories if they don't exist. And then from that point on, we can create our DB file, which will be another file in our app data directory now. And the name of that file will simply be our, favorite book database.db name. And we can then return the same thing as we did before, room database builder, and we pass in our DB file that absolute path. And the type is already inferred here. So this is how we create, or how we get the path to store such application-specific data in KMP for desktop, for all those different operating systems. The last platform to consider here is Android. Android, of course, again, uses a different type of file system and permission system and all that stuff. But this one is actually the easiest way here. Since on Android, we do need a reference to the context. This is what's required in order to get access to things like the file system. So here for this actual class on Android specifically, we can just pass an instance of that and then make use of this. We can then get the application context by saying context.application context, and then immediately construct this DB file by saying app context, get database path, favorite book database, DB name, and we again return room database builder, and we pass in the DB file absolute path it is. And here on Android specifically, you can see this also requires the context to create this database instance. So we can say the context is our app context. Let's also give this one a name. And that is how we create a database instance, a room database instance on KMP or Compose Multiplatform. So now we've defined actual implementations for all platforms, for desktop, Android, iOS. So the next step is to actually be able to inject our actual database instance using Koin. So in our modules, in the common code again, here we can now have a single where we want to say get we want to get a database factory. We then call that create on that. So this will now give us, if we save this in a variable here, this will give us this room database builder, which you can now use to configure how our database should be created with room specifically. So for example, we can add migrations, we can add a callback, type converters dynamically if we want. But all we really want here is we want to set a driver, so what drives that database, and that is an SQLite bundled it's actually bundled SQLite driver. Bundled SQLite driver, which the database will use, and then we can call build to get the actual database implementation. So this will now return the actual favorite book database we can then use to retrieve our DAO, to make queries, and so on. However, we don't yet have a definition in Koin for our database factory, since creating that is again dependent on the platform, since on Android, creating that requires the context, but on desktop and iOS, it doesn't. There we just create a normal class instance. And that is why creating that and providing that for Koin needs to go in our platform module. So here in DI for iOS, we can simply go in here and say single database factory, and that's it. You can copy this. Same thing for desktop, modules.desktop, paste this in there. And for Android, here in Android main DI, modules Android, we paste this. And here we now need the context, which you can get with, I think, application, Android application. Yeah, that is our context that we've previously introduced to Koin already. So if you remember here in book application, here, this is the point where we've linked our Android application class with this Android context. So Koin is able to inject that as well. We can then also go back to our modules. Where was that? Here. And provide our DAO specifically, since that is typically what we want to inject in our classes. So we can say single, and we say want to get our, what is that, favorite book database. And we provide the favorite book DAO, so we can also inject that if we want. So now that we are able to actually create and inject an instance of our database, we can finally get started working with that. So that means, our repository, our default book repository, since that is also what our app will interact with. In domain specifically, so the abstraction, we first of all want to add a bunch of functions. On the one hand, what we definitely need is a function to get all of our favorite books. This will then return a flow of type list of book. So again, our domain model. We don't want to use our book entity in here, since this would couple our domain layer to our data layer. Since book entity is in our data layer, we would have this import on data. So we would have an arrow from domain towards data, which we don't want here. So we instead want to again map these book entities back to our book domain models. That's, by the way, something we need a mapper for, which I haven't done yet. So in mappers, book mappers, we can only convert a book to a book entity, but not the other way around. So we can just copy paste this function and make this also for a book entity to convert this to a book, which would return a book, make this a book. The image URL here was nullable from the book entity, but apparently in the book, it's not nullable. So we might want to change that actually. In book entity, this one apparently doesn't need to be null. There we go. I think we just call the fields a bit differently. Average rating is ratings average. Rating count is ratings count. Yeah, okay. And num pages is num pages median. But that should be all the differences. So we can hop back into our book repository. Apart from getting our favorite books, we also want to be able to observe whether a book is a favorite. So is book favorite based on a specific book ID, which gives us a flow of Booleans. Since this is a flow we need to observe in order to also update our favorite icon, the little heart icon in live. So this flow will trigger in the moment where we mark or unmark a book as a favorite. And actually now when I look at it, these don't need to be suspending functions. Same reason as before, a flow or creating a flow does not require suspending behavior. What does need to be a suspending function is to mark as favorite, where we pass in the book instance, and to delete from favorites, which just requires the ID, which is completely enough to delete something. If we want to mark something as a favorite, this also could return some sort of result, because when we add something in our database, It could always be that the storage is full, for example, which is not an issue when we delete something, but when we add something, it is. So we want to return it as a result of type unit and data error.local this time. And whenever we return a result of type unit, so we don't really have any data that we return, we just care about the error and the fact whether it was successful or not, then we can also make this a so-called empty result, which is nothing else than a type alias, as you can see, for a result with a unit data type. We can then hop into our actual implementation and now start implementing these functions. So Command I, enter, and in order to get our favorite books, super easy, we just say, we definitely need the DAO instance here, private val, favorite book DAO, like this, and we return favorite book DAO, get favorite books, which will return a list of book entities, a flow of list of book entities. And we now need to map this flow, so this whole list of book entities. We now need to take this list of book entities and map every single item again to a book with our mapper. And then we don't have any more errors. Then, whether a book is a favorite or not, we need to return that as a flow. And the way we can check that is just by checking whether there is a book with that ID in our database table. Because every single book we save in our DB is a favorite, otherwise we wouldn't have saved it. So if it is contained in our getBooks query, then we know it must be a favorite. So we can say favorite book DAO, get favorite books, and we now want to map this. So again, this list of book entities, so the flow of list of book entities again, we get these here as well. And we now want to map this to a Boolean whether this book entities list has any element whose ID is equal to the ID we passed. So is there any book in this list from all of our books that has the same ID as the one we passed here? And this will return a Boolean, so we map this whole flow to a flow of Boolean as well, which will just switch when a book is actually being toggled as a favorite or not. Then to mark a book as favorite, we simply need to take this book instance and insert it as a new element in our database table. So since we want to return that as a result, we can say return try. We want to try taking our favorite book DAO, upserting a book, and we want to take our book and convert that now to a book entity. If that fails, it might throw an SQLite exception. On KMP, it seems like there is no SQLite full exception, which was the specific exception that was thrown on Android when the database was full. We just get a generic SQLite exception. So I would just say, if something fails here about inserting that, that will very likely be due to storage, because all the other typical SQL exceptions are rather a hint towards a developer fault. So you have an invalid migration, there is no permission to read this file, your schema is corrupt or so. So all things that we can solve with the right design in the first place. The only thing that would be a user's fault would be if the table is full, if there's no more storage. So let's just say we would take the success case and just return a result of unit in that case. And if something fails, we would return result error, and the error would be data error, local, disk full. And lastly, to delete a book from favorites, we use our favorite book DAO, delete favorite book, and we pass in the ID. That's really it. One little extra adjustment we need to make in this repository, since as I said, the job of a repository is to coordinate the access between multiple data sources, which we have. We have our DAO, which is a data source, as well as our remote data source. And when we now get a book's description, then we can check if there is already a book in our local database with that ID, because then we can just load it from local storage and we don't need to make the API call. So we can say that local result is equal to favorite book DAO, get favorite book by the book ID. And then we can say we return if the local result is null. So if there is no book that we saved locally, there is we didn't mark this as a favorite, then we return the book from the remote API, or rather the description. Otherwise, we will return the local result dot description, but we actually put this in a result dot success. Local result dot description, like this. So that way we really add this offline first behavior that we first try to load this information from our local DB. If it's available, we'll take it from there. Otherwise, we load it from remote. Okay, that's everything for our repository. The next step to finish this favorite functionality is to go in our book detail view model and actually respond to clicks on our favorite button here. Let's do this in here. I think this is not a lot of code. We launch a view model scope, and we also, oh no, we actually already have the repository here, so we can already work with that. So what we want to do here is we want to check if our book is currently a favorite book, because if it is, and we clicked on the favorite button, then we want to delete it from favorites again. So we'll say book repository, delete from favorites, and we pass in our book ID. Otherwise, we say we mark this as a favorite and we pass in the book from our state. This is nullable, I think. So let's say state.value .book, get the book in here, and then remove this thing. So this is one way of our implementation, that if we click the favorite button, we also change that in our database. The other way around would be that if something in our database changes, we also reflect that in our UI. So we update our isFavorite state here. That's something we currently don't do. And we can do this again by just observing this thing, the flow we get from our repository with a private function, observe favorite status or so, where we say book repository is book favorite, pass in the book ID for our book that we're inspecting. And you can then say on each. So whenever that changes, we get the information, whether that's a favorite or not, and we update our state with that information. So state update is favorite is equal to is favorite. Don't forget to launch this whole thing in view model scope. Otherwise, nothing will happen. We can then take this and also call this function here in onStart, observe favorite status. And that should be it for the detail view model in order to change a favorite status of a book. In our list view model, we also need to change something. So book list view model, because here we also need to, of course, display all the books from our favorites. So in here, we might also have a function to observe, private function observe favorite books, which will take the book repository and say, get favorite books. And with every emission, so whenever something changes about our table, we get the favorite books, and we just update our state with these. And we say favorite books is favorite books. We can then again launch this in view model scope. And this specific flow here, we should also actually save in a job. So a coroutine job, just like we did for the search job. I will explain in a moment why. So favorite book job, or observe favorites job, something like this. We then go down and we say observe favorite job is this, and before we cancel this. Because if we then call this here also in onStart, observe favorite books, this should be pretty independent of whether our cached books are empty or not. This might actually be called multiple times, because if we are on our book list screen, then the onStart function will be called. We will start observing and listening to our favorite books. If we then navigate to the book details screen, then this will keep on observing the books actually for longer than these 5 seconds, since that only relates to this flow chain, but not to the flow that is launched in here independently, which has its own view model scope. And since the view model stays active when we navigate somewhere else, we will still keep on observing those favorite books. But the thing is, if we would then go back from the detail screen after more than 5 seconds, this onStart function would trigger again, and therefore add another observer to listen to these favorite books, since the previous one was not removed after these 5 seconds. So we just really need a single observer here, and that is why we make sure to cancel the previous job if there is one. Alternatively, as I said, you can of course also use the init function of the view model, and then you don't need to take care of that. Okay, let's try this. Let's launch this. There we go. It is launching and it is crashing again. Let's take a look why. Class not found exception. Didn't find class favorite book database. Seems like some kind of compile time generation thing. Maybe it is because of an issue I noticed earlier, that we did not add the room compiler dependency because it was grayed out. Was that here? Yeah, the Android room compiler was grayed out. That must be why, and for you probably that did not happen, because I will adjust this in the initial code, but I will quickly fix this. We need to apply this for all of our source sets, for all of our different modules here, for desktop main, native main, and so on. So we can say dependencies, and we want to add a KSP dependency, so the Kotlin symbol processing, which generates the code for room. And here we can say libs n.x room compiler. And this should fix it because we applied the room, the KSP Gradle plugin as well as the room plugin. So doing that should hopefully get rid of that issue that the class is not generated. As I said, similar to the issue earlier, I will adjust the initial code of the repository. So you will already have this. Launch this again. There we go. Now everything is loading, nothing is crashing. We do see our books, that's cool. You can see the arrow is now invisible if it's a white background. Our favorites are currently not existent because we don't have favorites. If we add a book to favorites, we click here, click on that. Yes, it actually toggles. And that means that it must have also inserted that into our database because we only observe that Boolean, whether I want to show this favorite icon or not, we only observe that from the database. This does not originate by clicking on this, but it actually has to be applied in the database to see this. And we should also see this if we now go to favorites. Oops, not that one. Favorites. There is our favorite book. If we turn on airplane mode now, so we can't fetch any more books and we reload our app, we should still be able to see the book information for that. Here something went wrong, but here we do see our favorite book, which we can still open. There's no description, but if we actually mark a book as favorite that has a description, like our Harry Potter again, and take a look in here, then go there. Here we have a big description, mark this as a favorite. We turn on airplane mode, go back, go to favorites, and now we also save this big description. We can delete it from favorites again, and then it will also be hidden here. Very cool, that works. Next up, and the very last thing of this course, will be animations. So I've shown you that before. We have this little pulse animation. We have some navigation transitions that we can add, that we don't have this default fade animation, but rather a slide in animation, for example, for the new screen. And there's also a little animation that I've added here for these book covers when they actually load it. So just in order to show you again what we will build here for this book pulse animation, I will relaunch my sample app here so you can see this for a moment, so you then know what we are trying to replicate. There we go, an unknown error code. Okay, obviously I'm still on airplane mode. Let's turn this off and relaunch the app. Our books are loading, and when they loaded, okay, they were actually quite quick. Here, this pulse animation is what we will build, so you just have an idea of that again. Where do we put this? That is an animation, so obviously part of our UI layer. We could argue about putting that in core presentation, since that is a composable that we might want to reuse across features, even though we don't have multiple features here. Let's put this in there. So we just call this pulse animation, since this composable is really pretty much standalone and not coupled to our book feature. This will be simply a composable called book animation. We'll just receive the modifier so we can align it if we want. And as you've seen, this is really an infinite animation, at least as long as we show this composable. So the way this works is we have a transition, which is remember infinite transition. That is how we build infinite animations in Jetpack Compose. And then we can have the progress that we extract from this transition. So we can say progress by transition that animate float, since we now want to animate a value from 0% to 100%. And depending on that value, we scale up our this little circle that we draw. So we're gonna animate a float. The initial value is 0. The target value you want to animate towards is 1, so 100%. And the animation spec, so how this animation should work, will be a tween. Actually, no, not a tween, but an infinite repeatable, so it should be an infinite animation. We can also Alt-Enter to import this whole thing to get rid of this issue. On the one hand, the animation in here, that will now be a tween. That lets us define the duration. I want to pick a second here so that one pulse flow kind of takes a second to complete. And we want to set the repeat mode to repeat mode restart. So that's also the default. That means if the pulse animation finished one iteration, so after 1 second, then it will just restart from the center again and expand towards the outside. If you would want to use reverse here, then it would go to the outside, back to the inside, to the outside, and so on. That's not what we want for this pulse animation. And the actual animation, we can then just build with a simple box composable, which really just needs a modifier. Or we can then say graphics layer. So this is the typical modifier we use for animations. since with graphics layer, we can change the translation of the composable, so where it is relative to where it was composed. We can change the alpha value, we can change the scale, we can change the rotation with that. And this is just the most efficient way to handle animations in Compose, since if we have this progress, which updates very frequently here, and we use this inside of this graphics layer lambda, this will not trigger recompositions of this composable. So if we would actually make use of something like scale here, and if we would assign the progress here, since this is now considered as a real state that is not used inside of a lambda, this would trigger a lot of recompositions per second. So we don't want to do this, but rather change the scale here, since that won't really have an impact on also on the boundary of the composable. It will really just visually scale this up, but not the invisible box around the composable. So you want to say scale x is equal to our progress, as well as scale y. And we also want to change the transparency depending on our progress, because in the very center of our pulse animation, we want to have a very high alpha value, so we want to have it fully visible. And the more we transform, or the more we move with this pulse to the outside, the more we want to fade out the alpha value. And this works by saying alpha is equal to 1f minus progress. So this means the progress which starts at 0 will therefore result in an alpha value of 1f at the beginning of our animation, so at the very center of the pulse. And if our progress then animates towards 1, that means this will result in an alpha value of 0, so to the end of the animation where our circle is at the edges of this composable, then it will fade out that way. In order to really give this also a visual look, we want to give this a border, so this will simply be our width of 5 dp. This will be our border, the yellow circle that expands. We want to give this a color, which is our sand yellow. And most importantly, the shape should be a circle shape. And this should already be everything we need in order to draw such a pulse animation. So if we want to now draw this in our book list item, here book list item, scroll down to where we are currently using the circular progress indicator when there is no image load result yet. Here we can then use the pulse animation instead and give it a modifier to give it a size. Since I think, we did not use weights weights for this box, so it does not have a fixed width, I think. So we should just give it a fixed size here of modifier size 60 dp. The same thing we can then apply in our book detail screen if the image hasn't been loaded. In here, book detail screen, where's our image? It's actually in the blurred image background. Here, I don't know if we are actually already drawing the circular. Yeah, here's the circular progress indicator. So here instead, we want to use the pulse animation, again with a modifier size 60 dp. And if we launch this that way, we should already be able to see this result. There we go. We are loading our book covers. And now when I try to show this, it loads instantly. But there it is. Here's our book pulse animation. If we click on that, and then we also see it here. Oh, we actually need to center it. And that also looked a bit weird. We probably need to give our card some background before the cover has been loaded. And we need to make sure that the animation here is also aligned in the center of our box. Are we using a box here? No. So we need to use a box. Need to cut this out, have a box modifier, give this a modifier of fill max size, and to center this content alignment. And in here we can then put in our pulse animation, and let's also switch this to, I think we don't need to specify this at all, so it would just default to white or so. Let's try this again. So there we go, it's loading. Scrolling down a little bit to some kind of cover that hasn't been loaded. They load so quickly because they are already cached, but here's one. Yeah, now it looks much better. We're loading the book cover, and when it's available, there it is. The next little animation I want to add is when our book cover has actually been loaded, that it just rotates in a little bit and also fades in. We can also do this in the book item. Where is it? Book item, book list item. There it is. Here below where we specify our painter, we can actually observe the painter state. So we can say painter state by painter.state, and we collect this. So it's a state flow. We collect this as a lifecycle, and then we can also use this to check whether that was successful. And in that moment where we switch from loading to successful, we want to animate the book cover. So we can say val transition. This time it's not an infinite transition because it's just a one-time thing we want to animate once the book has been loaded. This transition can be by animate float as state. Here we need to pass a target value, which can switch depending on a certain other state. So we can say if painter state is async image painter dot state dot success. So once that switches to successful, we want to animate the target value to 1f, and before we leave it at 0. And we can also give this an animation spec again of a tween, and duration millis is, let's say, 800 milliseconds. And then we can scroll down to where we load and show our image, and again make use of graphics layer to add this animation. So since I want to have a little rotation effect here, where the book cover rotates from the inside of the screen towards us, we need to think about the right rotation axis that we need to work with here. So specifically, we need to rotate this around the x-axis, which is the horizontal axis. Since if we rotate around that axis, it will rotate towards us. So we need to use this rotation x value. And we want to set this to 1f minus our transition value multiplied with 30f. So initially, our rotation should start at, in this case, 30 degrees. So it should be rotated 30 degrees inside of our screen. Since our transition starts with 0f and animates towards 1f, we again get that same effect, that 1f minus 0f would start off the animation with 1f multiplied with 30f, so 30 degrees of rotation. And as this transition then animates towards the value of 1, we will get to a rotation of 0 here. Same thing we could also do for the scale. So scale x, actually put that scale in some kind of variable here, where we say 0.8f plus 0.2f multiplied with transition. So that means we start with 80% of scale and then add our remaining 20% over the course of our transition. So scale x is scale and scale y is also scale. If we then launch this, we should already be able to see some results. We'll probably need to execute a new search so we get some new books. Oh no, we actually already saw that. You just saw how these books animated in, but if we now search for something we did not search for before, for example, Aragon is, then we load with this pulse animation. And after the book covers have been loaded, we hopefully see some animations. There it is. All of these books are kind of rotating in. And another last animation that we can very easily add to our app is just a slide animation. When we click on a book that we navigate to this detail screen, we can do this in our nav graph. This is very easy and supported out of the box by Compose navigation. Because for each and every composable we have here, we can define this enter transition. So the animation that should play when this composable enters the screen. Actually, for this one, we don't even need this because this never really enters the screen since we never navigate directly to this book list composable, but we rather get back to it. So we rather need an exit transition, which is nothing else than a lambda. And here we can say slide out horizontally. Oops, horizontally, this one here. So this will actually play. So the exit transition of the book list screen will play when the book list screen exits our composition. So when we are on the book list screen, we navigate on another screen, on our detail screen. Then during that transition, this book list screen will exit by sliding out horizontally, by sliding out to the left. The same we need to do for the pop exit transition, actually the pop enter transition. So when we pop the backstack, so we are on the book detail screen, we pop the book detail screen from the backstack and then get back to this screen, then it will enter by sliding in horizontally again. So we can say slide in horizontally like this. And for the detail screen, it's exactly the other way around. Here we want to have an enter transition, which plays when we navigate to the detail screen. Here, this should slide in horizontally when we navigate to it. And the exit transition should slide out horizontally, actually inside of a lambda. If we try this and take a look here, there we go. If we now click on something, okay, that's actually, something is wrong here. Should be the other way around. You can see this is not exactly what we want. We probably need to go in here and make this a lambda, give this a name of initial offset and map this to an initial offset. Let me quickly try this. If we have this lambda for this one here as well and launch this again, here it is, we click on a book, and yes, that looks better. So we slide in like that, slide out like that. So what this initial offset here means is that it's just an alternative overload that we can pass the initial offset x, which by default you can see is set to minus it divided by 2. So it is the full width of this transition. And by default, it starts at half that full width to perform this transition. But we want to start at actually the full width, which is why we return the whole full width here in this lambda rather than just half of that. And that way we get exactly this transition here, which I think looks pretty cool. Okay, I think that's the app. What we of course didn't do till now is running the app on our other platforms. We've so far only ran this on Android, but we of course want to try this out on iOS as well. So if you actually have a Mac and you're running this on a Mac, then you can try this out on iOS. It is pretty simple. So on the one hand, let me minimize this a little bit. On the one hand, in your directory, you will find this iOS app folder, which contains the Xcode project, the Xcode workspace file here. You can right click to open this in Xcode. So this will really just show up if you're on a Mac and you have Xcode installed, and it will show up here. This is Xcode, the typical iOS and macOS environment IDE. And you can see here we really just have this iOS entry point in Swift, where we call this main view controller we've worked with in our shared code. You'll notice that sometimes it complains about that it doesn't find this Compose app module, but once you actually build this, it will find it. You don't even need to open Xcode, by the way, to run this app. I just wanted to show you that we do have this file, but we can also go up here to Compose app, click on iOS app, and then it will run this with the emulator, or it's actually called simulator on iOS, that you've configured here. So in my case, iPhone 15 with this iOS version. If we run this, I actually have the simulator open here, but Gradle is still building. Building the iOS application failed, okay. And wrong here. Did we get an actual error? Doesn't seem so. So tooling is definitely something that KMP can improve at, because it doesn't really show an error. Oh, I'm just blind. Here is an error. The database class must be annotated with constructed by. Oh, that is something I forgot. In our database, we have the database constructor, and we need to link this to our database because by default, Room doesn't know which specific DB this is for. So in our favorite book database, here, we need to annotate this with database, actually constructed by, and we say book database constructor. So apparently this is really just for the other platforms, because for Android it worked. If we relaunch this on iOS that way, we can check this another time. Yes, now something is happening. That is looking better. Our app is launching, and we see our app on iOS. There it is. We do see all the animations. Our books are loading. We have favorites, obviously on iOS, not yet. And we can scroll through these things. If we click on that, then, oh, no, it did not crash. Some kind of error happened here. But apparently nothing critical because our book was loaded. It is a little bit laggy, but probably because of it's a debug build here. But now once we've transitioned, you can see now it's much more fluent. Something we do need to adjust a little bit for iOS specifically is you can see the status bar here is white. Would look much better if it would also have our darker bluish color. But this is a super quick fix. For that, we actually need to go to Xcode. And here you can see we have this Compose view. We ignore the save area, which is pretty much the equivalent to window insets on Android. But it just ignores the keyboard save area. So we can just say we want to also ignore the container save area, which will also correspond to the status bars. If we relaunch this and then take a look here, you can see now we actually get this as a blue headline as well, or status bar, which looks much more natural. Okay, iOS works. Let's try desktop. We go to our desktop main, where we really have this main function. That's also always the entry point for desktop programs. You will notice, at least as of now, if we run this here, we will get this main KT file class wasn't found. Till now, I haven't figured out a way to really run Compose desktop applications here from this play button. Also, if we run it from up here, it will face the same issue, but it will work if we actually go to our terminal and run this manually with a Gradle command. So if we say /Gradle w run, which runs the same task this would actually run here. If we click there, you can see it actually builds and does not immediately give us this issue. And now it launches a program over here. It's loading our books, and we do have a working desktop app as well. Obviously here we can't swipe, but we need to scroll. Very cool. If we click on something, and we also get this transition here, you can see this is a little bit off since a desktop has such a wide window. So it focuses here on this red part, but I think this is really not an issue actually. If we search for something else, like Aragon again, then here we are. We have Aragon, click on that, we see our animation, and once it loads, we will see something. Probably because we load that many images at once is why it sometimes takes a little moment for an image to load. But other than that, here we have our Aragon book, and that works. That works. So if this course was something where you say, "Ooh, I really learned a lot with that," then I don't know at this point how long this video will be after editing, but I would guess probably around 3 or 4 hours. And if you say you've already learned that much with this free video on YouTube about Kotlin multi-platform, maybe about Android, maybe you're also an Android developer like I am, and you now just get into Compose and Kotlin multi-platform. If you say you learned that much with a 3-4 hour video, then really check out my Android Essentials bundle. While it's not a Kotlin multi-platform course, this is still the knowledge that you learn there about architecture, about multi-modules, about Gradle management, Gradle config, about Jetpack Compose, that is completely applicable as it is to Kotlin multi-platform projects as well. And that is a 23-hour course bundle. So guess how much you will learn in that. They will really build a real bigger app with, I think, 6 screens rather than just a simple little detail screen as we did here. All these courses really have a 30-day money-back guarantee. So even if you say you're unsure whether these are right for you, if you get these and you say, "Philipp, that was not it," then you will get 100% of your money back within 30 days. So down below, you will find links to that. You'll also find links to my Coroutines Masterclass, which we heavily made use of the knowledge in this course here. And other than that, thank you so much for watching this whole thing. I know this was long. I really hope you could learn something. And if you want more such Kotlin and Compose multi-platform content here on my channel in future, then please let me know that down below. If you maybe have a specific project idea that you want me to make a video about, any specific Kotlin Compose multi-platform topic that might not be building a full project, but just a part of that maybe, then just let me know that down below. Thanks so much for watching this thing. I know it was long. But I will see you back in the next video, at least if you've left a subscribe. So if you're not subscribing, then do that now. But then I will see you in the next video, which I publish 2 of every single week. So thank you so much. See you back. Bye-bye.